Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best. Hello, everyone. Thanks for your enrollment. You can go and enroll my courses over Udemy. You can go and subscribe me over YouTube as well. But either Udemy or YouTube, whenever you're watching my courses, obviously you are looking for the documents. So what I have done, I have created this giganetworkers.in blog site where I created different menus related to different courses that I have at various platforms. So for example, if you're looking for CCNP SD-WAN document, you can go here inside Cisco CCNP and can see that you have CCNP SD-WAN. You can go and click there, and then you will get all the documents related to CCNP. So once you scroll down here, so not only that I have uploaded the documents here, but you will get the video link as well. Otherwise, I can't fix this. Remote AS, no shutdown, neighbor, and IP address. So seems the configuration is correct. I need to give the password here. So I'll go here, router BGP, and then my neighbor. So what neighbor I have? 120.3, and the password let me give the password is SD-WAN. Go out here, we'll see show IP BGP summary. Still it is in active state. So from this side everything is correct. Now router 3 configuration for BGP is correct. We don't have any problem. If any issue I have to go and check the VH2. Okay. So we'll parallelly map this as well. So let's go back to our original configuration. And I will stop the monitoring. So let me do monitor, stop. And yeah, let me stop the monitoring. But we have enough log messages that we can see that what it tried to do here with the BGP debug. So let's see that what configuration we have given. So we have given that configuration that is my BGP correct, router ID correct, address family is also correct, neighbor is also correct. Let's verify.
show IP BGP. Show IP and see that we have option or not. Okay, show BGP neighbor VPN 1. So established, here it is showing established. Show IP BGP summary. Now it is established. So now you can see that the neighbor has been established. It was broken due to the key after the initial configuration. Now if I see that do I am getting BGP routes or not. Let's see. Now I am getting the BGP routes as well. So that's good. Inside VPN 1, I am getting the BGP routes. These are E as the eBGP routes. So okay, up to this point I am receiving. Let me go to the data center 1 and let me see show IP route BGP. I am getting BGP route or not. Nothing is coming. So why nothing is coming? What is happening actually that whenever we are talking about any of the service routes that is coming to my network, how it will come. So suppose I have one device here, let me draw. So I have one device here that is VE, for example, branch 2. Now it is connected with router number 3 and router number 3 is sending BGP packets to him, but this is inside VPN 1, correct? Now this VPN 1 inside the Viptela fabric, whatever devices I have inside that device, either it's a DC or branch, VPN 1, these BGP routes will go. Why? Because this device will advertise to VSmart and VSmart will work as a route reflector. It will reflect those routes to other sites. Correct? So we need to fix that we are doing any type of redistribution or not. That's very important. So if I go here, if I check show run OMP, you can see inside OMP, I am not advertising BGP. So once I advertise BGP inside OMP, that means now my VSmart controller knowing those BGP routes, and then it will reflect to all the devices. Correct? So I can see that is still that DC1 is not receiving BGP routes, or maybe some issue with this device. Let me go and log to other device. I just logged into vManage to log into any of the other device. So I'll do show control connection. I just want to SSH to any of the device, any of the vEdge. Here I can go to 175. So let's check 5. Okay, and we'll verify that what is the thing that we are checking, because that is very important. Now this is DC2. If I check show IP route BGP, here also we don't have BGP. So technically that BGP route that I have to receive, is it a BGP route or is it some sort of encapsulation and I'm getting? So technically what is happening, say when any of the device, when it is getting BGP from any of the service VPN, then it will send to the VSmart, because inside OMP I am advertising that. Now when OMP or when the VSmart will advertise to any of the device, it will advertise as a OMP route. It will not advertise as a BGP route. Correct? So we know that what is the prefixes that is coming if I go and check show IP route OMP, let's see. Do I have 13? Yes. You can see we have this 13, 13, 13 route. We have these 10 routes over both the transport, and these routes are OMP routes. So even in the DC1 also, if I check show OMP routes, or if I check show IP routes, you'll get this 13, 13, 13 routes. Okay, so this testing has been successful. We have successfully established the connection, BGP connection between this and this. Now if I go to router 3 and if I check show IP route, show IP say BGP. So these are my own routes that I am sending to router 3, but I am not receiving any route from the VE side, from the VH side. So for that, what we can do, we can go to say VPN1 and then say router BGP, whatever AS number we have. Let's see that can we do redistribution here. So if I type question mark, do I have redistribution option? Or I have to go inside address family IPv4 unicast and then I can do redistribution. Yeah, so I can do redistribute OMP, correct? I can do say redistribute connected. Now if I go here and now if I check show IP route BGP, let's see show IP route. I am getting any route here. I am getting routes. BGP is slow protocol, so it will converge late. I should have routes, you can see. So now I have routes 2291, 105, 136. Okay, and those routes are related to show IP route VPN 1. So we can see 2291 and we can refer the our topology diagram as well. So 91 is coming, 105 is coming. So 91 is coming, 105 is coming, 136 is coming, 136 is coming, and we can see. So now we have plenty of routes and we have successfully done a redistribution of BGP as well. So from the service side BGP to the V edge, from that V edge it is going everywhere. Okay. Now the next target we have is to prefer these BGP routes towards the data center. So for that obviously we need to create policy. Let me hide this or let me fix this. Now for that I have to go inside VSmart and then I have to check that how I can do that. So let's go to the VSmart and I want to SSH to VSmart, that is 1.3, correct? Yes, let's go inside VSmart. Let me increase the font size for the VSmart as well. I have increased the font size for VSmart and let's do it. So what I'll do, I'm going to create control policy where I want to select this BGP route. So how we can do it? First of all, let's go here and create the prefix list. Okay, say BGP routes, and what BGP routes we have, we'll give that. So that actually I want 13 routes. So 13, 13, 13.1 and then 2 and then 3. Let's take only 1, 2, 3. These three prefixes. Rest 2 routes, we'll see that how it is going. So we have these prefixes. Now I'll create say site list all DC and here I will give the site ID for the data center. What is that site ID? It is 20 and 30. So we can refer. The site IDs are 20 and 30. So I'll give 20 and then I'll give 30. Alright. Then I'll create one more site ID because what I want here that the branch, I want to apply these rules to branches. Okay. Or how we can do it. So what will be the strategy we have? Let's discuss that. What I want to do here. I have data center 1, data center 2, I have branch 1 and branch 2. So all these BGP routes, what I want that DC1 and DC2 will prefer. Okay. So what I can do, I will apply the policy for say branch number 2, BR2, and so what we can do here, we may have different strategy to do this. So I can do this, say I can create policy, say for branch number 2, where I will match the site list, match the VPN list, match the prefix, obviously with the route. So route of branch 2 will match these criteria, and while applying, I will apply to branch. So I will apply to DC, actually all DC. And here what I will do, so routes of branch 2 will have preference, higher preference value towards the data center. Okay, so let me do this, then you will understand what I try to explain here. So let's do it. So I have all DC, and then I'll create one more site, say branch 2, where I want to match the BGP routes. So for branch 2, we have site ID of 100. We'll go to top, we'll check the configuration, what we have done. So I have list all data center, one of the branch, and then the routes, correct? I'll create one more list, that is VPN list. So policy and then list, say VPN lists, VPN 1, and that VPN is actually 1. Commit this. Great. Now we have to create the policy. So my control policy name is BGP DC prefer. BGP routes toward DC, we have to prefer. I'll go to sequence number 10. I want to match the route of the site ID, say branch 2, and that should be site list, branch 2, and the VPN list we have, what VPN we have? VPN list of VPN 1, and prefix list of BGP routes. Let's see what configuration we have. So what I'm telling that, okay, match route for branch 2 for VPN 1 for these prefixes, correct? And then we have to take action. So action, what I want to do here, action accept, set the preference value, say 500, and then we have service TLOC action, TLOC list, OMP tag. I think that is okay. So we are setting this, and then I will go to the default statement, and the default statement will give, say default action is accept. Okay, I'll go to top. Let us see that what configuration we have so far. So now we can see that, okay, we have one policy for branch 2 VPN 1 BGP routes. I am giving high preference to that, and the default action is accept. Alright, now we will apply this policy. Apply this policy to site list with all the DC. The control policy name is BGP prefer in the egress direction. Validate this, commit this. Wow. Let's go to DC1. Now if I go here, if I check show IP route, and even we can see VPN1 as well, because we are specific to VPN. So all these VPN routes, say 1313, 123, 123, 123. So I should go to branch 1 as well. So how my branch 1, they are getting the route. So we have applied this policy, and I want to open one of the branch. So from here only I can open. Let me end this session, exit, and we'll go to one of the branch, that is branch 1. So for branch 1, what is the system IP? Let's see. I can see from here branch 1 system IP. Branch 1 system IP is branch 1.4. So 1.4 admin show IP route VPN1. I'm just focusing that these routes that I'm learning, this is coming directly to, that's okay, OMP IP is 1.7. So let's just stop here, and we'll continue this thing. We'll do more traffic engineering in the next recording.
Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best.
Let us continue where we left off. So now I am checking the BGP routes and their preference value in branch 1 and say all the DC. So I'll go to DC1 and DC2 and I'll check that. Now here if I go to branch 2 also. Okay, if I go to branch, say DC1 for example, and if I check show OMP routes, you can see here the VPN, the BGP routes, it is coming obviously via OMP. So what we can do here, we can check show OMP routes, say for VPN 1, and you can see that, okay, I'm learning the VPN routes, but few of the routes that we have set the preference value, that is 1, 2, 3. Preference value is 500, means it will be preferred. These routes will be preferred. If you want to know more about this, then you can give this prefix as well, show OMP routes, and then the detail. So now we can see here that, okay, I'm learning this route received from 1.3, that is the vSmart, path ID, the label ID, the status, and then who is the originator, 1.7, MPLS IPsec, and site ID, the preference value. So this is the originator information. It's the eBGP routes received from. So who is originating, from where I am getting, and then the attributes again you can see the originator. So we are getting from two paths. One is the gold IPsec, one is the MPLS IPsec. Obviously we can filter out whenever we want it, and the preference value is set, and here also higher is better. Now if I go to, say for example, branch number 1, and if I check show IP routes VPN 1, and we can give this as well. Actually I will check OMP route, but let's see this as well. So if I go here, okay, OMP, all these things, say protocol is OMP, we have two paths. Now what I'll do show OMP routes VPN 1, and then I will give that prefix 32. Now you can see that preference is not set. Okay, tag is also not set, and that was the result that we have done. And now suppose if you want, so again this is other use case that we can use here, and that will be again different use case, because by default we know that they are in full mesh. But if you want to break this full mesh, if you want to make this as a hub and a spoke, then what we can do, that this particular IPsec tunnel we can invalidate, and then we have either this type of topology or this type of topology. So any route that is going towards the any of the branch for a branch, so that will obviously go first to the data center and then go to the other branch. Go first to the data center, then it will go to the branch. Again here also we can set the preference value that I am preferring DC1 or DC2 for these routes. Okay, so all these options also always available for us. So we are very good with this section. Let's close then.
One of the important section we have is section 4, where we have to learn about various type of policy. So we have control policy, we have data policy, we have centralized policy, we have localized policy. Now you'll come to know in upcoming sessions that control policy is nothing much that is very much close to routing policy, or you can tell control policy is routing policy. Now this control policy that we are going to build over VS Smart, that is going to provide us full capability that we can do routing manipulations, traffic engineering, service chaining, etc. Means we can play around with routing capability inside SD-WAN. The next piece here is the data policy that will provide us the capability to do the application aware routing, and that's quite a big topic we have. So here you can see that section number 4.4 is application aware routing, and that's actually something that the success of SD-WAN will depend upon that how we are going to implement the app aware routing policy. Later, suppose if you are using the SD-WAN firewall features, then we have this option that we can provide application aware firewall policies as well. Now, going forward, what we are going to do, let's break this big policy section at least into some part. So we are going to discuss starting with 4.1, where we'll discuss about the control policy, data policy, and then we have several examples. So for example, if you want to block or allow certain prefix, if you want to use hub and a spoke strategy, means your branch traffic, they are going towards the data center, that's your hub, and then it is going some other place. You have various strategy to use this hub and spoke policy. Then you want to use the VPN segmentation. Now this VPN segmentation, it's very interesting here to point out that the overall SD-WAN solution by default, it is supporting segmentation. So that means you have VPN 10, you have VPN 20, you have VPN 40. VPN 10 you are using for corporate traffic, 20 you are using for PCI, 40 you are using for guest. or you can have VPN trusted, VPN untrusted, VPN guest, VPN third party, etc. Means you can segment the traffic as per the category of the application traffic, or the maybe there are different ways that you can segment the traffic. Now once you segment the traffic, then that segmented traffic, are they going to support multiple topologies? So if you see section number 4.3, this is telling something that, okay, you have segmentation. Now do these segments are going to support multiple topology? So what does it mean? It means that is VPN 10 can do hub and spoke, and 20 can go towards firewall, and then it can go in or out. Do my VPN 40 directly go to the internet, etc., etc.? Answer is yes. So these type of labs you will see in the upcoming session. Now once we complete that point, then we'll go and complete app, route, and direct internet access. So let's start with the policy, and this policy, that section 4 you're seeing here, they have 20% weightage for our CCNP SD-WAN exam. Viptela policies are one of the key components inside the SD-WAN Viptela fabric. So what type of policies we have inside the Viptela? Let me draw that. If we go and see that the policy type, we have basically two different type of policy. So first policy is control policy. You can create control policy, and the other policy type is nothing but the data policy. Now again, this control policy we can divide into two different parts. The control policy, that is nothing but the routing policy. It can be centralized, it can be localized. Likewise, the data policy can be centralized, it can be localized. Great. So what's the example of the centralized policy and localized policy with respect to control plane? The example for centralized policy is, say, control policy itself. So control policy, name control policy is a centralized policy. Means globally I can take decision related to routing updates and routing policy. The localized policy, good example is, say, route policy itself. Whenever we go inside the routing protocol, so for example OSPF, we can create some route filter, route policy. That will be the local. That means that you are pushing this policy with the template, with the device template. And these policies you are sending, say you can build this policy from vmanage, vmanage will push to vsmart, vsmart will push to vh. But these policies directly you can attach with the vh from vmanage to vh. Okay. Then you have centralized data policy. Centralized data policy, data policy name itself is a centralized data policy, or you may have app route policy. So let me draw here. What's the example of, say, data policy? And then you have two variation. One is the centralized one is the localized one. Now centralized policy example is data policy itself. Then we have, say for example, cflow template. That is nothing but the type of net flow that we use to build inside Cisco devices. We have very important policy, that is app route policy. App route policy is also a type of data policy, centralized data policy in this particular central policy. Again, in localized policy, you may have quality of service, you may have ACL, you may have mirroring. All these things will be part of the localized data policy. So this is the policy, this is the type of policy actually we have inside the SD-WAN. So inside policy, what you have control policy, you have data policy. Inside that again you have central policy, you have local policy, you have central policy, you have local policy. Correct? Now one by one we'll go inside the policy and we'll see that how it look like, what is the structure, how we can build and apply. So let's start with new topic, that is what are the components of
So components of policy. So the policy actually has three components. First of all, to whom you are writing the policy, means which is the traffic, what is the traffic class, or what's the traffic, what's the interesting traffic. Then the second portion is policy itself. What's the policy definition? Is it a control policy, data policy, app route, etc. And the third part is apply policy. So once you build the policy, how you are going to apply the policy. Correct? Now start one by one. The first part, that is nothing but the interesting traffic or list. You can create list related to all the things that you want to do, means for whom you're writing the policy, to whom you're writing the policy. So list can be, we know that we have different type of component in SD-WAN. So we know that we have site component. We know that we have other things as well. So we know that we have VPN component in SD-WAN. We know that we can define the TLOC. We have color. We have, say for example, prefix list. We have data prefix list. And one of the very important thing we have is the application. So with all these components, say for example, I can create site list, I can create VPN list, I can create TLOC list, I can create color list, I can create prefix list, data prefix list, app list. Okay, so these are the interesting traffic we are writing the policy for. Then the next portion we have is that policy definition. So what is the policy definition? Means what type of policy you have. So we may have control policy, we may have data policy, we may have app route policy, we can have cfload policy, we can have VPN membership policy. Like that we have policies. Now whatever policy you have, so for example control policy or data policy, what is the structure, what is the construction of this? So first of all, you go inside policy, type policy keyword, go inside the name of policy, so for example control policy, and then give the name. So for name, for example, A, B, C, D is the name of the policy. Then you have to go inside the sequence number, you have to match. So suppose it is a control policy, I have to match the TLOC of or route. Once you match the TLOC or route, you can match say VPN, you can match the prefix list, you can match the other attributes. Then you have to take action. So action may be accept, maybe reject. Maybe if you want to do some other stuff, we'll see later on, you can set some rules as well. But in general, match action. Like that you can create sequence 10, sequence 20, sequence 30, etc. And by the end of day you have one default action, and that default action will be reject by default, that you can go and accept. So this will be the policy construct. When we'll do the lab, we'll understand more about that. And final, the third step is apply the policy. Now when we are applying the policy, it is 100% of time with respect to site list. We are always applying the policy with respect to site list. So site list, for example, AB, then you call the policy, so for example control policy that we have created ABCD, and then you have to give the direction. Direction means either in or out, and later we'll discuss more about the direction and what's the direction in control plane policy, data plane policy, because control plane policy direction may be in or out, but data plane policy direction is bidirectional. So control policy direction is unidirectional, data plane policy is bidirectional. That we can discuss. So this is the overall policy construct. Let me quickly revise it. So you have policy. Your policy can have types, a control policy, or it may be data policy. In control policy, it can be centralized, it can be localized, same centralize and localize. Then either it's a control policy or data plane policy. You have to define the terms inside policy. So if I go inside policy, I have to define what is the list, what is the definition of policy, and how we are applying the policy in which particular say site. It's always with respect to site, but in which particular direction, in or out, etc. So once we know all these factors and facts, let me quickly walk you through the slide. You can see here the policy, centralized, localized. Then the construct of that policy, control policy, data policy. Then you have to define the list policy and you have to apply that policy. You can see the framework here for the policy. Define the traffic, define the policy type, apply the policy. So once you apply this, again we'll see that what's the direction in the upcoming recording. I'll explain more on this, what is the direction. Once you apply the policy, then that's done. So let's stop here at the moment and we'll continue our discussion in the upcoming section. Let us continue and discuss more about the architecture of the policies and the policies. So now you can see that we have the direction inside the policy. What does it mean by direction? So directions, I have my vSmart here. So I have my vSmart. My direction will be into the vSmart. This is the in direction. And then it can be out of the vSmart. So when you are sending the traffic from one vEdge to vSmart, that will be the in direction. When you are sending the traffic or the update from vSmart to vEdge, that is the out. So the traffic that is coming or the policy direction that is coming from vSmart to vEdge, that is the out direction, and if you are sending the policy from edge to a smart, that is the in direction, into the vSmart and out to the vSmart. Alright, so apart from that, if we go and discuss the, okay, although you told me that there are two policy, one is the control policy and one is the data policy. So what will be the fundamental difference between the control policy and the data policy? So let us discuss that what is the fundamental difference between the control and the data policy. Say control and data policy, we should remember these three terms, CAE. C stands for configure, A stands for, say for example, apply, and E stands for execute. So execute. Now what is happening here, that if you configure, apply and execute the policy at the level of vSmart, that will be control policy. But if you do the configuration and apply at the level of vSmart, but the actual execution will happen at the level of vEdge, that will be data policy. And since it is a data policy, it will be downloaded via the vEdge. So vEdge device will go and download that policy inside its local cache. Since it is a control policy, so the update will send via the vSmart, either in and out. So now what is the difference between the control policy and the data policy? So let me list out the difference between the control policy and data policy. Say CAE will happen at the level of vSmart, CA will happen at the level of vSmart, but E execution will happen at the level of vEdge. This will reside, the policy will reside at the level of vSmart. This will be downloaded by vEdge. Okay, then this is unidirectional, either in to out or out to in. You need two policy, that means, and this is bidirectional. So one policy will be applied in both the direction. Okay, so these are the main and fundamental difference between the control policy and the data policy. Let me go through these slides. So here clearly you can see that if it is a data policy, the execution will happen at the level of vEdge. So that's why your app route policy, your cFloat policy, your data policy are data policy. But if you are doing the configure apply execution at the level of control plane, then those are the control policy. So control policy and VPN membership policies are actually control policies. Then what about list? We have discussed about the list. So if it is a data prefix list, this will be used inside data policy. If it is a prefix list, it will be used inside the control policy. Then we can create site list, TLOC list, VPN list. In the policy section, one by one we'll create the policy and we'll utilize that. Again, you can see the architecture. If you are in the individual policy, go to the sequence number, match and take action. So remember this MAD, match, take action and the default action. So you are in the sequence number, then you are matching, taking action and then the default action. By default, the default action will be reject. So how you can go and create the policy, what are the construct of policy, how it look like. So here you will see your policy has three portions. Inside policy, you have to define interestring traffic. So you have to define the list, that will be part 1. Then you have to go and define the policy construct. So what's the policy name? Call those things match, take action, default action. So that will be part 2. And third part, that you have to apply the policy. It's very straightforward. So let's do one thing. Let's take one example. And in that example, what I will do, as per our given diagram, I will go to branch number 2. I will create one loopback 77 here, and that loopback, at the moment I'll go and create loopback, say inside VPN 10, automatically that loopback address will get advertised to all the data center devices, to all the branches devices. So what I want to do here, I want to create one policy inside, say this is branch 1 VH2 actually. So inside branch 1 VH2, second router in branch number 1. So in branch 1 VH1, you have to create one loopback with the IP address. At the moment you will create the loopback with the IP address, we know that inside OMP there is default configuration advertise connected and advertise static. So automatically this will get advertised to VSmart. VSmart is working as a route reflector. He will send to all the devices, correct? So what I need to do here with the control policy, all the devices in the fabric will get this 77 network except branch 2. Okay, so how we will build that policy? What you need to do here to build this policy, you go and create first of all the list. So you go and create list, say you should create prefix list, and that prefix list contains 70, 70, 70, 70. I will show you in the lab. You should create VPN list because you want to apply the policy over VPN 10. You should go and create the site list because you want to apply the policy always with respect to site list. So this will be your interestring traffic. Then next, what you should do, you go and create the policy, define the policy, control policy. In control policy, go to sequence number 10, match the route with certain VPN, say VPN 10, with certain prefix list, say 77, and then take the action as a reject. Then go to the default action and accept rest of the traffic. Then you go and apply this policy to only branch number 2. So these are the steps. Let me stop here, and in the next section I will log into the devices and I'll create this policy. Alright, so in this lab, what is the agenda we have? That we are going to create the policy to block certain routes to get advertised, correct? So if I go to branch number 1 VH number 2, and let me show you the configuration here. So in this I have one interface. So here you can see I have one interface called loopback77 whose IP is 7070.70.77. That is inside VPN number 10. So I can show you the configuration. You can see the configuration inside VPN 10. I'm advertising this loop back. Since I'm advertising this loop back, this by default the vSmart will send to everyone. So if I go here to the device list, suppose if I go to first of all branch 2 VH1, and if I go and check that route, even I can go to DC VH1 as well. Both the places you will see that this route is coming. So if I go here and check show IP route, and that route is nothing but related to VPN 10, I could filter that and I can show you there. Here you can see it is coming to the DC. Likewise, if I go to the branch 2, let me go and log in to this particular branch. So here you can see. So let's see this show IP route and VPN 10. So inside VPN 10 I should see that 70 network, and if you further want to filter this and see this, what you can do, show IP route, and you give this specific network. So it is coming here. What I want to create a policy. After that it will not come to branch 2, but it should go everywhere, correct? So let's go to the policies, configuration and policies. Inside that centralized policy, I'll go and add it. So here you will see in the policy building, in policy construction, you have 4 things on the top. Say you have to create the interest or group of interest, that is nothing but list. You can see list for application, color, data, policy, prefix, site, SLA, TLOC, etc. Then the second option that you are seeing here, configure topology and VPN membership, that is nothing but control policy option. The third thing here, configure traffic rules, that is nothing for data policy. And then finally you need to apply always with respect to site. So what we are going to do here, that I will go and create first of all prefix list, because this is a control policy. So I'll go here and I'll create one prefix, say block 77. I'll give the prefix 77.77.77/32. Add this. Then what I want to create one VPN called VPN 10. So I'll go here and create, say for example, VPN 10. The ID is 10 because I want to create the rule with respect to VPN 10. Here in the bottom you can see I have VPN 10. Then I'll go and create site called branch 2. So I'll go here and give, say, branch 2 new, and the site for branch 2 is nothing but 400. Yes, so now I have all the interesting traffic for my policy. I have VPN, I have site, I have prefix. I'll go next. The next page is related to control policy. I want to create custom control policy related to route and TLOC. The name I will give, say for example, block, say block 77, and the description to say block 77 prefix from branch 1 to branch 2. Like that you can give any meaningful description. Then I'll go to the sequence type. I want to match the route. Yes, I want to match it. And what you want to do with this? First of all, I want to match the prefix list. What's your prefix? So I need to scroll it a little bit. Let me give some space here. So I want to match the block 77, that's true. Then I want to match the VPN 10 that just now I have created. So let me scroll down, VPN 10. So these two things I want to match. Do you want to match any site I want to match the site, but when I apply this, even I can match the site also. This route belonging to which site? This route belonging to site number 1, whose site ID is 300. So suppose if you haven't created the list, you can go and create here. There is no problem. I can go click here. I can create the list. Say for example, branch 1 list or site, whatever name we can give. So branch 1 list, his ID is 300. Click save, and now I can call that. So I'll go here and call branch list. So now you can see that with the VPN 10, with the site 300, with the root that is the prefix 70 70 77, I am matching. So what you want to this match? Once I match this, I want to take action. In the action, I want to reject it. Correct? You want to reject it. That's the policy. So yes, that's the policy. And before saving this policy, I can give the name here. Say block loopback 77. You can give any name, logical name. Block loopback 77. Save the match condition for this statement. Then I'll go to default action. Here I should give except, otherwise it will block everything. Correct? So once I have my policy, I'll go next. This particular, okay, this is the same policy, control policy page, but the next page, this particular page is related to data policy. So here you can see the application aware routing, the traffic data, the cFloat. At the moment, we don't have anything, so I will go next. Now finally, you have to apply this policy. Apply this policy always with respect to site list. So I'll go here and give the name, say block 77 for branch number 2, and I will go and give the description. So what policy you have? You have the control policy, that's the topology. That's why you have block 77 here. You will go and give the direction. Direction is outbound. From outbound means from VSmart to VH. That's the direction. So where you want to apply this policy? I want to apply this policy to branch to new. That is the list that I have created. Click add and click preview if you want to see the CLI equivalence. So policy, control policy, sequence, see, match the route of this list with this VPN list with this particular list. So you can see we are matching all the list, all the interesting traffic. Then action, reject. Default action, accept. What is the prefix list? 77. What is the branch list? 300. What is the VPN list? That is the 10. Where you want to apply in this. So if I scroll down, you can see apply this to branch to new. Branch to new is nothing but 400. So this is the policy construct. Step by step, you can go and verify this. Click save policy. Now save policy doesn't mean that you have activated this policy. You should go to this policy here in the more, and you should click activate. Now what vManage will do, vManage will push this policy to all the VSmart, and from VSmart it will get pushed to the branch number 2. Because in the apply statement we have taken only one branch. That branch is nothing but the branch number 2. Now what we'll do that I'll go here and I'll log into the SSH terminal. First of all, I will go to the VSmart, from where I can show you that this policy is applied, and then I'll go to at least branch number 2 and data center number 1. So branch number 2 will not get this route, but data center 1 will get this route. So we'll do the verification portion. Let me go one by one to all these devices. So now in VSmart, if I type show run policy, you will see this policy. Clearly you can see the entire policy, all the steps related to our policy. And if I go and type show run apply policy, you can see this apply policy statement as well. Then I'll go to branch number 2, where I should not receive show IP routes related to VPN 10 77777777 because it should blocked. So I'm not getting that specific route here. But if I run the same command in the data center, if I go here and type, so let me log in first, show IP route VPN 10 and 7777, then here you should get that. You can see we are getting here, and these routes we are not getting here, although you have some default route that you are learning from the data center, but this specific route we are not getting. So this is one of the example of the control policy. The best possible way to understand the policy is to do that policy. So now we have seen one of the example of the policy. Again, quickly revise the theory. What is happening whenever the policy is processing, that policy will be get processed from top to bottom. So first of all, it will check sequence number 10, then sequence number 20. Likewise, it will go down, 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 down. And by the end of day, we have the default statement. It will check the default statement, what is there in the default statement. Now, whenever we are applying the vSmart policy, we are applying always.
Hi there. Thanks for your enrollment. We are in 1-minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best.
With respect to site list, if it is a control policy, it will be unidirectional. If it is a data policy, it will be bidirectional. So we have to choose the correct methodology for correct traffic in the correct direction. Now, what type of policies we have? We have, say, for example, app route policy, and that's the coolest thing we have in the SD-WAN. SD-WAN providing us app route control means with respect to application, I can provide them routing with respect to certain SLA criterias. And that's the true power we have inside the app aware routing. So that means that my device, whatever device I have, say either V-Edge or C-Edge or any Cisco device, they are able to recognize the application. And that's true. In case of CH, Cisco devices, we have N-bar engine inside that who is recognizing the application. Inside V-Edge, we have deep packet inspection engine, that is I think Cosmos, that V-Edge is using to recognizing the application. And due to these enhanced engines that we have, application recognition engines we have inside the box, we are able to identify the application, and then with help of policy we can put the SLA, and then we can do the path control. We have control policy, we have data policy, we can have membership policy, that certain VPN can be part of my corporate traffic or not. I can redirect the traffic with help of service chaining. I can do net flow type of policy with the net flow template. We can convert the NAT edge devices, or we can convert the edge devices to function as a NAT. So we can create a NAT, say for example inside VPN 0, or over VPN 0 I can have NAT flow. So application aware routing is actually huge, and it has so many variation that most of the things you'll find in the course number 2, where I'll discuss about app aware routing policy and the lab related to this. Then we have the cFloat template. cFloat template is nothing but you can collect the statistics, you can send somewhere to further analysis. It's very much similar to the NetFlow. Again, the lab we'll see later on. Then we have series of labs related to control policy. With help of control policy, I can do service chaining, I can do traffic engineering, I can support multi-topology support we have. So we have service chaining, traffic engineering, route leak, that is the extranet policy, service and path affinity, arbitrary VPN topology. These many things we can do with respect to control policy. Service chaining, simply you are redirecting the routes towards the firewall, towards the service devices. If it is a control policy, again, you need to create two policy. One is going from in to out, other is coming from out to in. Then we can do the traffic engineering, means if I want to prefer certain data center towards certain branch, or say branch 1 traffic towards data center 1, branch 2 traffic towards data center 2, I can do that. The other possibility, suppose if you want that branch 1, their primary is data center 1 and the secondary is data center 2, so that also I can do. So you can make primary and secondary in terms of routes with respect to branch and DC. That I can do with respect of traffic engineering. By default, what is happening in the Viptela fabric, that two different service VPNs, so for example VPN 10 and 20, across the fabric they are not communicating until unless we'll do a route leak in between them. So you should create some control policy and you should do the route leak. So 10 and 20 VPN, either in the same box or in the other box, they will communicate. It's a very much similar to, analogy is similar to like VLAN. VLAN 10 and VLAN 20 will not communicate until unless you have some router on a stick or SVIs. So that's the route leak policy that we can create. We can leak the route. So we can take the VPN, take the route, we can export. So here you can see match the route, match the VPN, export, match the route, match the VPN, export, and then you can apply the policy in the in direction. Then again we have very important use case related to data policy. Again, that is the one of the important policy factor inside the SD-WAN. So you can create app route policy, you can create service chaining, you can create cFloat, you can create traffic policy and counting, even in data policy. So QoS is also a type of localized data policy. So the power of data policy is really good. With respect to service chaining, I can create data policy. What is the nice thing about this? That now in the service chaining, you don't need out to in to out policy, because this is bidirectional. So once you create or once you redirect towards the security device, you don't need to create a policy for return traffic. So go and in, both will be work in the same policy. Then we can create local exit NAT. So if my users, which are guest user, which are not member of VPN, they can directly go outside to access the cloud resources. And obviously I can't send the traffic directly without any firewalling or NATing or any security provisioning. So I can create the NAT policy and then the traffic can go outside. Then we have certain examples. So here you can see the NAT related example. What you can do, that you can create the list and say certain IP. So this IP only, say XYZ IP, I am doing the NAT. Rest of the traffic is using IPsec VPN. So for Not for all the traffic we are doing the NAT. For certain traffic, say these prefixes belonging to this site, it is going outside for public resources, and rest of the corporate traffic is using IPsec VPN tunnel to do the communication. Alright, so these type of policies we can create, and in the next section I will show you one example related to multi-topology support inside the SD-WAN fabric. So we can stop here and we will continue in the next. In this example, I want to show you that how you can create hub and spoke policy. So this is hub and spoke policy. What is the topology we have at the moment? If you go and check the topology, you'll find that we have branch 1, there we have 2 routers. We have branch 2 where I have 1 device, 1 router. Then I have DC1, there I have 2 devices, and then I have DC2, there I have 2 VH devices. In between that we have 2 transport, one is MPLS, one is internet. So what is happening, what's the default behavior of SD-WAN is that by default you have all to all tunnel. So by default you can go to all to all. That means if you have say for example, if you have 4 devices, then you have this type of IPsec tunnel. Full mesh means 4 into 3 by 2. That means 6. If you have 7 devices, so you can count the number of tunnels you have. But in this case, in hub and spoke case, what I want, that I don't want direct tunnel from my edge device to other branch edge device. So from branch 1 to branch 2, I don't want direct tunnel, but I want the traffic should go to data center and then it will go to the other branch. That's the whole idea here I have to do. So before doing this thing, we should understand that how these branches, first of all, they are forming the IPsec tunnel. So what is happening that we have intelligence plane or intelligent plane, that is the control plane vSmart. Whatever TLOC that these devices have, obviously they have the TLOC transport locator. In that it has the system IP, so for example 10.30.2, and then the encapsulation, say for example IPsec, and then the color, say MPLS. Likewise here also he has the system IP, so 10.1.0.1, the color and encapsulation, so say encapsulation is IPsec, color is MPLS or internet, whatever transport we have. Over those transport they are forming the IPsec tunnel. But how? I am giving my local TLOC to him, he is giving his local TLOC to vSmart, and then vSmart doing the exchange. So to form the IPsec tunnel, I know what is my local TLOC. I need a remote TLOC and key. And these informations, this remote TLOC and key information I am getting from vSmart. So then I am forming the tunnel. Now somehow, if I do not receive the remote TLOC, that means I will not form the tunnel. Likewise, if this guy will not receive any remote TLOC, he will not form the tunnel, because to form the tunnel I should receive the TLOC. So in this case what I can do, that I can create a policy over vSmart, obviously with help of user interface policy builder inside the vManage. So what I will do, that I will create one control policy, say policy control policy name hub and spoke. I'll go to sequence number 10. I will match the, say we have option match route and match TLOC. So I will match the TLOC off site, say for example 300, and then I will reject it. Okay, then I'll go to sequence number, say for example 20. I'll match the TLOC of site 400, that is branch 1, this is branch 2, and then I'll reject it. Then I'll go to the default action, accept. That means I am accepting the TLOC of data center 1, that is 100, the site ID 100, and I'm accepting the TLOC of data center 2, that is the 200. And then I will apply this policy to the site who is branch 1 and branch 2, correct, in the out direction. Or better, I should apply this policy to all the branches. So all branches, all the data centers. So all branch, all data center, everywhere, correct. So I'm going to apply this policy to all the devices, all the site ID. Alright, so let's do this, and before doing this we should verify that do I have direct tunnel from myself to branch 2 or not. So for that I have to open the branch number 2 device here. So let me go here to branch number 2. Let me log into branch number 2 and we'll see that I can reach to him directly or not. So we'll go here and check show interface description. What is there inside VPN 10 at least? So 10.3.0.3. Now if I go here and if I type exit to exit from the vShell, if I ping 10.3.0.3 and that is inside VPN 10 and count is say for example 2, I'm able to reach, then I'll do the trace route for VPN 10, that is IP is 10.3.0.3. If it will go directly, that means I have direct tunnel. So you can see it's only one hop away, correct? And if I go and type show IPsec inbound connection, I should see that from branch number 2 where I am at the moment, I should have direct tunnel to 10.3. And that's true. We can see that I have tunnel towards 10.3. So let me show you this. Local TLOC I don't want, but you can see from 10.4 I have tunnel to 10.3. Here you can see 10.3, 10.3. That is the direct tunnel that should not be there after applying the policy, and you should not go directly, you should go via the data center. So to create this policy, let's go to the configuration and policies. We should create the interesting traffic. What is the ACL? So let me decrease the font size a little bit. This much is okay. Alright, so here what I want to do, that I should get a site list where I want to match everything. So the site list is say all sites including DC, and then this is from 100 to for example 400. So 100, 200, 300, 400, everything will come into this list. What else I want? I don't have other thing because now I have all the sites. I have VPN 10. In the previous policy we have created, if I need VPN 10 I can use it. So let's go on. I want to create a new policy, although you have hub and spoke and mesh option there, but I want to create my own custom made policy. So that is hub and spoke. I can give any name. Click here to the sequence type. What you want to match? The TLOC. With TLOC, what are the things you want to match? So let's click to the sequence rule. I want to match the site, that is for example 300, and any other thing you want to match with this site. Carrier, color, domain ID, group ID, OMP tag, originator, preference, TLOC. No. So this particular site, what I want to do in the action, I want, because we are already inside TLOC. So site and TLOC we have matched. In the action by default it is reject only. So I can click save. And here I can give say for name, say reject TLOC of branch 1. And nice thing you can see here, if I save this, I can copy this policy this time. And first of all, let me edit this, reject the 2. you remove this copy statement, and then here you can scroll down, go click edit, and instead of 300 you give 400. So take the TLOG of 400, reject it. Action is by default reject only. Save these two conditions. So now I have these two control condition. I should go inside the default policy where I want to accept it. So go click accept it. Save the control policy. Go next. Next one will be the data policy that I don't want. Now we are inside the main apply page. Here you can see that the topology, that's the control policy, and here I have the policy name itself, that is hub and spoke. I want to apply this. Yes, I want to apply this to all the sites including DC. Add this first, click the preview button, and now you can see the policy. So policy, match the TLOC of 300, rejected, match the TLOC of 400, rejected, accept all, rest all the TLOC you can have the control, you accept it. We have the site list of all the sites and the data center, apply to all. Save this policy, go here to hub and spoke and click activate. From here it will go and push to the vSmart first, and from vSmart it will go and push to all the selected edge devices. So suppose if you want to check the logs related to policy pushing, you can go and expand this more. Now you can see that policy is going, creating, updating from vSmart to the selected sites, and then we'll go back to our sites, and there we will go and check the policy. So I will go and click SSH, see the success message. You go and click SSH, where I should go to branch 1 VH2, branch 2 VH1. I can go to DC1 also, and then I will log into the vSmart as well, just to show you the policy is pushed to the vSmart or not. So let me scroll down. I have this vSmart 1. Let's go and log in one by one. So inside vSmart, you can go and type show run policy to see the policy. Yes, the policy has been pushed. You can go and verify show run apply policy. Yes, it is there. Then I can go here to the data center, to the branch number 1 and VH number 2. Let me log in. So admin and the admin. Now I can go and check show IPsec inbound connection. I should not see 10.4 here. So 10.4 is gone. If I go and check show interface description, because from branch 2 I will trace route to 10.30.3. So I'll go here finally. The session is closed because of more than 60 seconds, that is the 1 minute. So I'll go back to branch 2 and let me log in that one more time. Failed to log in. Somehow we are not able to reach to branch 2. Let me give one more chance. So admin and admin. We are inside the branch number 2, and what I want to do, I want to do the trace route for this IP. Now you can see it try to go to the data center. From there it is not getting the route towards the other branch, so that's why it is failing. That's okay, but our goal is done, that now the traffic for the VPN 10 related to 10.30/3 show IP routes for VPN 10. You will see that we don't have route towards 10.3.03 because now is not directed towards the one branch to other branch, other branch to other branch. So this is the way that we can go create the policy and apply the policy.
In this section, we are going to learn that how we can build and implement the control policy. So let's see that what type of control policies we have. We can see in the slide that we can do service chaining with control policy. We can do traffic engineering. We have extranet feature that is nothing but route leak between different type of VPN. Say for example, VPN 10 and VPN 20. By default, these VPN will not communicate to each other. So you can create a route leak policy to do the inter-VPN communication. We can use services and path affinity. We can create arbitrary VPN topology. So in this section, what I want to do, that I want to show you one lab related to multi-topology support. Multi-topology support means that we know that, okay, inside SD-WAN, we have feature that some of the VPNs, so for example, VPN 10 and VPN 20. So let me draw here. So I have one VH device. I have VPN 10, I have VPN 20, I have VPN 4040. Now this is my corporate VPN where what I want to do, that all the VPN 10 route, first it should go towards the firewall that is in the data center, and then it will go to the destination. Means I want to redirect traffic of VPN 10 across all the branches towards the data center firewall, and then it will go to outside. Likewise, for VPN 20, I want to do this hub and spoke that we have done in the last lab, that you can set the T-lock towards the data center. And for rest of the traffic, we'll see later on. We'll go and create different policy for rest of the traffic. So let's do this. And let me log into the vManage. All right, so what you have to do, that first of all you should go to the configuration and the policies. Inside this policy, what you want to create the centralized policy. You can go and click add the policy. In the add policy, I want to effect, say for example, VPN 10. So I have VPN 10 list, but if you want to create VPN, it's very easy. You can go and create your own VPN. So for example, VPN 10, you can give the number. Likewise, you can create the VPN list. Then the T-lock, here you can see that I have one T-lock, that is DC T-lock. So I can use this T-lock list that we have used this earlier in our other lab. Then we can create the site list. Yes, I want to apply this policy to, say for example, branch 1 or maybe all branches. So I have list of all the branches, but if you want to select it, you can select it. So I have all the branches, I have all the data centers. So I have all the sites for this particular lab that I want to work on. So I will go next. Next, you can see that I have option to create the control policy. Topology means you can create the control policy. If you know that what exactly you want to do, you can go and use this custom control routes and T-lock. So in this case, what I want this policy is, say for example, say hub and spoke for VPN, say for example 20, and then firewall chaining for VPN 10. So VPN 10 I want to redirect towards the firewall, and for VPN 20 I want to use hub and spoke. So let me copy and paste this. Now we'll go and build our rule. So let's go here. And for example, first of all, I want to create the rule for VPN 10. So what you can do, so straightforward, you can go to the sequence rule. You can match the route. So we can match the route of, say for example, data center, and then you can set the parameters. But in this case, what I want to do,
So our case, let me draw here one more time. So in our case, what we wanted actually, that different branches that I have, I want to take the route. So I have VPN 10 and 20. So for example, for VPN 10, so all the branches VPN 10 I want to set towards firewall, and all the branches VPN 20 I want to set toward the DC TLOC. So that's why I will go and match the site that is related to all branches. So let's do that. I'll go ahead to the site, and I have that site list that is nothing but all branches. So I can scroll down all branches. Then once you have all the branches, you are matching the route, you should give the VPN, because this is nothing but the VPN 10, because the VPN 10 in the data center, we have the firewall as well. So I'll go here and use the VPN 10. Now I have the match condition. I need to take the action. What action you want to take? Action is action accept. And then you give the service. What type of service you want to redirect? You want to redirect towards the firewall, and that firewall inside the data center, actually this is inside VPN 10. You can see very straightforward. You can go and save this policy. So this was the policy 1. So for example, for VPN 10 towards the firewall, correct? Alright, so once you have this policy number 1, then you can go and add one more sequence. This time what you want, this time you want to match the route of all the branches, and you want to set the TLOC. So this time also I'll go and match the site, and in the match site statement, if I scroll here, all the branches I want to match, and then I will choose the VPN. Say we are going to choose the VPN that is nothing but VPN 20, that is maybe PCI VPN. Yes, this is the VPN 20. So once I have this VPN 20 matching all the routes, what you want to do the action? So action I want to do that I want to set the TLOC, and this TLOC is nothing but the DC TLOC. So everything from the VPN 20 will go and hit, or whose next hop will be data center TLOC. So here I can go and change the name as well, say for VPN 20 next hop DC TLOC. Alright, and finally, if you want to give the default action, say for example, rest of the VPNs or rest of the traffic will use the default statement, you can give this. Great, so now we have the policy. We should go next. Now the next page will be your data policy. So we don't have data policy at the moment. And then the final page is to apply this policy. So I'll give the same name as apply policy as well. So let me go and give this same name. Say for example, apply policy. This is same name with apply policy. Now here you can see your topology has been called, and this particular policy I want to apply to the outward direction of all the branches. Correct? And I can click add here. If we go and click preview, you can see the rule. Match the route of all the branches set towards the firewall. Match the route of all the branches but different VPN set towards the data center. And suppose if you have VPN 40, for that also you can write the rule. In the upcoming section we'll write the rule for VPN 40 as well, and then you can go and apply this policy. Okay, so I can go click save this policy, and before applying this policy I will log into the devices. So let me go here to the monitor section and the network. So what we want to verify, say at the moment we don't have any policy. Let me go and check that also. So I should have all the policy in the false statement. That means my devices are running in the default mode. Default mode, there is no policy. All to all traffic is allowed. So if I go to branch number 1 and if I go to the troubleshooting section, inside troubleshooting section you can see that you have the option related to trace route. So we can go and quickly do the trace route. What you want to trace route? So suppose if you apply this policy, what will happen that VPN 20. So VPN 20 will use, so VPN 20 will go to the data center and then it will go to the other branch, that is branch 2 from branch 1, correct? So this should be the behavior after applying the policy. Before applying the policy, 10 and 20 everything will go directly towards VPN, towards branch 1 to branch 2, correct? So I need one destination IP. So for that I need to log into the device and grab the IP. So let me go to the device and check the IP, what IP it has. Let me do this thing. Best option we have, I can go to the SSH terminal as well, and I can log into the one of the device from branch 1 and one of the device from branch 2 as well. So I logged into branch 1 and branch 2, and if I do the ping and trace route, so let me do that. So here we'll check the IP of the VPN 10, that is 10.302. So from here I will do the trace route. So let me do that trace route from branch 2 to branch 1. Alright, so let's do the trace route for VPN 10, say 10.3.0.2. Now you can see that I can reach directly, no problem, and vice versa from 2 to 1, 1 to 2. Likewise, if I go and check the VPN 20, that is 10.3.20.2. So now again, if I go and do the trace route, say trace route for VPN 20, 10.3.20, let me see. So that IP is 10.3.20.2. This should also go directly. You can see direct reachability you have. So now we have two IP inside VPN 10. I have 10.3.0.2 and VPN 20. I have say 10.3.20.2. Now after applying the policy, so let's quickly go and activate the policy. So I'll go here to the hub and spoke and let me activate this policy. These vSmart are not managed by vManage, so let me quickly go and attach the vSmart to the vManage and then I can activate the policy. So we'll go to the templates. Inside the template you can see the vSmarts are not attached, so I'll go here and attach them. Sometimes if you attach both the vSmart, they will throw an error that try to attach one by one. Sometimes they will attach directly, so yeah, it's not attaching. So what I'll do, I'll go back to the template and let's attach this one by one. So attach the devices, take one by one, and you will see that now it will attach. And next and next. Likewise, I'll go back to the template and then again I'll go and attach the other vSmart. Alright, next and next. I'll go back to the policies and now I want to activate the policy, so you can go here and click activate. Now if those vSmarts are, the configuration has been pushed, the policy will get activated, and now I will go to the, say for example, monitor and network, and then I will select the devices. So I can go to branch 2 from where I have done the testing earlier. I'll go to the troubleshooting, and inside troubleshooting we have the option called trace route. Now I have the destination IP, say 10.30.2, that is inside VPN number 10, and you can choose the interface. Say for example your interface, if you start this, now you can see the output. It is not going directly, correct? It is going via the data center. This is VPN 10, where we are expecting that it will go via the firewall. Likewise, if you go and change the IP, say if you go and do 20.2, 20.2 is the destination for VPN 20. So if you go here and seems I need to go back once. Alright, this time what I will do, I'll go and use the other IP, that is 10.3.20.2. VPN is 20, and the interface I'll use the gig E0/3. Now this time, because we are using 20, you can see that for this particular VPN, this is going towards the data center, that is 10.2.20.3, and then it is going to the destination. So the first VPN is going towards the firewall, second VPN is going via the data center, because we have set the data center TLOC, and then it is going towards to the destination. So the policy is working perfectly right. Now what I can do here next, again to showcase you, if you want to see the more about this thing, you can go here and you can go to the
Hi there. Thanks for your enrollment. We are in 1-minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best.
real time, and you can verify the routes as well. So if you go and check the route, so you can see that I have the IP routes, and if you want to filter certain VPN, you can filter it. I want to see this VPN 10 route, and for VPN 10 route, let's see that I want to see the TLOC IP. So protocol, I will remove, say address type, I'll remove. So for example, prefix also I'll remove. I just want to show you the next hop address and the TLOC IP. So here you can see that for VPN number 10, because my firewall is in the data center, the TLOC IP is the data center IP, and even for VPN 20 also, because that is also set towards the data center. Now if you go here and check the OMP services, so now you can see that who is the originator, and for VPN 10 and VPN 20 I can see clearly some of the service route, but generally what is happening when the packet will go to the VSmart will set or send towards the firewall or any type of services routes. So one last test I want to do here. So let me log into the CLI, that is very much faster than this. So let's do one thing. Let's just stop here, and the verification and some of the testing we'll do from the CLI in the same lab. Let me show you verification from this place. So if I go and check show interface description from one of my branch 1 VH1, and if I copy any of the IP inside VPN 10, and if I go and do the trace route for VPN, say for example 10, and then if I give that IP, you can see that it is going towards the data center, and then it is going towards the firewall, and then it is going towards the other side. So from the firewall to the branch. Now if I log into the data center, and let me show you the firewall address. So here if I go and type show run VPN 10, you can clearly see the firewall address is 198.168.130.1, and the trace route result you can see it's going to the firewall and then going to the egress interface, and then it is going to the branch 1. Likewise, if you go and trace route this particular IP, so now I'll go and trace route for VPN number 20 and the other IP. This is directly going via VPN to VPN. This is going via the firewall. This is going via VPN to VPN. Now other IP also I have, that is the VPN 40, and since we haven't applied any policy, so they should go directly, correct? So now if I go and do this trace route also, directly it will go. So you can see clearly the difference and the power of SD-WAN. With very small set of policy, one of the VPN, so let me mark here, one of the VPN it is going towards the firewall, the other set of VPN it's going towards the DC and then going to exit, but the other set of VPN that is still using IPsec VPN to VPN tunnel. Okay, and that's why this is the multi-topology support that we have. Now what I'll do, that I'll go to the policy and I'll deactivate this policy. So let me go here. I'll go back to the policy and I'll go here and deactivate this policy. So once I deactivate the policy, then it will back to the normal. That means that the 40, as it is 40, the 20 will also go directly, and then the 10 will also go directly. So now all these devices are only one hop away. Okay, so this is the true verification. We have created the policy for all the VPNs, and then we have tested it again, rolling back the policy. They have their default behavior, and within a few seconds you can see that you can implement the policy and you can withdraw the policy.
In section 4.4 and 4.5, we have to learn and understand about application-aware routing. One of the core component of any SD-WAN solution we have, that how this application can take decision if there is a brownout or blackout failures. Then we have to discuss and think about the direct internet access. What is the importance of direct internet access? At this point of time, almost all the companies, they want that their 20 to 24% of traffic that exit locally, and they do not use the backhauled bandwidth. So from branch you have to go to the data center and again you will come back. So you are using the bandwidth twice, rather than you can go directly and use the internet resources or cloud resources directly, which is near to your branch. Because at the moment all the cloud provider or all the application provider hosted over cloud, they have their high availability zone or they have their availability zone So rather going from one location to other location and reach to destination directly from the branch, we can go outside. So these are the two very important and interesting topics that is going to be coming up in section number 4.4 and 4.5.
In this section, I'm going to discuss about app-aware routing. Let us start that. You can say that app-aware routing is the core of this cloud-based SD-WAN solutions, because by the end of day, everything is based on application, means how you can provide intelligent path, how you can provide the SLAs, how you can provide the failover. All these things comes under app-aware routing. In Viptela Fabric, we have very strong app-aware routing policies and various things related to app-aware routing. We'll see one by one in the upcoming recordings. Before I start that app-aware routing, I just wanted to tell you that this app-aware routing is coming inside data policies, and we have some other data policies as well, like we have centralized data policy, we have localized data policies, and then we have app-aware routing. That is again a type of policy. We'll see that, all those things. What is centralized policy? Whenever it is coming to centralized policy, that means you are pushing that policy from VA Smart Controller. And how you can apply that, we have option, like we can use like policy, data policy, and then whatever configuration, or we can use like this inside the VPN membership policies. But the centralized data policies means that you are affecting your data plane with help of your VA Smart Controller. Now when it is coming to localized data policy, that means you are building access list and you are doing all those configuration locally to the node. So first of all, you have to build something like policy and then access list. And like in normal Cisco world, we are applying the access list over a interface, like either in ingress or egress direction. Here also you have to use the same. Okay. Now coming our app-aware routing, and it's a big so no we'll discuss this one by one or step by step. App-aware routing policies, so built up we'll see all this construct and everything, but I already told you that this policy is something that is really required in a modern network or in any type of SD-WAN solution. And why it is required? Because it will provide you the best network optimization. That's the one thing. The performance and degradation can be minimized. That is again one very important aspect of modern network. Network cost can be reduced. That is the overall goal of any infrastructure. Application performance can be increased. So you can see all the big things like optimization, performance enhancement, the cost reduction, and the application performance enhancement. So all these things we have with help of app-aware routing, and we'll see what are the ingredients inside this app-aware routing. Then we'll come to know that okay, these things can be achievable. How this app-aware routing functions? So we have 3 steps. Step number 1, that you have to define the policy in terms of SLA. We'll see that SLA in terms of jitter, loss, delay. We'll check all these things. Then we have option, because we are monitoring the application end to end. So here to monitor this tunnel we have BFTs. So with help of BFT, we'll see that how BFT will track all these things. With help of BFT, we are measuring the one-way and the round-trip loss, also the one-way and the round-trip latency, and according to that, we are doing the, so this is, you can think that this is the if condition and then the action, or you can think this that this is the match criteria and then we'll took the action. What we can do after that, the map application to a specific tunnel based on the loss and latency that we have measured from step number 2. Maintain a history of loss and latency data. That's very important. We have a note here that each V edge they are supporting up to 40 logs. Means a V edge can have up to 4 different WAN network, and over these network we have to monitor the loss and the latency, and we have to take a track of the history of loss and latency. Okay. I have one diagram to show you that how it can be done. So obviously from VSmart you are pushing the policy to V-edge, and V-edge they have end-to-end tunnel. The step number 1 is to define the SLA. The step number 2 is to measure the one-way or the round-trip loss and latency. Step number 3, that we have to track the history of loss and latency, and according to that, means these are the policy implementation phases that according to that your path will be altered. So tunnel A versus B, C, D, like that. Okay. And this was the basic introduction of app-aware routing, and let me stop here. In the next or in the subsequent recording, I will record the other aspects, other important things of app-aware routing. Let us discuss about SLA class. The overall goal of this particular session is to understand that how the Viptela fabric inside the tunnels, they are collecting the information of the applications in terms of loss, latency, and jitter. And then in the upcoming section, we'll see that how we can apply all these things inside a policy. What happened in the Viptela fabric, that once your control and data plane is up, by default all V edges they have their IPsec tunnels, and that is purely mesh. That is pure mesh topology, any to any tunnel we have. Once this tunnel, means this tunnel formation is auto, so once your tunnel will form automatically, then second thing, that to track this tunnel via BFT, that is also auto. So automatically BFT is there and they will start tracking the tunnels, and the BFT they are using 1 second of interval to track this tunnel. Now again, important thing here to understand that we have T-lock. So all the tunnels they are associated with the T-lock, and these tunnels they know what is the local tunnel and they know what is the remote, say local T-lock, and they know what is the remote T-lock. And to identify or to differentiate a particular tunnel, the BFTs they are using the color. So that is the importance of color. Say at this point of time we know that T-lock is nothing but 3 tuple, that the system IP, encapsulation, and finally color. So that is the importance of color, that color is used by BFT to isolate or to identify a tunnel, and the BFTs they are using 1 second of default hello timer to track this in order. So to track this, what? To track this automatic IPsec tunnel, the T-lock informations. Both the things that the BFT are doing means they are checking that the tunnel is up or not, and secondly they are checking that the TLOC is active or not, because see, this TLOC is further again imported inside OMP, and VSmart is tracking that. So there are two tracks. One is tracking for the tunnels and one is tracking for TLOC, because if your TLOC is down, automatically your communication with the VSmart will also tear down. So remember this. Now, that is the default timer of 1 second. Then what about the average value? We have average value that is termed as one bucket, and that is by default that is 10 minutes. Means 600 BFT hello packets are equivalent to one bucket. Yeah, one bucket. And this is the average for loss, latency and jitter. This is again user configurable, and we can use this command VFD app route poll interval. We can change it. I have one summary slide for all these things, so please do not worry. What is the BFD hello packets? What is the BFD bucket? Means 600 hello packets. And finally, we need to determine the SLA class with help of multiplier. So what is the use of multiplier? So suppose if we are using a range of 1 to 6, and by default that is 6, that means 1 hello second for BFT, and then calculating 600 BFT is your one bucket. And finally, to calculate the SLA for the multiplier of 1 to 6, that means it will take 1 hour by default. All these things are by default value. So 1 second, 10 minute, and then 6 multiplier. So by default we have 1 hour to determine the SLA class. Okay, and let me show you the summary slide for that. This is again the user configurable item, and we can use the multiplier. And let me show you the summary. This is a summary. So whatever we have discussed so far, that BFT hello packets are for 1 second. That's okay, no problem. We can use this command to change it. This is ranging from 1 to 6, 5, 5, 3, 5 seconds. That is a big number. Then polling or the bucket value by default is 10 minutes. We can change this with help of BFT app route poll intervals, and we have this range. And finally we have the multiplier from 1 to 6, and we can use this command and we can change it. Okay, so all these are very important parameters to determine how app aware routing, calculating or collecting the stats with respect to BFT. All these things are related to BFT. So you can think that how powerful we have this BFT value is. BFT in terms of hello as a BFT color, BFT in terms of bucket as BFT app route poll interval, and BFT app route multipliers. Okay. So next section we'll start checking how we can configure all these things. As we have studied about this app aware routing policies, let us start building this policy. How we can build this policy. This app aware routing policy is a unique type of policy in Viptela Fabric, and it is the only policy that the implicit is, or the default action is accept. All other policies, by the end of that policy, if that policy will not match the criteria, then it will deny or it will drop the traffic. But in app aware routing, if nothing will match according to the policy, it will accept that. And that's why this is a positive type of policy That is the one thing. The other thing, this is also a type of centralized policy because we are building this policy at the level of a vSmart, and then the vSmart will push that policy to vEdges, and then it will be applied to a certain VPN or sites. Okay, so let us build this policy one by one. Let us try to understand the key components of this app-aware routing policies. And what are the key components we have? Let me go to the next slide. We know inside Viptela policy that everything will start inside policy. So first of all, we need to define the list. What type of list we have? We have list related to prefix, sites, VPN, and also we have list related to applications as well that we'll see in the upcoming recording. Then we need to define the SLA class. What is the loss, latency, jitter? Then we need to define our app route policy, and say inside app route policy we are calling our VPN, and inside that VPN we need to match conditions. So what we have inside VPN, so once we are inside VPN, then we have to match criteria, and then on that match statement we need to take action. Okay, I will see that. Then finally, if nothing will match to a certain SLA, the packet will forward to some default tunnel with no SLA configuration. Okay, and finally, once you have your policy built up, you need to apply your policy, and we can apply something like site list and then app route policy and whatever the name of the policy. Okay, so we'll see this example, this policy building here. Here you can see that first of all we can define list, and we'll see that what is app application and what is app family, application family in the upcoming recording. But these things we already know: the prefix list, site list, VPN list. Then we need to define the jitter, latency, loss. That's okay. Then we need to define our app route policy, and remember everything is inside policy. So that is our new object here, that is the app route policy object, and then the policy name, VPN, match, and action. This can be very interesting. We'll see in our example case that say my primary is SLA this. If this SLA will not match, then it will fall back to secondary. Secondary may be LTE or any internet connection. Primary may be my MPLS. All these things and fallback conditions will check. Default action is obviously to match any of the tunnel. Then finally we need to apply this, apply policy, then the site list name, and then apply this policy. Okay? So all these things one by one I will discuss in the upcoming recording. Let me stop here, and in the upcoming recording again we'll go into this policy. Let us build our policy in this particular section. We already discussed about the construct and what will be the structure of the policy. One by one, let us see that what we have inside all these things. First of all, let us discuss about this application list. And because this is one of the powerful thing inside Viptela Fabric, in application list we have application name, and at the moment Viptela is supporting up to 2300 different applications. So if you check this command, we have app list, then the application name, that is the one thing, or we have application family, and the application family, you can see this is the list of application family that Viptela is supporting. Okay, here you can see all various type of business applications we have here. Okay. Apart from that, in the list segment we have data prefix list, that already we know about that data prefix list. Then we have site list, a site identifier, something like 100, 200, 300. VPN list, whatever service VPNs we have, we can match here. Then the second important parameter is the SLA class. So how we are defining our SLA class in terms of jitter, latency, and loss. And you can see what is the maximum permissible number we have, 1 through 1000 millisecond. 1 to 1000 millisecond in terms of latency, 0 to 100% in terms of loss. So we can define our SLA policy in this fashion. I will show you in the live example as well. Then we have match parameters. So how we are going inside the policy. So we are moving to list. We can create list. SLA class, we can create that class. Then the app route policy. Inside app route policy, we'll get the match and the action segment. In the match segment, we can match. What are the things we can match? We can match app list, obviously the data prefix list, IP, destination port, and then we have various match criteria like TCP value, protocol number, source data prefix list, source IP, source port. All these things we can match. Once we can match those things, then what type of actions we have? Action we can count, log, and we can see this log values like show app log flow all, show app log flows. We'll see after our practical example that how we can verify these app route policies. Verify in sense what are the operational commands to view all these settings and the match and action parameters. Okay, so these things we have in the action. Once the action, still we have the action parameter. So once the action parameters are done, then what this V-edge will do, if we have more than one data plane tunnel satisfying the same SLA class criteria, then what the V-edge will do, that it will start load balancing across various paths, because your V-edge may have this path. So when the application is coming, say app 1, and it is matching the SLA criteria, then it will start load balancing the applications. Okay, so once we are done with the list, SLA class, app class, and inside that we have the match and the action criteria, then obviously we need to apply this. And how we can apply this? We can apply something like apply policy list name, app route policy, and then the policy name. Here we don't have any inbound or outbound direction that we have in other vSmart policies. Why? Because we are applying this, and you do not specify a direction either inbound or outbound, because this is affects only the outbound traffic of the V-edge. So again, this is very important thing. So whatever important things we have, I have matched and I have marked all these things as a red. Okay, or the commands are in the blue. So once we have all these things, then we can verify this with various commands that will use those commands and verify all these things. So at this point of time, I think it will be clear to you that how we can build the policy, what are the key components of the policies, say what are the things we have inside policy. Let me just summarize that in a second. Yep. Policy, we can define list, then we have SLA class, then we have app route policy, inside that we have VPN, then match action, and then we need to apply it to the site list, and then the app route policy. Okay, likewise it will go in this hierarchy. So let me close here, and in the next section I'll show you the practical example related to this.
In this section, I'll show you that how we can create our app route policy, and we know what are the key ingredients for this app route policy.
What are the things we require for that? So we need something called inside policy. We need list. Let me create the list first, because in this case we need VPN list, app list, site list. So let me create that list first, and then one by one I'll show you that how we can create other things as well, like SLA class, app route policy, all these stuffs. So let us create the list first. Let me open to my VS Smart Controller. Here, what I can do, I can go to policy and I can check. Let me stretch this so you can also see that. Let me double click here. Yeah, so inside policy we can create list, and for that, yeah, you can see that. So I can create list, and this time a list name is something VPN list, say my VPN, because my VPN is VPN 10. So I can give name VPN 10. I can exit. Then my second list is something called app list. If I type question mark here, you can see that we have this option called app list. I can create like this app list. You can give any name. Say in my case, suppose I'm going to use HTTPS applications. If I type question mark here, now we have option. Either we can have app or app family. I'm going to use app family for HTTPS, and you can see inside HTTPS we have option what type of app family this belongs to. This belongs to web, and let me type question mark, and then the app family. Other app family I have is webmail. I can always check with show configuration. So for HTTPS I have web app family, and the other app family is webmail. Good. Now I can exit again. I can create one app list, say for SIP traffic. What app I want to add in this? The app family is actually, and you can mark here, do we have traffic related to audio and video? So yeah, we have. I can mark this as audio and video. I can go to top. I can check my show configuration. Now we have list related to VPN, app list. Finally, I can create one more list that is related to site list. I can go to policy list, site list, say all branch, and the site ID I can take a range 300 to 400. Likewise, I can create site lists, say my DCDR, something like that, and then again I can give site ID, say from 100 to 200. I can check my configuration, and yeah, now I have all my list. So one by one I will use my list. Now the second step that I'm going to use here is to create my SLA class. That also I can create inside policy, and I can check my SLA class. I have one SLA, something related to website. That family is, that HTTPS. Here I can use latency. Why I'm using latency as 100, I'll show you that. because what I will do for the WAN link, I will increase the latency from 100 to 200, and then we can check our service path. So I'll show you in few minutes. Then other SLA class I want to create, say voice video, say SLA, and for this I am setting the latency as say 50 millisecond. I can go to top, show configuration. I'm good with the VPN list. I'm good with the app list, and finally I want to create one other policy, that is my app route policy. My VPN apps, something like that. We can give any logical name, and here I need to call my VPN, and then I need to go inside the sequence. So inside sequence number 10, I want to match what I want to match, my app list, and I have my app list. I have my SIP app. For this I can give, so match is done. For this I can give action to log, and here you can see that is the important thing here. So we have two things here. What is the SLA class and what is the backup SLA preferred color. Say preferred color, you know that for BFT, so how we are monitoring the tunnel with help of BFT, and BFT with the help of colors they know that okay, this is this TLOC source and this is this TLOC destination. So this color value is very important, and with help of color it can fall back to the backup SLA. And what is the preferred SLA? This simply mean that okay, if this SLA criteria match, this is the primary path, and if this will match, then this is the secondary. List of the preferred color for ECMP when primary SLA is not met, count bytes. Obviously this is your backup. It's okay. So I can give this criteria here, something like say my SLA class for voice video SLA, and preferred color, what preferred color I have for voice video is MPLS. That's okay, that's very natural actually. And my backup SLA preferred color is say biz internet. Okay, and that's okay. So I can go to top here as well. I can show you the configuration. What we have done so far, we have defined our SLA class. Inside SLA class I am going to match my primary and the secondary paths. Obviously that is for the tunnel. So let me stop here, and in the next recording I'll show you that how we can populate this field. Okay, so again I can create sequence 20, then 30 like that, and how we can give primary and the backup path. So let me stop here. Let us continue the previous section. So what we have done so far, that we have created a list. Actually we have created lot many lists. We have created list related to VPN. Let me show you where is the list in this example. Yeah. So we have the list, SIP app, all branch, all DC. Then we have created app list like HTTPS. Also we have app list for other traffic as well. So here you can see that our configuration is here and there, but while you are doing the configuration, then everything will come step by step. So we have all these list, HTTPS, SIP, app, branches, and then we have the VPN list. That's the one part. The other part, that we have our SLA classes defined. So I define SLA for web and SLA for voice and video. Then what I am going to do here, that few part of this app route policy I have defined. Say I use sequence number 10 for SIP, the secondary and the primary tunnel path. Okay, and the next I'm going to define for HTTPS, that is our web traffic. Then the third portion here, so this is for the web traffic, this is for voice and video, like that. So step by step I will do all these things. Yeah, so let me go back to our configuration template and let us open our VSmart. Yeah, so let me continue from where I have left. Again, I need to go inside policy and then the app ever routing, and what is the name, my VPN apps. I have done the configuration related to sequence number 10. I need to go inside VPN, my VPN, and then the sequence number say 20. I can use this time. I can match what I want to match. I want to match app list, and if you type question mark, you'll get that information. For this, what you want to do, exit from here. I want to set action log. My SLA class for web SLA is to prefer color. Okay, so web SLA, what I want to do, so this time I can give biz internet. Okay, and it will fall back to some other uh, traffic as well. So for backup SLA also I can give biz internet, because I don't want to use my MPLS circuit here. So for this traffic I can give internet, no problem, and no uh, you know exception here. Everything is fine according to the plan. Then I need to go inside sequence number 30. Here, say here I'm not matching anything, but simply I am giving action. Action what? Say for backup, color is obviously my internet, and for all other traffic that is related to voice and video SLA, I'll prefer MPLS. Let me show you the configuration, because everything seems to be too much. But if we exclude what is my SLA class, what is my VPN list, then what is the app policy? That is the key component here. App policy, I have my application SIP, primary is MPLS. I have my application HTTPS, primary and secondary is internet. And then I have my SLA class, means whatever traffic that will meet this SLA, they will prefer MPLS. Okay, and we know that this is the positive policy, so we don't need to define anything. What is the default action? Default action, if they will not match any of the SLA criteria, they will pass, they will allow any of the tunnel. Okay, so once we have done all these things, then finally we need to apply this policy. So how we can apply this? Because we have branches, and inside branches I can use app route policy, my app VPNs. That's okay. Then I can exit from here. Again I can give site list and then my DCDR app route policy, because again here we don't need to give any direction. By default this is in the egress direction, in the output direction. I can go to top, I can check show configuration. And now we have the full configuration. Okay, let us validate this and then commit and quit. Now I can go to my branches and we'll do few verification, but most of the verification we'll do in the next session, next recording. I can check show policy from my VSmart and related to app route policy, because this is a type of control and data policy. Mostly this is a data policy, so that's why we are able to see here. So whatever site ID we have given, all those branches they have downloaded this policy, and according to the app list and the action, app list and the action, and according to the SLA class, they will execute this policy. Okay, so I'm going to stop here because in the next recording I want to do the conclusion and the verification. So let me stop here in this particular portion, and in the next recording we'll do the verification. Let us do the verification, and I'm going to use some simulation in this section as well. So let us do that. Here if I go to my VH device, and how we can verify this, I can use show app. If you type question mark, you have option, either you can use app or you can use app route. I'll show you both of them. And then we have DPI inspection related to flows, and here you can see that we have the flows. We have audio video, means we have application SIP RTP. That's good. I am here in my branch number 2, and this is my local PC inside VPN 10. Apart from that, I can use show flow, show app, and then the route. We have the SLA class. If you want to see it in detail, all the SLAs, then you can do status. Okay, and one by one you will get the status of all the traffic from where to where it is going. So from me, if I want to check to the data center how it is going, I can view this information in the tabular format like this, and you can see because I have both the link, one is MPLS, one is internet, so it is showing that okay, I can reach to this. So for example, suppose I am going to my data center 1 via MPLS path, because you can see here the mean loss is 100, latency is 0, jitter is 0. So what if I increase the latency here from 0 to say 200, then what will happen? Have they divert their path? Then we need to check it. And the other way to check that information is to use a command something like show policy service path for VPN number 10. What is my interface for VPN 10? What is my source IP? Say 10.0.4.10 is my source IP. What is my destination? what protocol I want to check. So at the moment it is using internet path for the protocol number 1, and if I check why it is showing the internet path, because here it is showing it is using the MPLS link to reach to this location. Okay. So it depends that what type of traffic is going, because for HTTPS traffic both the links should be MPLS. So I have checked different options with this particular branch, and everything is going towards internet, and it's very strange. So what you can do here, that then if you check the control connection over your vmanage, then you'll come to know that, oh, your one control is down, and it is showing that your MPLS is down. So everything is going towards internet. So no problem, we'll do the testing with other branch. So here, if I come here, and before going there, let me show control connection as well, just to verify that, yeah, my one of the link is down. Here you can see that it is showing that my control is up to reach towards the vsmart, but if I go to my vmanage dashboard, now it is up. Okay, so you can see these things maybe happen. So now my control is up, everything is up, so that's why it is showing that, yeah, you have reachability to your controller via both internet and MPLS link. So now if I go and if I check my protocol number 17, that is the UDP, now this is via MPLS. Why? Because these RTP packets, they are using this UDP port numbers. If I go back to my show flow and my DPI information, show app my DPI flows, so here you can see that, yeah, your RTP is using protocol UDP, and because for this particular RTP SLA, we can check that also. So we are using SLA app float. Let me show you that SLA. So what I am doing here for video and voice, the preferred is MPLS and the backup is internet. So that's why my RTP, if I am checking the service path, it is going via. Now again my MPLS link is flapping, so that's why. But you can understand this thing, that how it is working here. And the control connection is not constant, so that's why this is happening. So let me quickly check my show control connection, and this is the thing that you need to verify as well. Show control connection, see, my MPLS is gone, so that's why everything is going towards internet. But anyways, what you can do here to redirect the traffic, obviously if your one link is down, so it will go to the other link. So what I'm going to do here, I'm going to start my WANM, and in the WAN interface I'm going to increase the delay for all the interfaces. So from say 300 I can fix. My SLA delay is how much we have configured. The latency is actually 100. Here I am giving more than that. So if this condition will not match, so automatically the traffic will fall back to the internet. But here it is showing that everything is going towards or through internet because my MPLS link is flapping. Now it is up. If I go to my service path, MPLS, now because I have increased the latency, so I'll go back. I need to apply the setting. Setting is applied to virtual interface. That's good. Now if I check the traffic, internet, if I check the control, is up. Okay, so now my traffic is going towards that because it is not matching the criteria. And the other way to check this is to check the flow stat. So let me go to show app route. Let me go there. I can check something like show app route and then the flow value. Let me do that. Show app route, and then I have a stat. I can use tab, and here in this field you can see that the latency has been increased, so that's why it is not going via MPLS, it is falling back to the internet. So traffic is going towards internet, and the index class here you can see 012 0 012 is mapped to internet. And if we see our index, app class, so you can see here index 012 is mapped towards internet, and 0 is now that is the default value here. Okay, so we have done lots of things related to app route policies, and it's actually very important, so that's why I took this much time that you can also understand and apply in the real world scenarios. Okay then, thanks for your time.
WAN is evolving, and so as the SD-WAN, and so as the cloud integration with the SD-WAN, because now when we are talking about new WAN strategy, we are talking about that how this new WAN or new SD-WAN fabric will integrate or adopt the cloud. So it's not only the evolution of WAN, but it's the evolution and the strategy and change in the strategy for the cloud integration with the WAN. Why it is required, why customers are looking for this? Because now if you go and see the SaaS adoption, that is software as a service adoption, that is predicted that will go more than 20% in upcoming years. So now what customer want, that they don't want to backhaul their traffic towards the data center and utilize the round trip link utilization. Rather, directly they can go to the cloud and use the cloud hosted application. Doing so, obviously, there are some concern that I can't directly expose to the cloud. So I can't, means I can go to the cloud, but I should have the security measures. I can use direct cloud access, I can use direct internet access, but it should go via some secure gateway, and my corporate traffic or my traffic that is going towards the cloud, that should be secure. Performance, customers are concerned, and they have the concern. You can see 25% of the customer, they have concern. So whenever they are sending the traffic towards the cloud, how they are sending, directly or backhauled, and then it is going to the cloud. In any case, they are concerned about the loss, latency and jitter, and overall the visibility
that once I'm sending or once I'm using the cloud hosted application, what is the visibility, what is the quality of experience, etc. So now if we remove these concerns, say if we remove security concern, if we increase the performance, if the cost will decrease, obviously all the customer will use a direct internet access or direct cloud access. Because doing so, if we remove the hurdle, that will be the ideal situation for all the customers. Now here you can see in the diagram that starting with no DIA, no direct internet access, so you are backhauling your traffic towards the central or regional hub or data center, and then you are going to the cloud. Or you have the mix of both, so directly also you are going to the cloud, or you're backhauling the traffic towards DC and reaching to the cloud, or directly you have multiple paths to reach to the cloud. So these are the options that customer have today, and customer they have to choose while considering the visibility, loss, latency, jitter, and the security concern, out of which particular design they are ready to use. Now we have two use cases at this point of time, that DIA can be used by the internal employees. So what does it mean? Here you can see in the diagram that there are chances that customer clients, they are the corporate client, and for internet access directly they are going and using the internet. That's the one case. The second case is that they are guest user. So here you can see in the diagram that I have the guest user, and they are not part, means they will not form the IPsec tunnel, or their traffic will not even go inside the IPsec tunnel to reach to the other side corporate or other side of the branch or maybe data center, etc. But they want to use the internet. So here you can see the guest user, they are using the internet hosted application, or they are using the internet. So these are the use cases and the concern. Later we are going to discuss more and more about the design aspects and what are the use cases we have related to designing the direct internet access plus direct cloud access. Let us talk about the design consideration for DIA. What are the components and the consideration? In this case, we have four different type of architecture. Here you can see that we may have a device having hybrid structure, means I have one link that is going to MPLS and the other leg that is going towards internet, like this. Or we may have mixed. So again, you can see that you have the hybrid, but you are using the TLOC extension in between. Or you may have dual internet, or you may have dual internet with TLOC extension, transport locator extension, correct? So in all the cases, there are chances that we can go and consider DIA or maybe local breakout. But suppose if we have some classical example where you are not considering the DIA, so there also we have the option. So let's talk both of the thing. We know that we have transport VPN, VPN0, that is working as IWAN front door VRF. You can do little bit of Google for front door VRF and you will get nice documents. Only the outside interface in terms of IWAN, they are there to form the, say for example, DMVPN phase 3, and maybe you have different type of colors like red, blue, green, or you may have different type of transport like MPLS, internet, etc., etc. Now the same logic actually we are using here. Name is VPN. Behind the scene, this VPN is nothing but VRF or VRF, virtual routing forwarding instance.
Viptela came with the idea of VPN from 0 to 512, where VPN 512 is nothing but your management VPN. Now in the Cisco devices, Cisco ISR, other Cisco IOSXE platforms, you'll find that you have VPN 1 to 511, and then you have VPN or VRF from 513 up to 65K. Okay, so these type of VRFs we can go and use. All right. So now say take the classical case where the branches, they want to use the IPsec tunnel to use the internet that is behind the data center. So in that case, my VSmart, so once the IPsec tunnel is built, VSmart is advertising default routes to the branch side devices, and then they are capable or they are able to go and use the internet. So here you can see that the internet traffic is coming. First of all, the OMP is sending the OMP routes update to all the SD-WAN devices. Now, when the traffic is interested for internet, you can see that they can go to the internet, or you will see that case if your internet link is down, then they will go via the MPLS. They will reach to the internet router. From internet router, they will go. They will access, means they will cross the traffic, and they will reach to the internet. So that will be the path here. You can see now if this link is down, so obviously the link will go via MPLS. Somehow it should reach to the gateway, and then it has to go and reach to the internet. That will be the preferred path or design. Again, in upcoming session, we are going to discuss more and more about the breakouts or direct internet access. We'll discuss more and more. Now here you can see that if you configured DIA, obviously you have to configure the NAT. So this VPN 0, I have configured the NAT. Now I have decided that what is the source or what is the destination I want to do the NAT. So the traffic, that internet traffic is coming over VPN 0, the NAT is happening, and then the traffic is going outside to access the internet, correct? Now here again you can see this diagram, and it's very much clear that you have service side VPN from 1 to 65K. You are not seeing here 512 because that is for management, and then this service side VPN has trace to VPN 0 because everything is going from VPN 0 to the destination. Either it's a NAT flow or it's a IPsec flow. So for example, in this case, I have two interfaces where we have configured NAT outside, and hence the traffic from the service VPN, it will come to the NAT, and then from here it will do the local breakout. Okay, now if you read this document, it will tell that, okay, suppose if your internet is down, means your local breakout is down. So in that case, what will happen? Suppose this red spot is down. So in this case, you can't directly go and use internet. So you will use the IPsec tunnel to somehow reach to the internet gateway. From there, you will go and use the internet that is behind the firewall inside the backhauled regional hub or maybe data center. Correct? Means you are backhauling the traffic towards the data center. So these are the design consideration, and you can understand from here that, okay, we should create a design for the traffic, intended internet traffic. Either corporate user wants to use internet, or direct cloud access, that is the DCA or DIA, or you have guest user, they want to do the local breakout, or they want to use the internet. So in both the cases, we should provide the correct methodology plus the redundancy, so they can use the internet-based applications. Correct? We have two options here to provide this DIA. What we can do, that we can provide this with help of centralized data policy, or we can use NAT DIA route. So let's check both of things. The NAT DIA routes are actually very easy and straightforward, and there is no LAN side filtering. So in this case, what we are doing here, you can see that
all the LAN side traffic or service side VPN traffic, we are sending to VPN 0, and over VPN 0 we have the NAT outside. So it will go and access the internet resources or resources hosted over cloud. Now the second option we have here is doing DIA via the centralized policy. Now in this case we have the filter option. We can filter it. What's the strategy here is that you categorize the traffic for NAT flow, and then you have the traffic categorized for SD-WAN or the IPsec overlay network as well. So if you go and check at this point of time, you'll find that you have three flows. At least you have three flows over VPN 0. Suppose this is my VPN 0. So I have NAT flow, I have IPsec flow, and one flow we know that we have something called DTLS or TLS for control traffic. Correct? So in this case, it is very important to design your queue policy, because we know that Q0 is used for control traffic. So now you may have DTLS related control traffic, you may have OMP related control traffic, you may have BFT, you may have some sort of NAT flow. Everything is going via the Q0. So we should check if any issue is there. We should go and check the Q0. And that's why it's very important to optimize the number of control connection, check how many IPsec tunnels you have. You don't want any to any and then you have n number of IPsec tunnels. Okay, so that's why things are optimized in SD-WAN, but we should know that how much optimization we need in terms of control tunnel, in terms of IPsec tunnel, in terms of breakout. All right, so one nice feature we have while using the DIA is that how you're going to track the interfaces or the WAN interfaces. More precisely, we are going to use this with DIA. So there are chances that your traffic will get a black hole. What are the chances we have? Here, so suppose you have one branch device and you are doing local breakout. So suppose I am using direct internet access, and suppose if this access is down, then how could I know that, oh, traffic is unreachable, and then I have to redirect the traffic towards some other tunnel or towards IPsec. So now I can use the IPsec tunnel to send my internet traffic, and that will be hosted over data center, and then you have the firewalls, and then you are using the internet, etc. Means how you will get the alternate path if you do not use the tracker. And in that case, we have the tracker. What is the use of this tracker? They are constantly sending the probes just to check that tunnel is up or not. If tunnel is not up, then the traffic will get diverted. And where it will get diverted, here you can see the router withdraws the NAT route to the internet destination. So it will withdraw the route and reroutes the traffic to the IPsec tunnel that doesn't have NAT enable. So now it will withdraw the routes and it will send towards the IPsec tunnel. Now for this NAT tracker, we have some important thing. What is the minimum requirement? So you should specify the IP address and DNS destination on the internet where you want to send the probe. It's very important that where you want to send the probe, you decide it. First thing. Second consideration here is that by default, they are sending the probes after 60 seconds and they are sending the 3 probes. Now this, if you think that this is little bit more, you can tune it from 10 to 600 seconds, and then the multiplier you can change from 1 to 10. So tuning option is there. You want to track the destination IP or DNS. You are sending the probes. You can tune the probe and you can check it. Now again, there is one other consideration is that also note that by default the router waits 300 millisecond to receive a response from the internet destination, and that is also changeable from 100 to 1000 milliseconds or 1 second. So these are the considerations that we should take here. So whenever we are using the NAT, we should track it, because if the DIA is down or the internet is down, so we should reroute the traffic. Otherwise, um, obviously, that's not complete automation. SD-WAN should understand and take the decision. Now, in this point of time, we should go and check the limitation of Viptela OS plus the iOS XE, because iOS XE, they at this point of time, again, if Cisco has added, but at this point of time, they don't have NAT tracker in iOS XE. They are doing ECMP to reach out to their destination, but they don't have NAT tracker. NAT tracker is a feature with Viptela operating system that can be checked with the Cisco or with the design document that Cisco is providing. This is the important recording, and you can watch it twice, or you can save this that later on again you can come and refer this particular recording or the number of slides that I'm going to show you. So what is the remote side design option? Now in
Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best.
the next slide, I will show you the diagram. But at the level of L3 switch, you can differentiate that which traffic is for the guest VRF and which traffic is for global routing table. Once you decide that, then what will happen here, you can see in the diagram. Let me highlight. So I have guest traffic and I have employee traffic. Guest who want to use internet, employee who want to use internet, employee who want to use IPsec tunnel as well. Now in case of guest, suppose if the internet link is down, guest is never be the part of VPN membership policy. Means guest traffic will never go and form, even they will be never be the part of IPsec VPN tunnels. So if internet link is down, suppose if you have only one link, if it is down, that means guest they will never use internet. Now on the other hand, the employee who want to use the internet, suppose if the interface is down, their traffic as per the centralized data policy, they can go via the IPsec tunnel and they have to reach somehow to the internet gateway. So they can go like this via MPLS, they can reach to the firewall and they can use the internet. So they still can use the direct internet access if in case of outage or failure, and that's why we have different type of VRFs serving different type of policies. In Viptela we used to tell that VPN, but VPN and VRF both are the same thing. So here you can see that branch design, that your VPN 0 NAT interface is down, so guest will be go down, but still your corporate traffic will take other route because he has the other option as per the centralized policy, and then he can go and use that. Now suppose again we know that we have two options. I can use NAT DIA route, and I can use the centralized data policy to create the DIA routes. It's very important here to understand, and that's a recommendation will come later on in this particular section. In the summary section, I will summarize that. While you're creating such type of rule, you should use, or the consideration or the recommendation is that we should use the track option. So you track the uh, system interface, or you track the WAN VPN 0 interface where you're using the internet, because if it will go down, then you can reroute the traffic towards the other available IPsec tunnel options. Correct? Now here you can see this is interesting and important. That suppose if you are using NAT DIA route, you have to go, and if it is a static route, you can point towards VPN 0, or if it is a dynamic, you should redistribute this NAT DIA route inside the dynamic. Now here you see this point number 3. It's very interesting that by default we know that a static route AD value is 1. But this NAT DIA route has AD of 6. We know that OMP has AD of 251. That means that the NAT DIA route has the higher preference over the routes that is coming from VSmart, that is nothing but the OMP. Correct? And that's the reason that your NAT thing will happen first, means NAT routing decision will be taken care first, and then secondly, if suppose that is unavailable, then it will go for the OMP route. Correct? So that was very interesting and important consideration. Now here you can see this is this type of summary type of slide. Now in this diagram, these employees are internet and internal employees, but suppose if we have guest also, one VRF you can associate with the guest and they can do the local exit. In case of failure of this link, suppose if it is the internal employee, then the traffic somehow will go inside the MPLS, and then it can go and use the internet. We should use the track interface here. That will be the best practice. So let me quickly summarize that what we have studied and what are the best practices we have in this case. So first of all, what we can do, that we should create the VRF for guest, and this will never be part of VPN membership policy. Means inside VPN membership, say for example, VRF or VPN 40 is a guest VPN, and it is not part of VPN. Means it will never form the IPsec tunnel. That's for our security safety purpose. Second thing, that I have internal user, so internal or corp user, they can use DIA over VPN 0 option. I have that I can use with centralized data policy, and with this centralized data policy I have fallback if it is required. So fallback is MPLS IPsec tunnel. Correct? Now again, interesting thing here is that we should go and use the track option as well. So these are the design consideration when we are going and using the DIA, and we should consider all these points. This session is just the extension that what we have studied. Only one or two new points you'll find. Now in case of dual router hybrid site design, so let me quickly show you the site diagram. So I have my branch, and in this branch you can see that I have two devices in hybrid mode, internet and MPLS, but we are using T-lock extension. So in between these two devices, we have transport locator, and then we are going to use the DIA. So the same thing that we have studied earlier, that for guest traffic, that is the green color, it can go and use the DIA. That is in the guest VRF. That will be the part, that will be the not part of VPN. So other important corporate or maybe partners or trusted zones or trusted VPN, they are part of VPN member, but guest is not. So that means if you have any issue at this point of time, guest traffic will get dropped. On the other hand, I have the employee traffic that is also using DIA, and if this link will go down, then it will take other path. So it will go and take other path, and then it will go and use the internet. So probably it will go like this, and then here, and then internet, it can use that path. All right, so let's see the theory. So we have theory that we are going to design the hybrid. We have just seen that hybrid branch design where we are using the T-lock extension as well. Obviously, there are options that in the WAN facing interface, you can get the IP from DHCP, or you can have the static IP as well. There is no problem. Generally, we are getting the internet facing interfaces, they are getting the IP from the DHCP. DHCP server or DHCP is hosted over the ISP side. But on the MPLS side, what we are doing, that we are providing the static IP, and if anything will there, if any problem will happen, obviously over the internet side, the internet traffic of the employee will go via the MPLS. Now, what is the important thing here, that since you are using the T-lock extension, while configuring the T-lock extension, all these interfaces, we know this thing from the T-lock extension theory, that whenever you are doing the T-lock extension, these interfaces are the part of VPN 0. So these interfaces who are here part of VPN 0, there you should go and enable the VPN 0 NAT as well. So you should go inside VPN 0, enable NAT. Not only the WAN facing interface, but the T-lock extension as well. Next thing, that we can use the track as well. We know that we have two deployment model. Either we can use a NAT DIA route, or we can use the centralized data policy from VSmart. Both things we have discussed earlier. Now here you can see that in case of failure, how it look like. So if failure is there, guest traffic will get dropped. So guest traffic is dropped as the primary internet is down. But you can see that MPLS, the internet traffic for the corporate or for the employee, that is going via MPLS, and then it is going to the core switch and aggregator, and then the firewall and the internet. So in this way, they can do the failover. There is no problem on that. And to check the WAN interface or the VPN 0 interface, we can go and use the tracking. So we have already discussed about the tracker. Whatever we have studied in the last section, what new things we have added? So since you are using the T-lock extension, over the T-lock extension also use the VPN 0 NAT. Okay, and rest whatever we have studied earlier, everything will be the same in this design as well. One by one, we are discussing all the deployment model. So in this case, say for example, I have a single device with dual internet connection. So here you can see in the diagram that I have one device, one edge device, VS device, having internet 1 and internet 2. So how and what is the best practices related to the DIA? Let's try to understand. Now in this case, either it's a iOS XE or it's a Viptela box, there is no problem. We can have that type of deployment model. Now in this case, again, that these interfaces who is facing ISP, they are getting the IP addresses, and default route towards the ISP is getting installed. Okay, so once we have such arrangement, now what will happen with the traffic flow? Here you can see that the same strategy that we have discussed earlier, that guest traffic can do the local exit. They will never be the part of VPN membership. My employee traffic that can go to the internet, and here we have two internet connection. So here you can see that if this link is down, obviously it will fall back to the other internet link, and it can use the applications or resources hosted over internet, correct? Now, while doing this type of deployment, we should go and enable NAT over both the interfaces if we want the DIA. And obviously, if internet is connected, so we should go and enable the NAT. We know that we have two deployment model. Either we can go and use the centralized data policies, or we can go and use the DIA route. And here you can see the DIA route having the higher precedence because their AD is 6, rather this OMP route, their AD is 251, but still the OMP will be used as a fallback. Now, very important thing, an important point here to understand is that inside iOS XE, if we have two NAT interface, they will use ECMP, equal cost multipathing. And even that is the limitation of iOS XE. But in the Viptela OS, we can go label the colors over the TLOC obviously, and then we can provide who is the primary and the backup. So now here you can see in the diagram that one of the internet circuit that we have, we are providing this as primary, and other link you can see that is working as a backup. So we have this option that we can go and give preferred local TLOC color and the backup local TLOC color. So here you can see that one is the primary, other one will be the secondary, and vice versa. That's the important thing we have. If we have two internet connection, we can go and add the tracking interface. We have discussed about this tracker. So tracker is there who will constantly go and send the probes. If the link is down, then it will get rerouted to the backup interface. We have technical tip that in this design, two different NAT tracker name must be configured. So you should configure unique tracker name, and then you have to assign over the interfaces, correct? NAT must be enabled before tracker to be configured. So these are the very important and interesting use cases in case we have single device and two broadband or internet connection. Next, we have dual router, dual internet design. So whatever we have studied so far, we can go and simply summarize, and those things and those knowledge will be added here. So what we know at this point of time, suppose if we have two internet, you can use those internet for redundancy purpose. So we have good redundancy. Second thing here that we are going to use the TLOC transport locator. So TLOC extension we are going to use. Here you can see that two links we have for the TLOC extension. Third very important thing, we know that we can go and use the tracker. And finally, we have two methods. Either we can use NAT DIA routes, or we can push this with the centralized data policy. So for example, centralized data policy where we can go and put the NAT rule inside that. So few of the traffic will use a normal IPsec tunnel, few of the traffic will go via the NAT rule, correct? So these things we have studied so far, and here also you can see that you have extra device for the sake of redundancy. While we are using the transport locator extension, TLOC extension, at that time we should go inside VPN 0, and those interfaces where we are using the transport locator extension, we should go and use VPN 0 NAT command. The rest of the things you can see that we have studied the same thing, same rule applies here as well, and those are the advanced practices, or those are the standard practices we should follow here as well. So here you can see that not only that you have primary and secondary, but here you can see that in this case you can go and have the local exit over other internet as well. So you may have local exit here, you may have local exit here, and you can go and add the fifth point, that will be the priority. So who is the preferred color, who is the backup local TLOC color, we can go and assign that. And that's the way that we can go and provide the dual router, dual internet connectivity, or dual internet DIA theory or the design. Now we are going to do the actual configuration for the DIA, and obviously we have two methods. One is that we can create the centralized data policy, other one is that we can go and create DIA NAT routes. So one by one we'll go and do both the things. Say in this example I have in lab, say for example I have VPN 10, VPN 20 and VPN 40. Let me quickly show you the diagram. So here you can see that I have two branches. One of the branch having devices, CH devices, CH1 and CH2. This green color is internet link and this blue one is MPLS. Say MPLS and internet. Now what we are going to do, that we have VPN 10, 20. So we have VPN 10 as a corporate, 20 as a PCI and 40 as a guest. Now for this VPN, that is VPN 10, we'll go and create the rule. Later on with this VPN, that will assume that this is guest VPN. For this also we are going to create the rule. But first of all, let's focus on VPN 10, and then we have branch with site ID 300 and 400. So in PPT we have a different site ID and the VPNs, but in actual lab we are going to follow this 300, 400, 10, 20 and 40. So let me go back to the slide. We are back to the slide. So while we are doing this rule, although the creation of rule you will find it's very easy from the vManage, but we should understand the flow and the logic behind that. So you can go to the configuration and policy. You want to create a centralized policy. You have to go here to add policy. Once you click add policy, then we know that we have 4 different things to consider. What are those 4 different things that is coming one by one? So first of all, interstring traffic. This is your classification phase. Then the next phase is related to control policy. So if you go and click next, you are here inside the control policy phase. Then the next one is related to data policy, and final one is to apply the policy. So we have actually these 4 phases from vManage that we can create the centralized policy. Now in classification phase, what we want, that we want to create the list for VPN. So in our case that is VPN 10. Then we should go and create the site list for the branches. Site list belonging to something that we want to apply the policy. Remember, apply policy 100% of time related to site list. So we'll go and define the VPN, then the site list and the data prefix list. Why? Because we want few of the traffic will go via IPsec, but for few of the traffic that is intended or destined to internet, for that NAT will happen. Now here in our lab we have mix of 2 devices. We have say for example iOS XE plus Viptela OS. So we have 2 different type of operating system. For both different type of operating system, obviously the iOS XE is not that matured as to compare with the Viptela OS, and that's the reasons Cisco has their own ISR product, say ISR 110G, 4G, 6G, where we can put actual Viptela code, say for example 19.2, so it will work and support all the SD-WAN Viptela features, correct? But still most of the customer are At present time, if you see 70 to 80% of branch devices are Cisco devices, ISR or ASR, etc. So Cisco has given one uh, what we can say that option to the customer that customers you don't need to purchase new box, but you can upgrade your hardware with the new iOS XE. Inside that we have put the SD-WAN patch and it will work. But remember, you before doing the deployment, you should list out and confirm that what features are there, what features are not there related to SD-WAN. All right, so once we create the list related to data prefix list, site ID list, VPN list, obviously then we'll go to phase number 2. So in this example, we have some other subnet, but when we'll do our lab, we may change the subnet just for an example. Like that, you can go and create the list or the classification you can do. So you can go and create the data prefix list. Suppose if different branches has different prefixes, obviously different branches have different uh, IPs or subnets who wants to go to the internet. So in that way we can go and categorize. So we'll see that in our lab. So for example here for branch 1 you have 1010. For branch 3, 4 and 5, this is branch, just an example, this is branch 2 and this is branch 3, 4, 5, last 3 and then 4 and 5, like that you can think. So then we have 10, 20, 10, 30, 10, 40. All right, so like that we can create the prefix list. Here you have the summary. In our lab it will be a bit different, and then you have overlay traffic subnet as well, and that's actually very interesting. So now you can see that you are creating the data prefix list for overlay traffic and the rest of traffic, or at least those type of traffic who wants to do the NAT. All right, then you have to go and click next. Likewise, we can go and add the branch list. So this is just nothing but adding the site list or the branch list, like that. In our case, we have branch ID 300 and 400. I'll show you in the lab section. So once you have the branch list, then okay, so once you have that, then you can go and create the VPN. In our case, say for example, we have VPN 10 instead of 1. So what I have done, we have done at this point of time that create group of interest. That's done. We know that next is control policy. So we'll go next. We'll skip this page. Then we'll go here to the configure traffic rules. You should go there, configure traffic rules, create a new policy. And this is one of the data policy. What is the agenda for this policy? The description is that data policy to match employee traffic and route the traffic from service VPN 1 to VPN 0. Correct? So now we'll go here and we'll create the custom policy. I am going to explain you each and every step in the lab section. So you have sequence rule, you have match, take action, and finally you have the default action as well. How you are going to create the rule? We are going to create the rule in this manner. So first of all, the overlay traffic, accept it. For overlay traffic, we are not doing NAT because overlay traffic have their own IPsec tunnels. Then for branch 3, 4, 5, which are the iOS XE type of branch, NAT VPN 0. In our case, that is branch 1. So for branch 1, I will do NAT VPN 0. And for branch number 2, where we have the Viptela code, there we can go and we can use NAT VPN 0, and then the fallback is local TLOC list internet. Same way I'm going to create the policy, only the site ID, VPN ID will change. Now finally we have the accept action. Default action will be drop. You can go and make this accept. So for example, what will happen? Whatever categorization or prefixes we have for data prefix list or for NAT plus the overlay traffic, apart from that all the traffic will get dropped if you make this as a default. So go here, change this policy as accept, save this policy. once you save this policy, then you have option to do the preview. Yeah, but before doing the preview, obviously we should go and apply this policy. That's the phase of the policy. So once you go and apply this policy, I want to apply this policy from service side to branch 1234 for VPN 10, or sorry, for VPN 1 in this case. But in actuality, we are going to apply to VPN 10. Then we have the preview option. Here you can see the number 5 is the preview option. Once you go and click, you can see the CLI equivalence of the configuration, and I'll show you that also. So this sequence 1 is actually for the IPsec traffic. The sequence 11 and 21, sequence 11 is for your VH traffic, and sequence 21 is for your CSR or ISR traffic. ISR devices or iOS XE rule. So finally it will look like this. We can save the policy. Once you save the policy, then we know that at a time only one policy is active inside the vManage. Once you save the policy, you need to activate it. So what's the flow? The flow is, and let me quickly draw here so you will understand. So you have your vManage, and then vManage will push this policy to all the vSmart. They are communicating with netconf. Obviously you have either DTLS or TLS tunnel in between them, and from vSmart, whatever selected branches we have, say list of site list, and there you have a vEdge or you have the cEdge. At that time, the vSmart and vEdge devices, they have OMP peer, or they are OMP peer, and this policy will push with help of OMP to all the edges. That will be the flow that netconf and OMP in between, running between vManage, vSmart, and vEdge. And that's it. So this is the way that we are going to do this particular policy. Let's stop here, and next section I'll log into the lab and I'll show you how you can create and verify. Let's do the lab. So let me log to the devices. Just wanted to show you that what are the interfaces we have inside the VPN 10. So for branch 2, the IP subnet is 10.4. Here you can see the network inside VPN 10 is this. And if we can go and check show IP route for VPN 10. So here you can see that inside VPN 10 we are receiving the routes, but basically the connected route that we have for VPN 10 is 10.4. So what I can do, that I can use a subnet, say for example 10.400 slash we can take this subnet 10 for 10.0. Okay, and if you see here the description, you have 10.1.251/3. It's just the IP connected with the switch or router. All right, then we should go and check the VPN 10 in the branch as well. So let's go to branch 1 and check show interface. We should do show IP interface brief, because this is the ISR, or this is the iOS XE. Here you can see that the 10.3.10 is the subnet for the branch number 1. Okay. All right. So we got the data prefix list that for which I want to create the policy. Let's go here and let's go to the configuration and policy. Once you are inside the configuration and policy, here you can see that you have centralized policy. You can go and click add policy. In that, I can go here and add the prefix list. So let's add it. This name is, say for example, branch 1, and this network is 10.3. This is just the name I'm giving. So for example, This is the name, but you should go and give the prefix. Now here it has problem. You can see dot and other things. It will not understand. So NAT traffic. All right, let's quickly give the data prefix list. 10.3 10.0 /24 is for branch 1, and then I'll go and create for branch 2 as well. So let's add branch 2 NAT, and what's that? Say 10 for 10.0 /24. Now, since we are creating this particular network, we should know that what will be my overlay. And we know that the order of operation means once you create the policy, the system will learn that policy, or system will act on the policy from top to bottom. So rule 1, then rule 2, then rule 3, or rule ABC, like that. So I should have something called overlay network as well. So what I will do here, that for overlay network, let's quickly go and check. So we can see that we have the overlay network. Say we have 10 network for VPN or VRF, 10, 20, and 40. 40 we are going to use later on. But here you can see that you have 100 dot network. On that we are going to form the tunnel. If I go to branch 1, we have 100.64, 100.64, and here also I can go and check 100.64. So now next what I can do, that I can create one more data prefix list. Let's go and create one more. That is for overlay, and that network is nothing but 100.64.00/16. So we have the data prefix list 1. Oops. And you can see that you have the data prefix list created for branch 2, for branch 1, for overlay. Likewise, we'll go and we should have branch 1 and branch 2. Actually, we have all branches, so I'm going to use this particular site list. Then for VPN, we have VPN 10, VPN 20, etc. So we have the VPN, we have the prefix list, we have the site. Let's go next. This is related to control policy, so we can move on. We'll go next. Now the data traffic, here you can see we want to create the new policy. Yes, and this is for, say for example, NAT for branch 1 and branch 2. Say NAT rule for branch 1 and branch 2. Oops, it's a little bit slow. For branch 1 and branch 2. Here you can see that they are not able to understand these characters. Now it's okay. Go click the sequence type. This is not belonging to application firewall, QoS, service chaining, traffic engineering, but we'll go to the custom rule. Once you are inside the custom rule, click sequence rule, and then we have the tons of options. So we application family, DNS, packet length, protocol, source, destination, etc., etc. Okay, so in this case, what we want, what my policy is, that we want to match the destination for overlay and source for my NAT traffic. That's the rule actually we are going to create. So what we can do, first of all, I want to match the overlay traffic. So for that, I will go and add the prefix list. That is nothing but just now we have created is the overlay. Now for this guy, this particular overlay, what is the action? We know that action is simply accept, because this will form the IPsec tunnel. Great. Click here, save and match condition, then go and add one more. This time what we want to do? This time I want to match the source. So we have the source data prefix, and we have two options. We have actually one CS type of device, one VH type of device. So anything I can take. So for example, let's take branch 1, that is nothing but C edge devices. Then we'll go to the action, accept, and what you want. Remember, we want to do NAT VPN. And here you can see this NAT VPN is 0. Do you have any fallback at the moment? I'm not giving any fallback at this point of time. All right, so save this. Now here you can see the policy clearly. Now the third rule or third line that we want to add here is, so let's quickly go and add. This is also related to source, so we'll go here and add the source data prefix. This belongs to branch number 2. Now this guy is related to vEdge, so we'll go here accept. We're going to accept the NAT, so let's quickly go and accept that. Alright, so where is our NAT? NAT VPN 0, fallback, and that's it. So this I am choosing the fallback option, and the fallback is your local TLOC. What's your local TLOC? We have the local TLOC internet, and if you have local TLOC list encapsulation, you can go and use the restrict, but we are not using that, so we can safely save this condition as well. So now I have 3 rules. Finally, we should go to the default action. By default, it will be drop, so we'll go and click accept, save the match condition. Now we can go and save the policy. We can go next where we want to apply this policy. So we should go here and give the NAT say rule for branches, and you should give the proper name and the description as per the requirement. Since this is the data policy and we should apply this, so here you can see we should choose the VPN and the site. They select the list. We know we are going to apply to all the branches. Select the VPN. This VPN is nothing but VPN 10. Add it. Now we have option to click preview, and we can see that. So first of all, we have this overlay. As per our previous recording, we can go and check, match the destination of overlay accepted, then match the branch 1, that is the CSR type of devices, action accept, NAT use VPN 0, then the sequence number 21, match the source, and what we are going to do here is that action use NAT, NAT fallback, and then it's up to us that we are going to use the fallback or not, and then set the local TLOC as the internet. Okay, then you have the list, and then finally you have the apply policy. So this is the way that we can go and create the policy. Once you go and create the policy, you should go and activate it. If we activate this policy, then it will go and apply to the vSmarts. And if you go back to the vSmart and if you go and check show run policy, you can see this data policy applied to the devices. Okay, and if you go to the branch 1, you can go and check show IPsec inbound connection. There is no problem with the inbound and outbound connection because anyways the overlay tunnel we are allowing here, and that's why we have given the overlay as well. So this is the way that we can create the policy, and then we can push, means we can create the policy at the level of vmanage, push to vSmart. From that vSmart with help of OMP, it will go and push to the edge devices. Now here if you want to see the policy, you can go and check, say for example show policy from vSmart, because what is happening here is this is the data policy, and we know the difference between the control policy and data policy. Data policy should be downloaded via all the sites where we are applying the policy, and this is the way we can go and check as well. Alright, so let's stop here. I'm going to show you that how you can copy the policy and little bit of basic verification command. So if you want to copy the policy, you should go to policy, and once we have the policy created, then what we can do, that here you can see that you can go to the policy, and on top you can see that you have custom option. Click to the traffic policy. We know all these things. And then instead of creating new policy, we can import existing. So that's the whole goal here. Import the policy. If you want to do some edit, do not edit the already activated policy. Copy the policy and then edit. So what I try to tell here, so once you are here and this policy is activated, means true. If you want to do any change, first of all, create a copy. So for example, NAT rule and it like that. You can give any name, but we should give the change ticket number and the description, that what date, what change ticket, what is the description related to, what is the justification, etc. We can go and give, no problem. So once you have this rule created, that's the copy. This is false, means this is not activated. Then you can go here and edit this. Whatever edit you want to do, you can edit it. There is no problem. You can go and do all type of edit. Now on top you can see, so let me quickly show you this thing. So if you see on the top, this is policy application topology. Remember, policy means apply policy, topology means your control policy, traffic rules means your data policy. So these three options we have on the top. We haven't created any control policy, so we can leave it. But if you go here to the traffic rules, we have app route, we have cFloat, etc. We can go to add policy, and then here you can go and detach a view or copy. Now still, if you want to do any type of change in this policy, from where you will do, see on top you have the custom option. Go click to the custom option, and then you have the traffic policy. Remember, traffic policy, that means your data policy. Topology means control policy. Any change, if you want to do the control policy, you should go here. Any change inside the data policy, go and click there, and now you can see that you have your data policy here. Now you can go here, click edit, and you can do all sorts of edit. Correct? So that's one way that you can copy. I have shown you the full path that you can go and copy from here. Then you can edit this rule, and then you can attach this. At the moment you attach the other rule, the first one will become false. So 0 and 1 boolean is there. Now still you want to create new policy. So there is other way as well. Go and create to the centralized policy, and then you can go here to the traffic policy, and then you have this option called import existing. Now you can go and import any of the existing policy. So here you can see that I have this policy, that's obviously the data policy. This I can import. Okay, and then we can go next, and we can rename the policy. Then we can apply. So edit, import, rename, sequence, all sorts of options are there for us. Now let's quickly go and verify whatever policy that we have created. We should go and verify. We have two different type of operating system. We have iOS XE. There you will find the verification will be different. So here you have to go and type show SD-WAN, and you can go and check the NAT option. So here you can see that show SD-WAN, and then you can see you have NAT, and then forward, and then IP NAT translations. Like that you can go and get the result. Oh, this list is big. And then if we go here and you can check the verbose as well, this will show you in detail. So when you have created the rule, it's very detailed actually. Create time, last updated, it is showing us. So when we have created the rule and when that rule has been updated, it is showing us in detail, correct? All right, the other option that Cisco has always, show IP NAT translations. You can go and see the NAT table here, and again you can see that we have multiple options. So we have total. Normally this is related to iOS XE, so I'll leave it, but we have option. Now the next thing, that suppose if you want to see the configuration, the Cisco term, we can go and use the filter show run pipe section NAT or IP NAT. So all NAT related configurations are coming, correct? But if we are very much specific to the SD-WAN configuration, so we should do config transaction. Now we are loop back inside the SD-WAN mode, and here you have to type like that, show full configuration and SD-WAN and then the NAT. So here you can get the NAT portion of the configuration. Let me quickly check if I have this NAT option, IP, and alright, you can see this full configuration related to SD-WAN, and we should have SD-WAN, and then I should go here and check show full configuration and NAT. Yep. So instead of SD-WAN NAT, you should go and check like this. This is the configuration that we have done. One of the configuration is related to guest VPN that we'll see. But yeah, you can verify from these places. Now in the vEdge, command is show IP NAT filter, and then you can get this result. If you want to go and check inside the tabular form, you can go and verify like this. Okay. All right. So stop here. Now we are ready to learn about the guest, how they are going to use the internet. It's actually very straightforward and easy in SD-WAN. Say for example, guest VPN is VPN2. In our case, that is VPN 4040. And simply we have to go inside the template and inside the service side VPN2 or VPN40 in our case, and we have to point out the default route towards the VPN 0. So how you can do that? Suppose if you have existing template, you can copy and edit it. In our case, I will show you that how we are going to do, but we are inside the service side VPN template, and here you can see that default route pointing towards gateway VPN and enable VPN on. So those things we are going to do. Now suppose if that guest user is connected with L3 switch where I'm running the OSPF protocol or any dynamic protocol. So in that case, we should go and redistribute that NAT route inside the dynamic protocol. So how we can do that? We can simply go to that particular protocol template where you have the distribute option. Inside that, you should use the protocol as a NAT for redistribution. And that's it, and that will work. Okay, so let me quickly log into the lab section, and I'm going to show you all these two options. We are here in the lab. You should go to the feature, and say for example, we know that our VPN is VPN 40, that is belonging to branch number 2. So here we have here you can see that VPN 40 template, this template, and I can, first of all, let me copy this. I will make this as a for NAT. So VPN 4.0 template we are going to use for NATing purpose. Here it is. And now we'll go and edit. So if you go and edit, you should go inside IPv4 route. Once you are inside the IPv4 route, you should go and add. So here you can see that I have this edit option. Even I can add also. But if I go here and add, here you can see that it's already a VPN gateway and NAT is enabled. So here you can see that enable VPN is on and the gateway is VPN 000. This is the same setting actually we want to do, that is already here related to VPN 40. Let's click update, save this. And now this particular template I want to use inside the device feature template. So we'll go here to branch type 2. Let's see that which particular template this is using inside the VPN 40, service side VPN 40. And here let's just scroll a little bit down. So here you can see that it is using branch 2 VPN 40 template. And if I scroll down, branch 2, we have here you can see that we have VPN 40 template for NAT. That actually I want to use. So I can go and use this. And then I can click update. But we should verify that also, that what was branch 2 VPN 40 template as well. Anyways, let's update that. Once we update that, let's click next, because this is going to push configuration, and we should go, and if we want to see that what portion of difference we have in the configuration, we can go and check the side by side difference. And if I scroll down, it will show you that that particular portion what change you have. So inside VPN 4.0 initially actually there are certain statements, say OMP and advertise, OMP and connected static as well, that we are not giving at this point of time. Okay, but rest is fine. So we can go and click configure devices. Meanwhile, it is pushing the configuration. What we can do here is that I'm going to show you this option related to OSPF NAT distribution. So if I go here, I have one OSPF feature template as well. And I can go here and we can see that branch VPN 10 OSPF actually I want. And we have certain places where I can see the no OSPF and OSPF as well. So OSPF DC filtering, just to show you, let me quickly copy this so I can do the edit inside the copy. I don't want to play around with the template that is already attached. So we are here inside the OSPF DC with filtering. NAT I want to do. Let's click edit. Once you are inside the OSPF, if you go to redistribute, inside redistribute, if you go and add new redistribute protocol, we have NAT and we can add and then we can update. So like that you can create the or change the small feature template. That feature template can be called inside the main template. So now if I am here inside the DCB edges, I can go and edit, because here we are using the OSPF, and then I can go and use the NAT. So in this case, all the DC1 devices, they will add one extra line of configuration inside the OSPF redistribution. Okay. All right, so we have done the configuration for branch 2, and if you want to see that, we can go and check We want to see this NAT and filter. It was there already initially as well, and we can go and check the NAT flow like that. Okay, so this is the way that we can create it, edit it, apply it.
Now we reach to section number 5. In this section, basically, we have to study about security and quality of service. In security, you can see 5.1 relates to service insertion. Although we have discussed about this service insertion and their lab in the previous section, where we have a study about multi-topology support. But here also we'll take one example related to service insertion. Next is application aware firewall. Now security itself is a big topic inside SD-WAN. So first of all, what I will do, so make yourself comfortable. I'll go through what are the security related topics we have. I'll try to explain few of the features that we have inside security inside SD-WAN. And then you can see the lab related to application aware firewall. Remember this thing that if you are applying application aware firewall in the same VPN at that time, you don't need routing policy because by default, same VPN they can route. But suppose if you are applying this policy in between, so for example, VPN 10 and VPN 20, that is different VPN. So at that time, you have to first of all create route leak policy, and then you have to create the firewall policy. So to understand this, we should understand the route leak as well. So route leak will be the prerequisite if you want to understand the application aware firewall policy across different VPN. Then 5.3, we have QoS. So what is QoS and how we can configure, and then scheduling, queuing, shaping, and policy. So let's start with security. This chapter is actually very interesting because first time we are going to discuss the packet flow without QoS policy and with QoS policy. So if you see the packet flow without QoS policy, how the packets are flowing inside the Viptela fabric. So for example, what will be the source we have for this SD-WAN fabric? So source will be always towards the service VPN or maybe source or destination. So whatever service VPN I have, so for example, service VPN 10 or 20 or 30. So I may have my source and destination here in the service VPN, and other side again the source and destination will be maybe inside the same service VPN. So for example 10 and or 20. So maybe 10 will go to 10 or 10 will go to different service VPN, that is 20. So what is happening that, okay, any packet that is coming, so any data packet that is coming to the edge device, he has to go to VPN 0. So from any service side VPN, the packet will come and reach to VPN 0, where we have the IPsec encapsulation. So we have headers related to IPsec, like we have encapsulating security payload header, we have outer header, we have remote TLOC addresses. Obviously I have the source and destination address, and on the top of that I have header information. So here you can see that encapsulation happens, and in the remote side, so here I have done the encap. Here in the remote side, where I have the remote destination VPN 0, at that point of time the decapsulation will happen, and then the packet will transfer to the same or maybe different service side VPN to the destination. Now this particular packet flow is without applying any type of policy, without applying QoS policy, or without applying any type of data policy. Now suppose if you apply quality of service policy, that is one type of data policy, then what will happen? So now you can see that packet will come to the ingress interface. At that time classification will happen, ACL will come into the picture, input ACL. Suppose if we have any policy that is coming from the VSmart, say centralized data policy, then
in between 2 and 3, that policy will come into the picture. Route lookup will happen, and then this packet will go to the egress of that particular interface. Over the egress interface, again the output ACL and policies, output scheduling, output rewriting, and then the packet will go to the IPsec tunnel. So if we apply the QoS policy, obviously the default behavior will change, and this will be the packet and the life of packet from the ingress to the egress.
Packet goes to out of remote site. It's going same VPN 0, no?
Yes,
At the
same
end of
VPN 0. Yeah, always it will leave from VPN 0. It will go to VPN 0 because VPN 0 we have only transport over VPN 0 interfaces. Yeah, that's correct.
Okay. Means only the things that happen edge router, ACLs and policy implied into the ingress packet.
Yes, so before VPN 0, we have all those things applied. Then it will go to the IPsec.
Yeah. The same thing, but the policies and the ACLs will be applied. Okay.
Yeah.
Now, here is one question. For VPN 0, generally we are keeping a gigabit Ethernet 0 and one more ISP link. Okay. If I have more traffic is coming, we have 6 interfaces. 4 is connected to the branch office. The traffic is more, then how you will increase the bandwidth? Change the router with the big interfaces?
Yeah, that's a nice thing to check. So remember, we have a study about application aware routing policies. So suppose I have 2 interfaces over VPN 0, and then more traffic is coming from different segments from service side VPN. Then we need to check that what type of app route policy I have applied. Now if I applied that app route policy properly, then what will happen, say for this link I have some SLA, it will fail over to this link I have say SLA, it will fail over to this link. Means in general, if you see, if the application applied is proper, they will properly utilize both the links. So the link will be active utilized.
But if the traffic is totally more than the 2 interfaces, then change the hardware.
Yes, the traffic will load balance to the interfaces.
Okay.
Alright, so let's see that what type of QoS policies we have. We'll see the format of the quality of service. The format is very different than what we have inside Cisco MQC policy, modular QoS CLI policy. It's very different, but one thing we have, one good thing we have inside the QoS policy, I'll come back to all this slide. One good thing we have inside the QoS policy, that if you see the policy, even the QoS policy also, you'll find that this will also start from policy. So first of all, I have to go inside the policy framework, and then I have to call different objects. We'll see that. So before that, let's check that what is the hardware and the software limit of the QoS. Alright, so we have some big slides. The QoS features on the vEdge router work by examine packet entering at the edge router. It is a localized data policy because it is local to the device, also called access list. Now again we have the difference between the Cisco and the Viptela, that in Cisco we can use ACL, and that ACL I can call inside, say, route policy, policy map, NAT, so many places I can call ACL. But here you can see that localized data policy. So QoS is a localized data policy. Sometimes this is referred as a ACL, access list. So here you will find it's a bit tricky, but it's a standard only, but it's tricky that how with help of ACL we are forming the QoS structure. We'll see that. You can provision QoS classify for incoming packets into multiple forwarding class. So what is this new term, forwarding class? We'll see that. Based on the importance, spread the classes across different interfaces queue and schedule the whatever these things are there, we are going to see in the configuration, because configuration is actually very structured. We have a structure for the QoS configuration. We'll check that. Now, once we have the ACL, we can apply this ACL to input and the output direction. We'll see that also, that how we can apply the ACL over the interfaces. To provision QoS, you must configure each router in a network, generally each router. So how we are going to apply the QoS, I'll show you in the lab section. Why? Because you'll find that QoS implementation is very structured than the normal QoS that we used to do in the Cisco Catalyst or Cisco routers. It's same type of format used everywhere. It's like that. So we'll see that once we are going to see the structure of the QoS. So at that time we'll see that how with help of ACL and how with help of forwarding classes and different type of queues we are going to apply it. So I'll hold this slide for upcoming configuration slide. I'll come back to this after 2-3 slides. Let's move on. We can classify the packets. How we can classify the packet? One thing we can remember at this point, we can classify the packet with respect to forwarding classes. How? We'll see. So forwarding classes, we are going to map with the queue. How many queues we have, that also we'll see just in next slide. So here you can see that, for example, you can configure QoS map for each output queue to specify the bandwidth, delay buffer, size, packet loss, priority of output queue. This enable you determine how to prioritize the packets to their destination. What does it mean? Again, we are going to see. Depending upon the priority of the traffic, you can assign packets higher and lower bandwidth. How we can assign the bandwidth? We are going to see that in the configuration. Buffer levels and the drop priorities based on the condition defined in the QoS map. Packets are forwarded into next hop on the hardware V-edge router. So this is the important thing. On the hardware V-edge, we have total 8 queue. So queue is starting from 0 to queue is ending with 7. That means we have total 8 queues. Q0 is reserved and used for both control and the low latency queuing, LLQ. For LLQ, any class that is mapped to Q0 must also be configured to use LLQ. All traffic is transmitted. Now Q1 to 7 are available for data traffic, and the default scheduling we'll see. Say I have Q0, I have Q1 up to I have say Q7. How we are going to divide the traffic inside the queue with respect to forwarding class, we are going to see this in the configuration. The other important thing here in this slide, you'll find that, but in case of software vEdge or the cloud vEdge, we have only 4 queue, number from 0 to 3. Q0 is reserved for control traffic and Q1 to 3 are for data traffic. The scheduling method for all the 4 queues are weighted round robin. LLQ is not supported. So what we can conclude from this particular slide is that for hardware we have Q0 up to Q7, means we have total 8 queues. 0 is reserved for the control traffic or control plane traffic. Likewise in software we have Q0 to Q3. Q0 is there reserved for control traffic and Q1 to 3 is for data traffic. Let's see. We can do the rewrite of the data packets as well when it will leave the, or when it is going from the egress interface to outside. At that time we can rewrite the DSCP, differential service code point. That option we have, like this option is there in the Cisco devices also. Alright, so let's see that how we can go and build the policy. I'm going to show you that how we are going to build the policy. For building of policy, we have 6 steps. Step number 1, map each forwarding class. So we'll see forwarding class to queue mapping. So for example, in our case, we have Q0 to Q3, means we have total 4 queues. So map forwarding class to the queue. Configure the QoS scheduler for each forwarding class. So now I have say QoS scheduler for the forwarding class. So for example, I have forwarding class 1, forwarding class 2, etc. So then I'm going to call the forwarding class inside the QoS scheduler. Group the QoS scheduler inside QoS map, and that's done. So inside QoS map, you have to call QoS scheduler, and we are done. These are the main important ones. Now next, define the access list for the match condition. Apply the access list to the interfaces. Apply the queue map to the egress interface, or apply the queue map. So you have to build the policy and you have to apply the policy. How we are going to do that? Let's see. So first of all, you have to go and define the class map. So here you can see class map. Let me show you the real example. We have very nice QoS example, so I will show you there. Let me go and log any of the device. First of all, we are going to check what is the class map. Now here you can see that I have class map. Inside that I have class voice, because this is important, so I am mapping with Q0. Video I am mapping with Q1. Business data I am mapping with Q2. Best effort is Q3, because in software we have 4 queues. So like that, I can have my forwarding classes. These are my forwarding classes to the queue mapping. That is our step number 1. So once we do step number 1, then we can go to the QoS scheduler. How? So then I can go and check secure QoS scheduler. I am going to call the class, define the bandwidth, define the buffer, give the drop probability. So again from here, next is QoS scheduler. Now you can see QoS scheduler, sorry for that, best effort. So inside best effort, I am calling a class that is best effort. I am giving bandwidth percent of 5 only, buffer percent of 5. It is a red drop, random early detection drop. It will shoot the packet if it having some low priority or something. That is the use of red. For business data, because the data bandwidth is high, so I am giving 50% of bandwidth to the business data for the class biz data. The drop is again a red drop. For video, calling the class video, bandwidth is 30, buffer is 30. And finally for voice, giving the class voice, but here you can see that the scheduling is low latency queue. So for voice related traffic, I can give scheduling as a LLQ, low latency queue. Now what is the last step that we need to check? We need to go and call this inside the QoS map. So now you can see that inside QoS map, whose name is WAN QoS, I am going to call my best effort, my traffic, business traffic, video and voice. So here you can see that we have class map where we are mapping the forwarding classes to queue. Then we have QoS scheduler where we are calling the classes, say A, we are giving the bandwidth, buffer and the priority. Then finally inside QoS map we are calling the QoS scheduler, whatever we have defined in a step number 2. Now what will be the final step is to apply this. So next what we'll do, this QoS map whose name is WAN QoS, I will go to the WAN interface. So who is my WAN interface? WAN interface is sitting over VPN 0. So if I go inside VPN 0, you can see I am applying QoS map, WAN QoS, WAN QoS. So all the interfaces over VPN 0, I can go and apply this QoS policy. Okay, so this is the half. We'll check the 50%, other 50%, but this is the way that we can use WAN related QoS. And then I'll come back and show you the access list configuration as well.
The sure short question that you will get in your interview is that what are the different modes of BFD and what is the use case related to bidirectional forward detection, why it is important, and do we have any other usability of BFD like that. So maybe same question in different styles people can ask you. Now, BFT is very important, as we have discussed in the last session, that BFT at the moment your tunnel is up and running, it's a responsibility of BFT that it can track the tunnel. Now, on other hand, it's a responsibility of BFT that suppose if you have app route data policy or application route data policy, again, those applications that is using the tunnel, so who is going to check the loss, latency and jitter glued with that application? That's the use of BFT we have. So BFT, say suppose BFT is a type of hello packet as well, who is checking the health of tunnel, or in other word you can tell that at least the liveliness when we are talking about BFD hello packet. Here in the chart you can see that we have three flavor of BFT running inside SD-WAN. One is the hello packet. What hello packet will do, it will go like how ICMP echo request and reply is working. You're sending the echo and then you are getting the reply, and then you can measure the round trip. At least one way or one side loss, latency, jitter. Correct? Now suppose if you send 5 ping packets, means 5 echo request and echo reply like by default routers are doing, and then they are giving what is the minimum, maximum and the average of the uh, loss, latency, jitter, you can say, or you can say that round trip loss, latency and jitter, etc. Likewise BFD is also doing, but it is doing in much more effective manner, because first of all it has the timer of 1 second. Obviously all these timers that you're seeing here are tunable, you can go and change that. One thing important here, that BFT is per color. So suppose if you have two ISP color or you have two link with two color, that means you have two BFT going via those tunnels. That means you are sending two independent BFT packet, BFT hello packet to reach out. Now think like that you're sending some application, and for that application you have certain SLA parameter. So suppose voice application where loss, latency, jitter you have given very less. It's very, say for example, uh, latency sensitive application, or it's a very much, say, delay sensitive application as per SLA. So who is going to measure? So that's the answer, that BFT is going to measure that. When we are talking about one way, at that time BFD hello packet will check one way loss, latency and jitter. But suppose you have to examine or you have to collect certain number of samples, and then you have to decide on an average basis. So for that, for sampling reason, we have the bucket feature, or we can say that we have the bucket option. That's the poll interval. That's the second, actually the third column. You can see the uh, when we are coming to the row, let me try to highlight here so you can see here. This is poll interval of by default 10 minutes. That means you are going to sample 600 BFT packet, and those, on top of those samples, obviously 600 BFT packet, then you can take the average of loss, latency, jitter. Correct? Again, the configuration is there, how we can increase or decrease this. These are the default setting. Now the last thing we have is the multiplier. So suppose you have one bucket of 600 sample, but is still with time
means obviously if the time will pass, that bucket will exceed. So to have the history of that bucket or to collect all those buckets, we have this multiplier. Means the device, they have some sort of buffer and they are having 6 different, you can think as a bucket of 600 BFT. Not 600 bucket, but 6 bucket. Let me correct myself. 6 bucket, each bucket having 600 samples, and then we are maintaining the history of the average of loss latency jitter. Correct? So that's the correct statement. Now here you can see 1 second and then 10 minute and then 6 multiply means 6 into 10, that will give you 60 seconds. That means 1 hour. So 1 second, 10 minute and 1 hour. And that's the BFT types we have. Remember here is that BFT, that first option hello packet is per tunnel, but the poll interval and the multiplier are per device. Question number 13. What is the difference between feature template, device template, policy template, and security template? And this question may be a little bit confusing because we have so many different type of features and where to use what. For any of the new guys, it may be a little bit a learning curve. So here you can see that let me try to draw here. Give me a moment, I will draw. Say for example you have feature template. Let me write here feature and template. Let me clean and write. So what's the use of feature template? Feature templates are very small templates that can be reused inside device feature template. So device feature template, this is the actual configuration for any of the device, and again this device feature template also we can reuse. So here you can see that you can reuse first of all the feature template. Even you can create variable inside device feature template, that also can be reused. So now you can understand that device feature template can have n number of feature template. Now when we are talking about configuring the device, so let me go up. You can use the feature template or you can use the CLI template as well. Remember this thing. So you can have CLI template, you can have device feature template, and then you can go and use n number of feature template. Now again, when we are talking about device feature template, so let's focus here because this is going to be configured, or this is going to be pushed to the device. So what is the hierarchy that we manage is using a protocol netconf to go and push the configuration, say for example device feature template, to n number of VH plus VSmart. Correct? Great. Now you can go to the vmanage and you can create security template as well. You can go to vmanage and you can go and create policy template as well. Okay, so now we have these two term, policy template and security template, and where it is going to be used. Now this security template is part of device feature template. So device feature template, you have big template, and if you go and see in bottom you have something called additional configuration. Here you can go and use the security template. So again that means the vmanage will go and use netconf to do this configuration. But when we are talking about this policy template, so you can go to the vmanage label, you can go and create policy template, but this policy template will get pushed to VSmart, and then VSmart will go and push to VH, okay, as per the site list. So you can see that how much difference or variations we have here. We have vmanage, and at the level of vmanage you can create say feature template, you can create device feature template, you can create security template, you can go and create the policy template. Now this policy template, so policy template will go and push to the vsmart, and vsmart is using OMP to go and push to VH. Here the underlying protocol again is netconf. Now for this vmanage, you can create FT or DFT. And remember, FTs are part of DFT. So this device feature template, again it will use netconf, and again this security template is a part of DFT that will go and push to the VH directly. Okay, so that's the importance with respect to templates we have, and that will be the answer for this particular question. Next qualified question we have is that in secure SD-WAN, what security features we have? What are the things we can do over the ISR routers with respect to security? So answer here is that Cisco SD-WAN supports all sort of security features. We can go and create firewalling rule, although this is true with vEdge as well. So cEdge as Cisco and vEdge as well with Tela. So cEdge and vEdge, both we can go and create the zone-based firewall rules. But in cEdge, we can go and create AMP related rule, advanced malware protection, URL or web filtering, IPS IDS rule, and then we can integrate with Cisco umbrella as well. Although vEdge also we can integrate with Cisco umbrella. So what are the new features we have? You can see here new and advanced feature like any next generation firewall. We have AMP, web filter, IPS IDS. Correct? Now the next very important thing here to understand that these devices mean the ISR devices where we are going to enable the security features. They are actually not security device. So that means we need some extra virtual image. So these devices can work as a container, or over these devices, assuming that we have the container functionality, and then we can go and install some other image related to security, and that's the virtual secure image. Can be downloaded from the same place from where you are getting all the softwares related to SD-WAN. So you can install this. Again, there is one very important point. So suppose uh, you go to vmanage, because from where you have to create the policies. Your policies you have to create from vmanage, and suppose if you are coming to from Palo Alto World, we have Panorama as a central off mode controller or GUI. From there you can go and push the configuration to the different say for example Palo Alto firewall. Same, so for example we have firepower where we have FMC, firepower management console, from where you can create the policies and you can push to FTD. Correct. So likewise here also vmanage is working as a central console or central manager where you have to go and create the policy. Now what will happen in this case? So first of all, you will install the virtual image at the level of vmanage, and then you can go and create the policies related to AMP, URL, etc. Now once you create the policy, obviously you have to push the policy. How it is going to be pushed? Again, in the device feature template, you have one option for security template. So you can create the policy in the security policy template feature template or security feature template section. Then that policy will go inside the device feature template. So that's your template part. Now once you go and use the netconf, means vmanage will use netconf to push the policy to the ISR devices. Once you go and push the policy, what will happen? Because these ISR devices, they don't have virtual image. So first of all, they will contact vmanage. They will download the virtual image. So this will take time. So first time when you are creating the policy, it may take 20 to 40 minutes. Why? Because first of all, he has to, or the ISR or the endpoint devices or edge devices, they have to download the virtual image. Once they download the virtual image, then they will go and install the policy, or then they will go and write the policy over that virtual image, and then whatever flow related things we have, it will work. That I will explain in the next question, that what is the difference between app aware routing and app aware firewall, that we can check. But yeah, that's a very key thing, and it's a very important thing, that what will happen, that when you are creating the policy, it's not like that FMC or Panorama that you create the policy push and within a few seconds it will go and push to the selected devices. First time it will take time, next time onwards when we'll go and create the policy, it will be faster. Now we have tricky question number 15. What's the difference between application aware routing and firewall? Can I apply app aware firewall within the same VPN or VRF? Now this question is very interesting. We know that one of the core capability of SD-WAN is that they are supporting application aware routing. So application aware routing, this is one of the data policy that you can create. So certain application will go via MPLS, certain will go via internet, fallback, etc. So this is one of the capability. Now the question here is that how the SD-WAN devices can do either app route or app firewall policies, how they can do. So the answer is this, that the devices, they have something called DPI, deep packet inspection. Now these DPIs, say in Viptela, that engine is Cosmos, and in Cisco ISR we know that's a famous term NBAR, network based application recognition. Sometimes Cisco is referring as a AVC as well, application visibility control. So this is the engine. What is happening whenever the packet is coming and hitting to the device, they can learn the metadata of that application inside the deep packet inspection. Now your DPI engine can learn, recognize the application, and then either you can go and apply or create the say app route policy, or you can go and create the app firewall policy. Okay, so that's the answer of first portion, first part. Now the follow-up question is that, okay, so your answer is correct, that is supporting app aware firewall. So when I have VPN, say for example service side VPN, VPN 10, and then suppose I have VPN 20, so can I go and apply the app firewall to the same VPN or different VPN? See, you can go and apply to the same VPN the firewall rule, that's there is no problem. But at the moment you'll go and apply, so you can take say zone, source zone for example, as VPN 10, and then the destination zone as VPN 20. That time, suppose if we have only firewall rule, this will not work. Before applying the firewall rule, you should have or you must have the route leak policy. So the VPN 10 can leak the route to 20 and 20 can leak the route to 10, and then only you can apply the firewall policy if in case of intra-zone communication. Alright, so that will be the answer for this particular question. Let's just stop here. One of the good question may be that what is the difference between or similarity between TPM and TAM? Now we know with the evolution of V-Edge hardware, we have trusted platform module, that is nothing but the TPM chip. Inside that, vendors are pre-loading the RSA certificates, and that can be used whenever the vendor will ship that device to the client or to the business unit. Uh, at that time, they will go and deploy those devices and they will get authenticated. So it will cut down the number of certification steps or the process, because in certification if you check
controllers, the number of steps are more than the physical devices or than the edge devices. Why? Because already certificates are the RSA, at least the certificates are there in the TPM chip. Now, on other hand, you can see that with the C edge devices, with the Cisco devices, we have Cisco Secure Boot method, and that's the TAM. So the same chip module, not exactly same, but same type of concept we have with Cisco ISR as well, where you have trusted anchor module. Now, if you go and do a little bit of search about trusted anchor module, you find that Cisco is using this anchor module in other hardwares as well. So, for example, UCS, Unified Compute System. So there also Cisco is using, and maybe in other Cisco routers and other switches also you'll find that Cisco is using this. Why? Because of to protect the hardware. So here you can see in the step number 1 up to 4 that before the actual OS will get launched. So what's the order of operation? That your micro loader in general, the process will start from step number 2 where you have the micro loader program. That's a small program which is helping to boot the operating system. Like that you have this bootloader, so micro loader and then the bootloader helping to start the operating system or run the operating system. But before that we have, so here you can see the micro loader is anchored, or you can see some sort of a screen via the anchor, a small anchor module program who is going to do some sort of code level check, some sort of sanity check, you can say. So that's the thing we have, that in case of hardware protection, we are using this anchor module. And again, you can see what is the difference between TPM and TAM. Both have different type of program, but overall, the goal is to protect the hardware. Question number 17. What's the importance of vBond in Cisco SD-WAN fabric? Is this forming TLS or it is using DTLS channel? Now again, this type of question may be underrated and may we think, okay, because of all the devices in network, in at least with respect to control plane, they are very secure, so they should form TLS tunnel instead of TTLS. Now, what is the difference between TLS and DTLS is that TLS is TCP based SSL, DTLS is UDP based SSL. So if you go and check the specification of tunnel, you'll find that the vSmart and vManage, they can have option, they can use both DTLS or TLS, means it's optional. But for vBond, it's mandatory that they should use DTLS. So vBond, we don't have even option to choose TLS. They are always using DTLS. Now, one of the potential reason for this may be that of the DTLS connection may be faster, although it is not much reliable like TLS, but it's still what we want from vBond. We want from vBond is to do the authentication related to all the control and data plane devices. Either they are joining the fabric or they are leaving the fabric. In both the case, first of all, they have to go and inform the vBond, and suppose if that time we are looking for reliability or something, so it's not that fair enough that we should use TLS connection with vBond. So that's the reason that vBond is using DTLS. That's the one of the reason, but uh, other reason may be that DTLS tunnel is faster. Maybe there are some sort of acceleration related to DTLS that is not there in TLS. Maybe some hardware related stuffs as well. That number of DTLS tunnel could be more with compared to TLS tunnel in terms of manageability of the tunnels. So these may be the probable answer that choose A versus B. But here is the caution. When we are doing the network design, at that time we should prefer the highest level of security. So at that time what we should do, that for the vManage, for vBond, for vManage, vSmart, and the edge devices, we should use TLS. And obviously the vBond is by default using DTLS, so it's fair enough to use such type of design model in terms of control plane and data plane devices. Question number 18. How we can achieve high availability in vBond, vSmart, and vManage? Now, it's actually a very tricky question because for all the controllers, we have different methodology to reach the high availability. So first thing should be here that what type of controller deployment do you have? Do you have cloud hosted or do you have in premises? Now, if you have cloud hosted deployment, then at that time, mostly Cisco will take care of the high availability of the control plane devices. But still, how you're going to do the connection with the vEdge or CS devices to the vSmart and vManage, that's again important thing. At least the connection or the control connection between the control plane and the data plane should be optimized. Either it's a cloud-based deployment or it's a on-prem. In both cases, we have to do like that. So suppose when we are inside on-prem, in that case or in that scenario, what about the high availability? So we are doing the DNS method for vBond. That means suppose you have 3 to 4 vBond, and those vBond, instead of giving the vBond IP, we can use the URL or some DNS, and that DNS will be mapped with different vBonds. So if one vBond or two vBond is unreachable, still with the URL you are able to reach to the remaining vBond. Correct? Now for vManage, we are doing the clustering. So we are creating at least 3 vManage in a cluster, and that's the Cisco recommendation. And we should have very low level of latency in between these vManage because the databases are going to be replicated across the vManage. So you have your one logical distributed switch, maybe inside the data center or across the data center. So with DVS, you can have the vManage inside the cluster, correct? Now finally, and the important one, what about vSmart? So for vSmart, we have a technology called Affinity, and what this Affinity technology is doing, or the strategy is doing, is, so let me try to explain here, because it's very important that we should design proper method for vSmart. So suppose if you have 3 vSmart in a data center, suppose I have DC1 and I have DC2, and suppose I have 1, 2, and 3 devices. So what will happen? We know that all the data plane, they will go and form the connection with all the vSmart, correct? And suppose if we have multiple paths, they will go and reach uh, to that particular vSmart with multiple ISP. So that means in this case, you have 3 vSmart and then you have 3 devices. That means your number of control connection is 9. Now think if you have 2000 devices, then your number of connection will become 6k. Number of connection in number of control connection. 6000 control connection unnecessarily you are managing, and suppose if any due to any reason this data center is down, you don't have redundancy. So this is not a scalable design. Rather than what we can do here is that we can group the vSmart. So suppose I have group 10 and I have only 2 vSmart here, and then I have other group here, and in that group suppose I have only one vSmart, so group number 20, and then one of the, suppose I have two VH device. So for one of the VH device, this is the primary and this is the secondary or backup. For other set of VH devices, this is the primary vSmart and these are the secondary or the backup link,
correct? So primary and backup link, you can go and use the connection. Now, if you go and see the number of active control connection in this case, that will be drastically reduced to, so from 6K, they will go and reduce to 2K. And still you have better redundancy than what we have in the 6K. So this is the affinity feature inside the vSmart designing, and we can reach the highest level of redundancy with this particular feature inside the vSmart. Alright, so remember, we want DNS, we manage cluster, and vSmart, we have to do the affinity feature.
Quick question, guys.
Yeah.
They have VPN 0. Currently, you have only one interface. But reality, they have 4 interfaces.
So for all the interfaces, say here you can see inside VPN 0 we have 2 interfaces.
Show
So
me that.
yeah.
Yeah.
So
VPN
first
0. Yeah.
VPN 0 gig 0/1 and then
Yeah.
gig 0/2. So both
But
places, yeah.
okay. 2 places. Every interface you need to give a map.
Yes, yeah. So if I show you this show interface inside VPN 0, I have these 2 interface.
Yeah.
So for all the interfaces, we can apply this QoS, and this configuration that we are checking. So now we are in the operating system 19.1. Say for example ISR. I don't know I have shown you that slide or not. Just give me a second. Let us continue our configuration section, and in this particular section I'm going to create access list, and I'm going to apply it on a certain interface plus the QoS map that we have created in the last section. I will apply it, plus in this particular section I will create rewrite rule as well, and then I will apply it. So let's do all these things in this particular recording. I'm here in my DC1 VH1, and I don't want to do any configuration in this particular device because I want to do configuration in one of my branch, that is say my VH1 in branch 2. So let's do one thing, let's copy all these stuffs and we can paste here like this. We can validate, commit and quit. Now what I want to do, I want to create ACL rules and I want to apply it like we have in this slide. So here you can see that I can create ACL, I can match the source and the destination. In this case I will use source as my VPN 10 source, and my destination is again in VPN 10 because I'm going to apply this policy inside VPN 10. I will use branch 2 VH1 and DC1 VH as a source and destination, and I will use this policy. So what I'm going to do, once I match the source and destination, I will set that traffic with class best effort. If we have traffic matching DHCP value 10, then that will set as a class AF. And if I am matching the TCP protocol, then it will match the class AF3. That we have 3 classes here in our software-based VH, and the default action is drop. So once we'll create this rule, then obviously we need to apply it on an interface, and I'll apply it in the branch 2 VH1 VPN 10 interface in this direction. Okay, so let's do this. Let me open my VH, and here what I can do, I just want my source and destination IP. So for that I can check show interfaces. In VPN 10 this is my source. Now I can create my policy. Access list say ACL is 1, say sequence 10, and I want to match the source IP as this, and sequentially the do I have okay, it's not a valid value. Let's re-verify it. That can I take IP and length? Yeah, I can take it. So let me do like this. Okay, And once I am doing this, because I want destination as well, so I can do one more time here, and then yeah, okay, no problem. Then I need destination as well, so my destination IP is the data center 1 VPN 10 IP, and that we need to check it. Let me check here with show interfaces as well, and this is my destination. So my destination IP is 0/18. It's not in the value. Yeah, we need to give proper subnet. You know that. What does it mean? So once I have the source and destination, then I can set action. For that, I need to come to my sequence number, and here I can map a class. So my class in this case, if I type question mark, you can see all our classes are here. This is okay. Then we can exit. We can go to sequence number, again exit. We can go to sequence number, say 20. And in this case, I want to match the DHCP value of say 10. That is again according to our slide. Yeah, here exit, and the action is accept, and the class is AF1. Again, I can exit, and I can exit. Now I can go to the sequence number 30, where I want to match protocol TCP 6, that is, and I want to set an action as accept with class of AF2, that is the remaining class. Now we can exit, we can set the default action is drop. We can validate it. Now I can commit it. I can go out, I can go to my VPN say 10 and interface gig 0/2, and here I can apply this as a access list. And what is my access list? ACL1 in the ingress direction. I can validate this, commit. Once I commit, now I can check like this. Now I can go to show policy and then access list, associations. Now we have the various options to verify it. Apart from that, counters, then name, and the moment I don't have policy, I can check this something like show run policy and then access list as well. So it will show me the entire policy. I have the policy where I have the source and destination matching the default class. Then I have DHCP traffic matching AF1, TCP traffic matching AF2, like that. So we are good with the ACL configuration. Then what next we have already applied. Now what I'm going to do, I'm going to configure the rewrite rule, and then I will apply this over interface. So only rewrite rule is left here. So let's see that what does it mean and what is the usability of this. See, if you know QoS concept, we have something called RAID concept there, random early detection. With help of RAID, you can mark. So you can have low and high drop preference. Means if traffic is coming in this particular queue, then the rate of dropping them, you can think like 1 out of 10. If it will cross this limit, then it may be 2 out of 10 means 2 packets will be dropped out of 10, and that is something like random drop, means your system will randomly drop or shoot those packets reaching the destination. Now here we can use the rewrite policy, and we can use this concept of RAID as well. How we can use this? Say I have one rewrite policy called transport, and with AF class, with you can see on your screen marking with DSCP3, then AF1 high DSCP4. Like that we can mark the low and the high drop preference in the rewrite rule. So what I can do here, let me open my configuration template or the configuration VH where we are doing the configuration, and then we'll do the configuration and then we'll check it. Going to my VH, and here let us do this thing. Let's do the configuration. So here again I have to go inside policy. I can use rewrite rule, and we can give some name like transport. We have here I can use my class AF1 and low DSCP value say 3, like that, class AF1, and the high preference is 4, like that. We have class AF2 with low of something, we can say that 5, a DSCP of 5, and same class with high of DSCP value of 6. Like that, we have one more class, that is BE, best effort, low with DSCP 1, and class BE high with DSCP 2. We can check our configuration. This is our rewrite policy. We can validate, we can commit and quit. So commit and quit. Now we are done with all our steps that we have discussed. Now the final step is to apply this. Now what I'm going to do, I'm going to apply this QoS map and this rewrite rule transport policy in my VPN 0. And one important note here, that QMap and the rewrite rules are applied only in the outgoing traffic, or this is only for the outgoing traffic. Okay, so let's do one thing. Let's go and we can go to our VPN 0, and I have two interfaces actually, means I have two control interfaces, and here I can apply the policy. So I can check my QoS map and the rewrite rule. My QoS map is something test, and my rewrite rule is transport. Validate. Likewise, I can go to my other interface, that is 0/1, and we can use QoS map test and rewrite rule as transport. Validate, commit and quit. Now we can check our rule. So our final policy, you can see here that I have class map, then I have rewrite rule, I have class access list for the interfaces for VPN 10. I have something called QoS map where I'm mapping the schedulers. Okay, so now you can see that the configuration is really big, and we have applied all this configuration. If you want to verify, you can verify it with show policy, and then we have the various options. Although I haven't used policies and other things, but still we have the verification options here. Okay. So I'm good with this particular section, and let me go back and let me show you that from where we have started this. So for that, let me go back to my slide deck. Here is my slide, and if I go back, so what are the 6 steps that to configure the QoS? Now let us revise it. So first of all, what we have to do, that we need to create class and then map the class with the queues 0 to Q7 or 0 to Q3 in the cloud-based vEdge. Then we can create schedulers for each forwarding classes. Then those schedulers we can map inside the QoS map. We can create ACL and we can match the traffic or match the class map inside the ACLs. Then we can apply the ACL to certain interface, that's okay. And finally we can apply the QoS map and rewrite rule to the egress direction. So all these 6 steps I have covered one by one. Obviously you can, if you want, you can pause the recording and you can verify it. Okay, so I'm going to stop the recording here. I'll see you in the next section. Hi, welcome. In this particular section, I'm going to show you 2 examples. One example that how we can use Policy in our vEdges, and here you can see that what is the policy that I'm going to configure inside my ACL. Let me highlight that with black color. So this rate I'm going to limit, and this is my buffer size. Let's see what is the policy configuration. And you can see the constructs are very simple. We can go inside policy, name of the policy, we can fix a rate and the burst. If it will exceed that burst limit, then packets start dropping. That is our rule. And likewise, we can apply these policies to our service VPN interfaces. And important thing here that we can apply this in either in ingress direction or egress direction, either in or out. Okay, so let's see that how we can execute this policy. Let me open my device. Let me go to my vEdges. In this case, I'm going to use my branch 1 vEdge1, and if I check my interfaces, what interfaces I have inside VPN 10, I have one interface gigi 0/0. So let's create the policy. Then I can give policy and the name of the policy. Then I can fix a rate like this. I can use the burst, and then we can use the exceed. The exceed is drop or remark. So in this case, in our case, we can use drop, no problem. We can validate. Even if we want to check this, or if we want to view this configuration, we can type show configuration, and here it is. Once we are good, we can commit, and we can go to top. We can go to VPN 10 interface. gig E0/0 because I have only one interface. Then I can use polisher and the name of the polisher. Now we have option, either I can use in or out. Again I can commit. Even if I can do commit and quit, I can check my policy like this. I can check my policy with filter like policy and polisher like this. We can check our policy like this as well, show run, and then what options we have here. You can see access list options. We have lot many access list option, and then we have access list policy, so we can use this as well. Okay. So at the moment I haven't tagged any of my ACL with the policy, so I'm not able to see this, but if I want I can tag my ACL with the policy and then I can check it. So these are the various options that we can have to view our policy. Let us stop here because in the next section I'm going to show you the next example. So let's stop here. See you in the next recording.
In the modern networking, in the SDN type of networking, those networks are also exposed to the outside world. So we have same threats that we have in the traditional network. It is applicable to the SD-WAN type of network as well. So for example, say cyber warfare, a nation or state-sponsored threats or hacking, organizational crime, ransomware, financially motivated crimes, multiple bugs, malware, DOS attack, botnets, all those things are there. Why? Because at the moment also what my user is doing, that he is going outside and he want to access the internet. And now because we are in the hybrid type of transport world, so my user, he can go directly to the outside where I have the cloud hosted application or SaaS as an application or infra as an application. So all the places they can go and they can find those threats. So some of the threats we have seen in the last slide that is motivated, but some of the threats are there. Those threats are not that much motivated, but hackers or those world who is doing the hackers, either it's a mature type of hacking or any type of script kiddie, or just for fun also people try to do DOS attack and other attacks, because those tools are available over internet as very small easy type of tools, maybe backtrack or any type of tools, and just for testing purpose or maybe just for fun they used to violate the rule and try to gain access inside the other network. Apart from that, you will see that few of the devices they have OS vulnerability, or maybe in network you have some sort of vulnerabilities. So those attacks are also possible. Something you are doing uh, just for checking that tool also. So I have seen few of the guys just they are, start learning some hacking courses and then they start testing that either it's internal. So most of the time we have seen that most of the threats are internal also. So internally they know some sort of trick and then they are doing or running the script or they are sending some DOS and etc. Even sometimes I have seen that people don't know that what they are doing, but they just do those things and maybe they are spreading the malware everywhere in the network. So either it's intentional or unintentional, that is from the mature hacker or group of hacker or organization group or nation. In all the cases, we need to protect our network from the external threat. Now in the SD-WAN realm here you can see that you may have outside in threat. So maybe threat is coming to outside in because I am using local exit concept. Locally I am exiting to outside. So maybe my attack surface will increase. Now here you will see clearly that I have three type of edge. So I may have branch edge, I may have data center edge, I may have cloud edge.
So all these three places I need to protect, I need to secure, and what type of options we have in terms of security, that we'll see one by one. So you may have outside to in threat, you may be inside to out threat, you may have internal threats. So some employees or some people, they don't know what they are doing, but they are spreading the malware or the script inside the infra. So for all those things, now in Cisco SD-WAN, we have very powerful security stack. We have very powerful tools available because now these devices, these SD-WAN devices, they are supporting ISR and ASR, and we can build the security stack with help of these new devices. So now you can see that we have full edge security stack. We will see later on that what type of security options we have in the new Cisco devices. They are very rich, and we'll see one by one that what features we have inside these new iOS XE routers and how we are going to plan and provide the security in terms of cloud security. So we can use Cisco DNS, we can use IPS, IDS, and URL filtering. All those features we have in the new Cisco devices. So let's stop here, and next section we will study about what new features capabilities has been added inside the Cisco devices or inside the Cisco SD-WAN. In this session I'm going to cover that what is the threat surface we have and what is the solution we have. So now you can see that I have my branch here and I have my data center here. Both the branch and data center, they should have some edge devices where I need to provide the security. So I should have very mature type of security. We'll see that what type of security we have, but the input is coming from the cloud, either it is a private cloud or public cloud, etc. So all the places we should provide a tight security whenever the packet is coming in. Now why we have this attack surface, that also we'll discuss. But in terms of SD-WAN, if you see the SD-WAN components, so what we have, say we have orchestration plane, management plane, data plane, and control plane. All these places, by default, we have the security. So when you bring up the control plane and the data plane, at that time you have tight security. We know that the data plane and control plane, they are forming DTLS, TLS tunnel. In between data plane to data plane, we have IPsec tunnel. So we have tight security, but still we want to provide the security to the infrastructure devices, say for example WAN edges, controllers, and when the device is moving from branch to the cloud. So let me show you what I tried to explain here. Here you can see that I can directly go to the cloud. Here you can see that I am directly going to the cloud. At that time, I can use integrated security stack or whatever integrated security suite of things we have. We'll check that. So we have VPN, firewall, URL, IPS, AMP, etc. We'll see that complete stack that we have here. We are going to see. Then other option, you can see that you may have dedicated security appliance. Then what you can redirect your traffic towards the regional hub or towards the dedicated security appliance, and then it will go to the outside. Here I may have two flows. So here I have actually two flow. We'll see. We can discuss that. Suppose if it is a data policy, then I do not need to worry about in and out because that is bidirectional. If it is a control policy, then I need to create two policy, one in to out, other out to in. And then finally you have this cloud delivery where we can use Cisco DNS security, that is nothing but Cisco umbrella, and we can provide the security to the cloud hosted application if I have, say for example, cloud hosted devices as well. All right, so let me show you that attack surfaces that we have. So we may have compliance. Here you can see at that time I'm using IPsec VPN, firewall, we have firewall zone, IPS, IDS. So what is happening, that all the traffic is backhauled towards the data center and then it is going to internet. So that's the traditional way, like in traditional internet also, or in traditional WAN also, we used to do this strategy. Everything is going towards the data center or the regional hub, and then it is going to the cloud where you have the security appliance. The other option we have where we are giving the more attack surface. Here you can see only 25% is attack surface. 50% of attack surface is that for guest access. So suppose you have different VRF or VPN and you are allowing that users inside that particular VRF or VPN to directly access the internet. At that time your attack surface will increase. You are more exposed towards the public cloud. The third option, you can see that we have direct cloud access. So my user can directly go to cloud, my guest can directly go to the cloud. At that time, you can see that attack surface is increasing, and we can use app-aware routing policies, we can use app-aware firewall policies, we can use IPS for attack prevention, we can use AMP, advanced malware protection for malware prevention. So you can see that attack surface and how we are providing the security, both we have, both the options we have. And then finally, you can see this direct internet access. In that case, directly you are going to the internet, directly the guest is going to the internet. So in that case, the attack surface is 100%. So we can use app-aware, firewall, IPS, DNS, URL filtering, AMP. Whatever required things we have to protect the data, I can use it. Correct? So now you can see in the diagram that what Cisco is providing to the customer. So here you can see that you can have firewall, IPS, IDS, URL filtering, DNS security. All these features we have, and later we'll see when we log into the dashboard from the vManage, we can provide these security policies. We have say firewall, we have intrusion system, URL filtering, advanced malware protection, and then again we have the DNS security as well. As per the attack surface, we have the solution inside the new Cisco devices. Here you will see that in ASR, although it is limited, in VEdge, although it is limited, because in ASR and VEdge, you are assuming to redirect your traffic towards the firewall or towards the security appliances. But in case of ISR, ENCS, Enterprise Network Compute System, and CSR, you can build those things inside the device as well with some virtual image. So here you can see that you have this edge router flexibility. We have full edge security stack. So we have enterprise firewall, app-aware routing, firewalling, IPS filtering, advanced malware. Then we have DNS security like Cisco Umbrella. And everything by the end of day we can manage from the vManage. So not only I can do the provisioning, policy, monitoring, reporting, but policy related to security as well. I can go and monitor. And finally, we have full visibility for all those services that we have. We have multiple dashboard as well in the vManage dashboard from where we can manage everything. But by the end of the day, we can do the troubleshooting as well. We'll see that what is the path, how the traffic is going, etc. So all these things we have inside the vManage dashboard. From there we can go and provide the full security as per the attack service. So we have the attack, but we have the security defense as well. Cisco Viptela fabric is actually very strong, and it's very secure. Why it is strong? Because they are using the 256 AES encryption bit. So that's why the security is very high. At the moment we bring up the control plane, so if you do the deployment and you bring up the control plane or the controllers, and then if you bring up the data plane devices, what is going to be happen that from control plane and inside the control plane itself, they will form either DTLS or TLS protected tunnel. From data plane to control plane also we have the DTLS or TLS tunnel. From data plane to data plane, they will automatically form IPsec, and it is actually very scalable because in SD-WAN we are using a scalable method to form by default full mesh IPsec connectivity. So yeah, that's true that this fabric itself is very secure and strong. And let's see one by one what are the use of all these planes. So here you can see the management plane. It is here to do the overall management of the fabric, the troubleshooting, and the RBAC APIs. We have control plane, that is one of the important component in the fabric, that is nothing but VSmart. What the VSmart is doing, that not only you have the control connection, but you have the OMP peer as well between the edge and the VSmart. You can send the policies, you can send the routing and other traffic engineering, service redirection, all those parameters from the VSmart to the edge devices. Then we have the physical devices. We can do ZTP, PNP. They are with the control plane. They are forming the secure tunnel, and with one data plane to other data plane devices, you have the IPsec tunnel. Obviously, you have the orchestration plane as well. That is nothing but the VBond. That is the first point of authentication, and they are using the whitelist model. They are doing the NATing as well. So these are the components we have in the fabric. One by one, if I go and discuss about this, so what is the role of the orchestration? It orchestrates the control and management plane. It is using the whitelist model. They are distributing the list. So whatever list that you are uploading to the vManage, he will send to vBond and he will send to vSmart and vice versa. Whatever they are getting from the PNP site, also they are going and distributing to the ZTP server. From ZTP server, the vBond are getting those lists. So those lists that what you want to authenticate inside the fabric, they are getting redistributed across all the control plane devices. Then you have the intelligent device that will use all type of control policies and data policies. It will help to form the IPsec tunnel as well in between the devices. So it's actually very smart and intelligent device that is there working as a control plane or the intelligent plane in the fabric. Then we have the WAN edge. Nowadays we have all this security suite inside that. So not only that we can do the app aware routing, but we can do app aware security as well. They are the component of the data plane devices. They are forming the OMP, that is the routing peer with vSmart. So here I have OMP. All these vSmarts are OMP peer. So for example, this particular device, it has 3 OMP peer. Like if you have 3 vSmart, then they are doing app aware routing, export performance. You can run OSP or BGP. Now we have EIGRP support. I can run first hop redundancy protocol, that is the VRRP. They can do zero touch deployment. I can do T-lock extension. So all sort of innovations that we have inside the branch routers with help of the control plane. Then finally, we have the management plane that can be used as a day 0, 1 and 2. So for the deployment, for the configuration or bringing up all the fabrics, and for the monitoring and operations and maintenance, we can use the vManage. They can support multi-tenancy. You can do the troubleshooting. You have full visibility. We can create policies and policy related templates, configurations and configuration related templates. We can do software upgrade. We have RBAC features, and finally we can integrate with some third-party tools for automation and APIs. So all those things we have, all those features we have inside this secure fabric. That is the combination of, so for example, the control plane, management plane, orchestration plane, data plane. You can do cloud reporting as well with help of vAnalytic, and that's it. That's the secure fabric we have inside the SD-WAN fabric. We know that VS devices, they are coming with the TPM chip, that was nothing but Trusted Platform Module. Likewise, in new Cisco images, that is Cisco IOS XE, they have something called TAM, Cisco Trusted Anchor Module. Now we'll see that what is the differences between the TAM and the TPM module. But both the functionality of the TPM and the TAM modules, that they are used for secure boot up of a system, first thing. And second thing, that those hardware, that TPM chip for example, they are preloaded with some sort of RSA keys. So when you are doing the ZTP, or for example when you are doing the PNP, at that time you don't need to do the manual type of certification process. Automatically when you connect those devices to the WAN interfaces, they will register, and they will do the authentication in terms of certificate validation and all. Everything will be automated. So that's one use case we have. That is, again, once you boot up, then they will do the automatic uh, certification process, and they will join the fabric. Now here you can see the list of the useful features that we have in the Anchor, Cisco Anchor module. So we have the integrity, we have the TAM service library, we have the crypto function, this is your tamper proof storage, we have boot measurement, we have SUDI, SUDI. We know about this UDI. UDI is nothing but unique device identifier, where you can add secure before to that. And this secure UDI, nowadays what we have to do and what is required, that you have to go to PNP portal, plug and play portal. From there you have to register with what part number, what is the serial number and chassis ID, and that will update it to the, so from PNP it will update it to the ZTP, from PNP it will update it to vManage, and then once you are connecting the edge devices, it will get authenticated. So here you can see that we have a small comparison between the TPM and the TAM. Although both of these modules are providing, say for example, crypto engine, non-volatile secure storage, anti-tamper, key storage, random number generation, policy configuration, etc. So both these modules are actually there to provide the physical security and secure certification, authentication, etc. Suppose if you are going to use that, say for example, VS device, when Cisco has acquired that, at that time you can use the TPM chip inside that, which has the certificate signed by Avnet. We'll see in the upcoming slide that now it is not required, because Cisco is providing their root certificate to the devices. But before 19.1, these are provided by the Avnet. It doesn't mean that the corporate or company, they don't have their root CA. They can do these things via their root CA as well. Now when we are deploying the router, you can see that we have two routers. Either it's a physical box, or it's a cloud, or the operating system that we are booting up. The physical box will come with the serial number, it will come with the chassis ID, it has the TPM module. What about this virtual box? Because they don't have the GPM module. So at that time, you have to upload the list that you'll get from the OEM related to serial number and the token. That is nothing but one-time password or OTP. So chassis ID you have, but you don't have serial number, but you have the token that will be used for only one time. And once you are bringing up the device, at that time you have to go and you have to give one command, activate vEdge router, what is the valid chassis number and the token. Detailed process I have listed in this particular small course, that how you can go and deploy the control plane and data plane devices manually. All those devices in this particular course is virtual, means we are using 100% virtual devices, or the only the operating system, just to showcase you that how you can bring up the system. That is that recording, how that course was related to Viptela, and that's why you'll find that I need to certified from the Avnet, or in case that is the lab environment, so I have my own root CA from where I can sign. But you can go and check step 1, 2, 3, 4, 5, 6, etc. You will get all the detailed steps in that. All right. So now you can see that from 19.1 we have Cisco everywhere. So Cisco will do all those certification and the criteria that Cisco will fulfill. Here it is using the plug and play mechanism to do the certification authentication. plus to generate the serial number and the chassis ID. All right. Finally, we have this DOS protection mechanism inbuilt in the devices. So suppose you are communicating with respect to vManage and vSmart. So if the traffic is coming from the vEdge, vManage, vSmart, v1, they are coming via the secure TLS or DTLS tunnel. So there is no problem. Traffic is permitted. That's why we have green. But here you can see that we have deny if any other traffic is coming. Then in that case, what the vManage and vSmart will do, that they will deny except these traffic like TCP, DNS, ICMP, netconf. If you want to allow some services, you can always go to the tunnel interface and you can allow services. You can see that we have control plane policing, so 500 PPS per flow, and this total number of flows we have. Likewise, if you have the vEdge router, so there also we have the control plane policing or some sort of DOS prevention mechanism inbuilt. So in that case, I may have TLS, DTLS channel with the control plane devices. I may have SD-WAN connection with the SD-WAN IPsec connection with the other VS devices, or maybe I am hosted my devices over Azure or AWS. At that time, I can have IPsec or I can have GRE tunnel with a Zscaler, a cloud security provider, or maybe something is coming from outside. So in these three cases, you can see they are allowing the traffic by default. But if any unknown source is there at that time, you will see that what type of permission you want. Again, you can go to the tunnel interface and whatever things that you want to allow, you can allow. Otherwise, you can disallow other things. All right, so let's stop here. At the moment we bring up the control and data plane, the fabric will go and it will secure itself. Now you will see that in SD-WAN, in Viptela especially, we have the scaling for the control plane. The control plane is highly scalable, and that's the one reason that why this is becoming nowadays very popular. So here you can see the data plane plus the local control plane complexity in SD-WAN. Sometimes we refer this as a class architecture where you have non-blocking type of connection or the tunnels or the physical connectivity that is non-blocking. Say for example, leaf and spine structure. So if you see the structure of the, say for example, spine and leaf or leaf and spine, etc., then all the spines, they are connected with leaves, and these leaves, they are again connected with a spine. There is no spine to spine connectivity. There is no leaf to leaf connectivity. So here also we have this type of tunnel, means the control connection we have logically like this, but the data plane, they are always, say for example, one hop away, but still the complexity is only n. In the traditional network where you have the key complexity, all the devices, they are sending their key to all the devices. So their key complexity is nearly n square. Here the complexity is less, so it can scale wisely. Apart from that, we have overlay management protocol that is customized. We can tell that this is customized BGP protocol, which is using TCP based extensible control plane protocol, that is, and you have OMP pair. So for example, in this case I have vSmart here. So for this vSmart, how many OMP pair I have? So 1, 2, 3 and 4. I have 4 OMP pair, and if I count down that how many control connections I have, then you can count, okay, for this particular device, if you have only one ISP, then you have say 1, 2 and 3 control connections. So those are different things, like DTLS or TLS control connection are different, and OMP is something like your routing peer. So later in this segment I'll show you that how the devices, they are advertising their routes to the OMP. Now if you go and check what types of OMP routes you have, inside OMP you will find that you have 3 different type of route. One is V route, or the routes coming from service side VPN. One is the TLOC routes, and one is the security route or service routes, for example firewall, IPS, IDS. So what is happening that my V smart, he is the intelligent enough, he is getting collection, or he is taking all the routes from all the devices. He is working behind the scene as a route reflector. So he reflect all these three type of routes. In future, if you want to make any policy, centralized policy, routing policy, or data policy, you can use vSmart and push that, and then they can do traffic engineering, service redirection, route preference, etc. So all those things are possible inside the secure tunnel. Next, we have very important data tunnel. These data tunnel will also form automatically, but what is happening, because the key complexity is only n, how it is, whatever edge devices are there, they are sending their key information. Here you can see that we have the OMP update that has IP subnet TLOC, encryption key, data and app route policy. So to form the IPsec connection, you have, say for example, local TLOC. What you want? You want, so he also have local TLOC. You want remote TLOC, this is TLOC transport locator, and then you need key. So this remote TLOC and key information you are getting inside the OMP update. He will also get the remote TLOC and the key information from the OMP update, and then they will form the IPsec tunnel in between that. That is the data plane tunnel. Now this data plane tunnel is, again, it is segmented inside the VPN. We'll see in the upcoming slides. But remember what type of routes that SD-WAN is forming. They are forming say OMP route. What type of routing tables we have? So OMP routing table, you can go and verify, like show OMP route. Then they are pushing, they are sending the OMP table to these guys. They are installing the OMP routes. From that, they are building the routing table. That is nothing but the RIB information. And from there, they check, okay, active tunnel, inside that I have BFD for tracking the liveliness of the tunnel. Then they are forming the FIB database. So what is the subnet and the next hop tunnel IP, or what is the subnet, what is the next hop actual VPN IP, and associated TLOC with that. And then they are sending the packet from one place to other place. Now again, it's interesting that the vSmart in between, he is helping to form these guys the encrypted tunnel. So you can think that phase 1, like inside VPN we have two phase 1 and phase 2. So phase 1 is done via the vSmart, and then phase 2 these guys are doing. So that's why the scalability is very high, and this VPN solution can scale if we compare to the traditional VPN. Yes, we have the data plane integrity. So you can see that whenever the traffic will come from the service side VPN, so for example VPN or VRF10, then this particular data that is coming, that's the payload, once it will come and reach to VPN 0, he will put the ESP header, the UDP header, and then the outer IP, whatever outer IP it has, to reach up to this particular place. So here you have your encryption will happen. Once you reach to this point, your decryption will happen, and then packet that is started from VPN 10 or VRF10, it will delivered. So again, he will go here, he will check what is the VPN table to the routing table, where is actually the destination mapped to, and then he will deliver the data. Okay, so this way the routing will happen. It is a very secure fabric, and inside that you can see the ESP and all the AES, like advanced encryption system 256-bit, is embedded there. We have full support of segmentation, and when you are doing the segmentation and the routing, that will support segmentation routing. So that's why we can tell that we have multi-topology support. How it is happening? So for example, VPN 10 across the fabric can behave like hub and spoke. The VPN 2 across the fabric redirect towards firewall inside the backhaul data center, and VPN 3 can do some local exit, or maybe it can work as a full mesh. So all these options are possible, everything we can do with help of obviously the VS Smart policy. So I can create VS Smart policy, and then we can do 100% segmentation, and multiple segment can work as a different topology inside the same fabric. We have end-to-end segmentation. Yes, you have big VPN 0, and inside that you have segmented tunnels like VPN 1, 2, 3, because throughout the packet life they have some label, and they are using that label format like in MPLS. They are carrying the label from one place to other place, so that's why they have the label. And this segmented label, whatever VRF actually or VPN label we have, they maintain that label. So that's why we have the VPN maintained, or the segmented VPN maintained from one location to other location. Finally, if you see the solution in the old draft, we have say VPN 0, VPN 1 up to VPN 512. That is, VPN 0 is nothing but transport VPN 1 to 511. That was nothing but the service VPN, and the VPN 512 was nothing but the management VPN. So now if you see that, oh, VPN 0, that is going connected to MPLS internet, it is something like untrusted zone. We'll see later on how we can add the interfaces inside the zone. And then you have the trusted zone. Across the fabric, I have a management interface as well for out-of-band management. So we can create these interfaces inside the zone. We can separate the zones. Then obviously you can put the security from your VS Smart. So security may be say control policy, not 100% security, but we can have control policy is nothing but the routing policy. And then you have say data policy. So in data policy you can use, say for example, app aware routing policy or net flow policy. So those things I can push from the VS Smart as a data policy. Again, these policy are centralized. You can see centralize and localize. So let me draw here properly so you can understand. So what is happening actually, if you check the policy and security, you'll find that policy is having two parts. One is centralized policy. One is control policy, other one is the data policy. Inside control and data policy, you have centralized policy, you have localized policy. Here you also you have centralized policy, you have localized policy. You can tell centralized policy is nothing but global policy. This is nothing but local policy. So this way you can segregate, and now you can see the true power, that not only we have the inbuilt security in the control plane, data plane, while communication also they are using the security both in control plane and data plane, but both places the security parameters are different. We can insert or we can redirect the traffic also. So here you can see that if I'm going to the inside VPN1, you can see I'm redirecting towards the firewall, and then it is going, so from remote side it is going to regional hub to the data center. So all redirection of traffic and all those things are possible. So now if we summarize, service nodes are connected to SD-WAN edge. If you are directly going towards the Azure or AWS, you can use IKE version 1 or 2. And if you are going outside, again we have discussed this, if I am a DIA, then at that time I can go via the backhaul data center, or I can use other parameters as well, but in that case my attack surface will be more than the normal. Alright, so let's stop here, and next section onwards we'll discuss more and more about the security features. As per Cisco innovation, they tried to combine whatever most important and widely used features we have in this security suite. So you can see here that, okay, I have the firewall, IPS, URL filtering, DNS security. All these different protocol or the service elements, they have different rule. So if you want to check the packet flow up to layer 4, now we, with help of say next generation firewall, we can inspect up to layer 7 as well. So we can check the flow of the traffic, the TCP flow, and they will maintain a session table. Inside the session table, you can see all the traffic that is going into out to in. Then we have IPS IDS where we can check the signatures. If any anomaly behavior is there, if any behavior that is deviating the standard protocol signature or whatever a standard format of protocol has. So for that we have the IPS system. URL filtering, obviously this is again the core of any type of UTM device, Unified Threat Management devices. So you have long list of URLs where you want to block the users to go. Then we have advanced malware protection where uh, we have the features like file reputation and sandboxing. So you can send certain file to the cloud. From there they will go deep inside that file. They can check all the contents of file, and then if it is safe, then it will go to the destination. It's something like that. So you are doing some conversation, but one copy you are sending to the cloud. He's checking everything, and if it's okay, then the communication will continue. We have simplified cloud security, means that Cisco has invested a lot inside the DNS security. That umbrella is Cisco umbrella. That suite of protocol is coming under umbrella. And at the moment they are trending, maybe it's a number one DNS security at the moment in the market. So now if you add all these things, you'll find that, okay, my branch, they want firewall type of services, IPS, URL filtering, malware protection, and the DNS security in case if it is hosted over cloud. Even any type of edge devices or branch device, we can connect with the DNS security. We'll go and we'll perform the lab task. If you go to the configuration and you go to the security tab, you'll find that you have the compliance where you can use firewall IPS. Guest access, you can use firewall and URL. Means we have different tabs, inbuilt tabs are there. Okay, for this type of traffic you use these features, for this type of traffic you use this feature. If you directly going to the cloud, you can use combination of firewall, IPS, malware protection, DNS security. Now suppose if your threat surface is 100% open, that means you are directly going to the cloud, say you are directly going to the internet to be more precise, then you use all the features, say firewall, IPS, URL filtering, advanced malware protection, DNS security. Whatever offering that we have from Cisco, you use all those offerings. And then finally we have custom as well. If you want, you can create your custom made policies as well. So let's stop here, and next section onwards, let's start with one by one. We'll see firewall and other features. Let us understand more that how firewall, DNS, URL filtering, all these things are working behind the scene. So here we have the example of firewall, and we have two different type of flows. The important thing here is that the devices, the iOS XE or the ISR routers, they are using N bar to identify the application. And with help of N bar, they identify what is the application ID, and that ID as a metadata, they are sending to the firewall. So then firewall can take decision. Okay, so here you can see the LAN to WAN movement and WAN to LAN movement. Packet is doing the IP destination lookup, then N bar, then DNS security, then VRF, then CEF. So when it is going to the egress, here again you can see the firewall, IPS, URL filtering, AMP, NBAR, NAT, and DNS security. So this is the way that one by one the packet or the application ID has done their lookup, and according to what policy we have configured, so for example URL, AMP, NBAR, they are taking decision. Okay, when the packet is coming from say outside to inside, same type of lookup is there, say firewall, IPS, URL, AMP, DNS, and NBAR. So the packet is categorized in the same way. Now what is important here, that if you see the application firewall, it is recognized by the NBAR engine. The DNS security, this is when we are sending that query to the cloud, and it is coming from the cloud. In both the places we are using, say, encryption DNS method, or we are encrypting the packet and then we are sending to the DNS cloud or Cisco umbrella. Both these things, say application aware firewall or DNS security, they are working inside the iOS data plane. But this IPS IDS web filtering AMP, we are going to use the Linux container for that. Okay, so these are the part of iOS, and this is the rest of the security like IPS IDS web filtering AMP. They are part of Linux container. How it look like, we'll see in the upcoming slides. So before going to the Linux container, you can see the data plane path. So you have N bar, and they put the application ID as a metadata to firewall. And once the firewall is doing three-way handshaking, means SYN-ACK and SYN-ACK, then next time when the packet is coming with certain application ID, the firewall, according to the firewall rule, it is taking decisions. So here you can see the N-bar engine will add the data path once the ABC, application visibility control map. N-bar inspect up to L7 traffic, and N-bar is attaching application ID and putting that metadata to the firewall, so firewall can take decision in the data path or in the data plane. Now when we are talking about the DNS security, in DNS security also, you have the DNS request. It is going to ISR. It is encrypting that DNS request, sending to the cloud. Then cloud, once he will analyze all the packet, then he send the response. Then the response packet means what type of action it has. Either it has to allow or it will go to the internet. So either it can block or it will go to the internet. Then this will take decision. So the summary is that in between to the edge, the ISR and the DNS cloud, we have encrypted communication, encrypted DNS communication, and then the DNS, according to DNS processing, they are taking the decision, either allow it or stop it. Now we already discussed that we have the LXC container for IPS IDS URL filtering and AMP. Here you can see that in data path we have virtual port groups, we have some management port group, we have traffic virtual port group. When it has to take decision, it will go to the control plane, and from there it will take decision. Inside that control plane you have see that we have Linux OS. Over that we have iOS daemon who is tracking this iOS, who is tracking this container. So suppose if any problem with the IPS IDS engine, then iOS can detect that and it will send alarm. Okay, so that's why the vManage will come to know, oh, there is problem with this virtual image that we have in the container. So this IPS runs on the LXC container using control plane resources, traffic punted to the controller using virtual port group interfaces, reserved. So for this you have reserved CPU and memory. So we have reserved CPU and memory for the containers, enable deterministic performance. So you can see that with help of VPG, it is going querying and then it is taking the response, and then in this process, in this way, they used to work. So let's just stop here and we'll continue more detail and depth analysis of all these functions that we have. Let us discuss about container architecture and installation. So this is the container architecture. Here you can see that we have control plane, we have data plane, and we have service plane. So I can push the configuration. I'll go to vManage and I can create the configuration. I can push to the IOST, and from here you can see that it is going towards the control plane and it is going towards the data plane as well. So what is happening when a packet will come, it will do the request. We have the GRE tunnel in between the data plane and the control plane. That GRE tunnel is nothing but termed as a AppNav GRE tunnel. So when the packet will come, it will go to the control plane. Now it will reach to the snort engine, Here in the Snort engine, you can see that we have three different type of boxes: BCTI, Beaker, and TG. BCTI is nothing but the URL filtering, who will take the decision. Beaker is nothing but the AMP, advanced malware protection, and TG is nothing but the threat grid. So obviously we know that behind the scenes Cisco Talos is working, and whenever you have the file, they have some sort of cache here, so that file can go to the Talos in the Cisco cloud, just to check that what is the contents inside that particular file. So again, what is happening here? What is the flow path? Say you are sending the request, it is going to the TZ. From TZ, it will go outside to the cloud to do the lookup, and once they respond, and then the reply will go to the customer. Either you have to block or allow certain type of packets or the files. Correct? So this is the overall internal diagram or picture here, where we have the control plane. IOSD takes care of the app hosting, installation, configuration, provisioning of feature both the service and the data plane. So this is the role of IOSD, who will take care of both the control and data plane. Then we have data plane. In between data plane and the control plane, we have the GRE tunnel, and then we have the service plane. Inside that, we have hoses, open source, Snort engine, AppNav, health, reporting agent, and also it is checking that health and monitor and reporting all sort of stuff. Suppose if something will happen with the Snort engine, then with the service plane, it will inform the IOSD and it will inform the vManage. So internally they are doing this type of communication. Behind the scene, so many things are going on related to this Snort engine, and various boxes that we have, or various functions we have related to URL, AMP, and TG. Alright, so let's see that what is the prerequisite. Here you can see that we have two option: cloud lookup, on box lookup. The only difference between the cloud lookup, inside cloud lookup you have cloud low and cloud medium, where you have IPS, URL filtering, AMP, and the threat grid, that is the TG. In the cloud medium, again you can see the difference is that you have one core and two core. These devices are supported, these devices are supported. The difference between the cloud lookup and on box lookup is that in on box lookup you have local store as well, just to check what is the URL filtering, and then I have the local say database where I can check those contents. In cloud lookup, everything will go to the cloud and it will do the lookup and it will come back. Okay. So next, what I'm going to show you, that how you can go and install this container, what are the steps involved to do the installation. For that, Cisco has given nice document. Let me walk you through that document. So this is the Cisco document that you can go and refer. In this particular document, if we go inside, say, SD-WAN security solution virtual image, so let me go there. So you'll see that how we can go and install the virtual image. That virtual image, Cisco has started with 18.4 image release, that is the vManage image release, that is supporting IPS, IDS, URL filtering, and all those features that we have seen already. These are the supported device list. So what we need to do, first of all, we need CCO account. So we go to the downloads, router, SD-WAN, XE, router, and the ISR platform. Then you will see the list of virtual image. You can go and download that first of all. Once you download, then you go to the log to the vManage, go to the maintenance software repository, choose that virtual image, upload that virtual image. So for example, in the vManage, once you upload that virtual image, then you can go to the configuration and security and you can create all these policies. Now here is one catch, that see, so far what we have done, we have downloaded and uploaded that image to my vManage dashboard. So let me first of all log into the vManage dashboard and show you that. So in our case, it is already downloaded and uploaded to the vManage dashboard. What you can do that you can go to configuration, and if you go to the policies, you can obviously see the say you need to go to the security to see the security policies. But before that, let me go to the maintenance, and here you can see the software repository. Inside the software repository, I can see that, okay, I have the virtual image. This is my virtual image, that is app hosting and LXC container. It has been installed. If you want to upload new image and activate it, you have option. You can upload the virtual image like this, drag and drop here. If you have in the local file system, you can go and upload from the local file system. So once you upload this inside this, what is the next task you want to do? You want to go inside the configuration and the policies, and then you want to create the policies. Again, this is actually the normal policy that we use to create. If you want to create the security policy, then you have to go inside the configuration and the policies. This policy is nothing but security policy. Now inside this security policy, if you go and click add security policy, so now you can see that inside the configuration security, we have add security policy. And then you can see, say, policy related to compliance, guest access, DIA, etc. Now what is important here that I want to mention that, see, at the moment, my branch devices, they don't know those images, because I have installed, uploaded only to the vManage. So suppose if you go and create your first policy, and then you will go and apply this policy to that particular branch device, then it will download that image, okay, to its own, say for example, ISR router, and then it will work. So first time when you deploy the policy, it will take some time, okay, because we are not installing these containers to the uh, branch side devices. So first time they will take some time, but next time onwards, when you create policy, apply or push the policies, then it will not take much of the time. All right, so this is the way that we can go and do that policy installation, and we can create it and apply. We'll see later on how we can apply and create more detail about all these things. Let me walk you through the new dashboard. Cisco has added so many inside this dashboard. If you go and check my old videos where I have used 17.x dashboard, this is something like 19.1 dashboard and the new image purely under Cisco. So here you can see, if I go inside the dashboard, inside dashboard itself, I have 3 dashboard. So I can go and click dashboard. You can see that I have main dashboard, VPN dashboard, security dashboard. Main dashboard, we are very much familiar. What are the contents we have? This is as it is, that in the old code. Then we have the VPN dashboard where I can go and check VPN related thing like, okay, these WAN devices, the health, the total WAN health, and what are the top applications. Then interestingly, we have the security dashboard as well, where we can see security related stuffs. So I can go and check what is the firewall enforcement, means firewall related things. Then I can go and check top signature, means IPS IDS related things, URL filtering related things, and the AMP, advanced malware protection, what is the file reputation, what is the file analysis. So in the dashboard itself, I can go and check. Obviously, everywhere you have this square box, you can go and open that. You can expand that, and then you have the chart and the details. So we have the chart view and the detail view that we have in the old code as well. Apart from that, you can see on the top that you have inspected and you have dropped. So you can go and check that also. We have the timer counter like 1 hour, 3 hour, 12 hour, like that. So we can go and drill down those things as well. This is again from the dashboard. If you want to go and check the individual device and the reports or the graph related to individual devices, then you have to go and click to the monitor, go inside the monitor. So let me go inside any of the edge device. So for example, monitor network. Inside that you can see that we have the WAN edge plus the co-location cluster. Now this is also a new thing that has been added in this new Cisco SD-WAN. Now for example, I will go here to the CSR router, and now here you will see that we have all the old stuffs, like we have the application interface, TCP optimization, WAN throughput, flows, the top talkers. Some of them has been removed. Instead of DPI, I can see we have the WAN throughput. Flows at the moment, no traffic is there, top talkers. But we have the security monitoring as well. So that is the thing I want to highlight. Inside security monitoring, I can go and check firewall. I can go check IPS, URL filtering. I can go check AMP. And now here we have the custom option that I can select, and I can go back in the date and I can select year and months as well. That is not there in the dashboard. In the dashboard, you have only 1 hour to 7 hour, 1 hour to 7 day counter. We can go and check malicious, clean, and unknown logs. URL, DNS direct, those things also we can go and check. Okay, so these things we have, you can see that newly added from Cisco. So we have, you can say that embedded security dashboard inside the actual dashboard. And not only we can see over the main dashboard, that is the vManage dashboard, but we can go device by device and we can check all those things. Correct. In real time also, if you go and see, they have added app hosting commands related to the CLI things. If you want to see over the GUI, so you have added, you have all those new commands. Even Cisco has added EIGRP, so we have EIGRP related commands as well, and some of the new features as well. So many new things has been added. You can see the policy and the data and the app filter and policy QoS, policy zone pair. So many new enhancement and features that we have in the new code. Correct, you can go and check like that. Let me go to the T-shoot as well. In T-shoot, same that we have in the old. Now let me go quickly to the maintenance, and inside the maintenance you can see we have one tab, security as well. So which devices I can go and enable these features like firewall, IPS, URL, advanced malware protection, DNS security. And if you want to see the images, for that also you can go to the software image. This is like the normal one. You can see here we have 19.1.x that is running, and inside the V edges we have 16.11. Then I can go and check the virtual image, that is the actual container that is used for all the firewall and all the security devices. All right.
In this session, we are going to learn about the firewall and the policies. Now, for users, you can see that Cisco has given this nice wizard option that where you have the compliance. If you're creating rules related to compliance, you can use application and intrusion prevention, guest access. You have these options, DCA, direct cloud access. You have these many options. Suppose if you want to mix, or if you want to create your own options, you can go to custom and you can create your own. All right, so first of all, let me log into the dashboard, and from there I will show you that what options we have. So let me log into the vManage. So here I am inside the vManage dashboard, and if you want to go to the security policy, you have to go inside configuration and policies, and then you will get this option for, you have to go inside configuration and security, and then you will get option for security policy. Now suppose if you want to create some new policy, what you can do, you can go and click add security policy, and here you can see all these options.
Suppose if you want to create only firewall policy, so better select custom, click proceed. And now on the top you can see that you have all those options that if you want to mix and match you can use. So you can use firewall, IPS IDS, URL, AMP, DNS security, and then you have the summary. In this case, let's go and see that from where I can create the firewall policy. So here you have to go and click create new policy. Suppose I want to create one policy where I want to block, say, between two zones. So two VPNs, a VPN 10 and VPN 20. You give the description, nice description, what you want to do, and then you can proceed and you can create the rule. So before going proceed and create the rule, I will go back to the PPT. I will walk through a few of the slides and then I'll come back here and then I'll show you that how you can create the policy. So let's go back to the PPT. So here it is. So suppose we are focused on firewall policies. So let us discuss about firewall. We know that Cisco, when they started their security, initially they came with ACL, access control list. Those were not stateful. Those are stateless, means packet by packet, packet by packet. The things will go as per source IP, destination IP, and certain port numbers. Then in the ISR itself, Cisco has introduced zone-based firewall, and that zone-based firewall is nothing but you have option to you can inspect the traffic. So when the traffic is going from out to in, or maybe coming out to in or going in to out, in both the cases you have something called session table, and inside that session table you can see that what is the source, what is the destination, what is the flag, what is the protocol, etc. Okay, so the same way that firewall, say for example, if you know Cisco ASA firewall is working and creating their rule. The same way we have this app aware firewall. The advantage here that they can examine layer 7 header of packet. So that is the nice thing that has been added. So not only that it can inspect the L4, so for example L2 to L4, but it can inspect L7 as well. Why it can inspect L7? Because if you see the previous slides, previous videos, you'll find that we have N bar before the firewall rule, and N bar, what it is doing, that it will recognize the application, and when the metadata is going inside the firewall, they put the app ID. And with that app ID, plus obviously you have the VPN ID as well. So with help of that app ID and VPN ID, he'll come to know, okay, this is this application, and for this application, I have this rule that I need to apply. So this is the mechanism. Not only this is, say, a firewall, but this is app aware firewall. So initially we have one concept in SD-WAN, that is application aware routing. Now you have the application aware firewall as well with help of NBAR, and Cisco is continuously doing innovations in NBAR. Initially it was NBAR 1, now it is NBAR 2. Even new releases also come, means they are improving the NBAR code to recognize the application. So at the moment you can see that it can check up to 1400 plus application as a layer 4 application. Drop traffic by application category. Yes, we can. He can. This particular file can understand the application as well. So applications, those are coming from cloud or any private or public hosted cloud also. He can inspect that, and according to that he can take the decision. He understand the segment as well, because he knows that which segment I have to put the rule. All the PCI compliances are there. High speed logging also they can understand. They have the self zone policy as well. So new features have been added, and we'll see in future again Cisco will add some more feature related to security. Now this firewall can protect from intra-zone, means same VPN. So for example VPN 10 or 20 within the site or across the site also. They are using drop, inspect, and pass. So these three options we have. This is purely related to Cisco old technology, that is zone based firewall technology, that all the actions it is taking. Now the second option we have that across the VPN if you want to put the policy. Suppose VPN 1 and VPN 2, but remember you need to do some sort of route linking, because by default two different VPN or VRF, they will not communicate. So you should have to do route linking first with the say for example vSmart policy, and then you need to create the policy, or then you need to go and create this zoning firewall policy. So first it will check the routing. Obviously if you have route, then only you will apply certain firewalling rule. So you should have the route and then you can apply this policy. How you can do it? You can go to the configuration and security, and then you have the security policy. You can go to this section. I will walk you all the steps how you can go and create the rule from the vmanage. You create the rule and then you have to push this rule inside the template. I will show you that how you can go and push the rule. So for example, I'll go to branch number 3 and I'll create first of all, I'll do the route linking. So branch 1 and branch 3. So for example, you can see the local subnet is 10.3. In this diagram, you can see 10.3, 10.0 something. And here is the local subnet is 10.5, 10.0. This is the local subnet. This is the local subnet. So according to that, I will create some policy. But before that, I will do the route linking policy so they can communicate, and then we'll apply the firewall policy. How you are going to create and apply the firewall policy? You need to define what is the inside zone, what is the outside zone. Say in my case, I'm going to use say a VPN 10 and VPN 20. So my lab is a bit different. I have zone security, say call Corp. Corp is VPN 10, and then I have say zone security called PCI, that having a VPN 20. So like that, I will use these two things. I will also go and match. So while creating the policy, I will match certain traffic, but basically I want to match IP traffic. If you match IP, obviously you'll match everything, but I'll show you that how you can go and match certain protocols, because we have feature up to L7 mapping. Once I will do this step, once I will do these and these steps in the GUI itself, so we don't have to go and type all the commands. In the GUI itself, the logic is very clear. So you create the zone, you create the zone security, you create the map it inside the zone pair security, and automatically you will see once I apply this policy, automatically this policy map, class map, everything you can see. So if you see the CLI, if you want to check the CLI, create zone related command first. Then obviously you should have class as well, because this class you need to call inside to outside class. Here you can see the service policy type inspect is inside to outside. Finally, you have to call here that class, the policy map, and then inside to outside, the class type is inside to outside, and what action inspect default is job. So same type of policy I'm going to create. I will tell you that what policy and what are the things are there in my example. Then finally, if you want to create some ABC type of policy, that also you can do. So you can create one another class, name ABC class. You can map or you can match those protocols. With those protocols, you can take these actions. Then here you can see that I am calling class map same inspect, and then again inside that I am calling service policy ABC policy, and then I'm applying it. Okay, so all these options are actually, if you do via the GUI, automatically things will come, it will pop up, it will ask you, oh, you want to do this, you want to do this, and you can easily go and achieve all these tasks. So let me stop here, and the next section we'll do the labs. We'll create the route leak policy and then the zoning policy. Later on we can go and add and delete something inside the zoning policy. In this section we'll create the firewall policy for the same zone. So for example, I have two branches. Let me draw here the branches. I have branch number, say for example 1, and I have branch number 3 where I have actually logged in. Inside that, for VPN say 40 or VRF 40, so both the places VRF 40, here I have one Windows system. So first of all, I'll show you that what IP addresses we have inside the VRF, and then from this Windows system I'll try to ping this place. After the firewall policy will block that. Okay, so let's do that testing inside the same VPN, say 40 zone. Let's do that. So let me log in and show you all those configuration, because what are the things I want to do? I will create data prefix list as well. So what is my source IP, what is my destination IP prefix, all those things step by step will create and will understand all the flow. So if I go here to the device, so for example branch 1, and if I type say show IP interface brief, in my case the VRF that is associated with VPN or VRF 40 or VPN 40 is nothing but gig 7. So if I go there and if I show you the configuration, here you can see this is the VRF 40, this is the IP. So this is the IP. I'll make this as a destination and then I'll ping show IP interface say gig 7. From this particular subnet I will ping, that is 10.540. So my source is nothing but 10.540.0/24. Destination is nothing but 10.340. So let me do the RDP, because here in this network I have one machine. Say let me show you that 10.540.10 from where I can RDP. So I'll go and RDP to 10.540.10 and then I will ping to 10.340.2. So let me log in. So here you can see that IP is 10.540.14, and if I ping to 10.3.40.2, that is the branch 1 IP. So I'm able to reach. What I will do after creating the policy from the same zone policy, it should block. So let's go and create that policy. I will go to configuration and policy. Once I am inside the configuration and policy, I just wanted to add some list. So data prefix list that I'm going to use. So I'll make this a firewall source, and that I know that source is nothing but this is IPv4. The IP is set, for example, 10.5.40.14 also I can use. This is the source wants to reach to destination, or I can do one thing, I can use this complete subnet, add it, and then the destination. So we know that in firewall we have 3 mode: drop, inspect, and pass. We'll see that all those modes. I'm going to use inspect, so my session table will know, okay, this is the source going towards the destination. And then again, if you want to drop, you can drop it. So firewall, this is the destination. What's the destination? Destination is nothing but 10.3.40.0/24. So we are going to use these lists, and I don't want to create any other thing because I want to create the security policy. I'll go here to the policy, I will click add, and actually I need to add one policy, so go here and add one policy. At the moment I will click custom, because once you are inside the custom, you will get all the options. On the top you can see you have all the options. I want to create new policy, and the policy is nothing but say firewall inspect, because I want to inspect first of all, and this is firewall inspect rule, say for example between or rule in same VRF. that is VRF10, or sorry, that is VRF40. So this is a rule I want to create. Let me expand, let me increase the font size. I'll go here, click sequence rule. What is your source? So my source data prefix is, just now we have created source is the firewall and the source where it is. So firewall source. All right. What is your destination data prefix? So destination also we have created. Destination is nothing but the firewall destination. Okay. Now I have the source, I have the destination. What you want to do? I want to inspect one of the protocol, that is ICMP. The protocol number is 1. Save here. Once you save this policy, you can see that on the top you have drop enable. Actually this will come in the last. If you see the CLI, you'll find this is the default statement. So this is the main policy that we have created related to our firewall. There's the source and the destination and the block. Okay, so I'll go and save this policy, but here in the rule column you can see I have one rule. I should allow that what is the VPN you are looking for. So you'll go here and click apply zone pairs. Already we have the zones created. I can simply go and use. So for example, this is nothing but VPN 40, that is guest inside, and that is nothing but 40 because we are going to apply the policy in the same. So now you can see the source that will take the prefix, that is nothing but 10.5.40.0. Inside VPN 40, the rule will be applied to the destination, that will take the destination inside VPN 40 or VRF 40, that is 10.3.40.0. This is the rule we have. Let me save this policy. Click next. Now these things I don't want at the moment, so I'll skip all these steps. And in the last here, so firewall policy, that is nothing but summary. Firewall policy, say for VRF10, firewall policy to block something, to block, sorry for that, to block VRF, actually that is not 1040 traffic. I should give the correct name. Alright, so we are very much done. Now here you can see the setting, firewall, direct internet application. If you want direct internet local exit to the VPN 0 or through the VPN 0, you can use this option. If you want to protect it from the DOS TCP attack, you can go and enable this. You can give what is the number of sessions you want to enable it. So let me do one thing, say maximum 60. Now you have this option to preview. So before saving that policy, you can go and preview. You have the zone based policy, that is the firewall inspect, which is the source, what is the destination, what is the protocol. Say by default it is taking drop. I should go in the action and I can convert this into inspect, otherwise it will drop. So I will do that. Then default action is drop. Then what is your VPN, what is your zone pair, what is the direction of the policy, what is the access list or prefix list you are using, what is the subnets inside the prefix list. TCP SYN flood limit is 60 and the internet zone that we have by default, it is denied. So before saving this policy, I'll go back because one place I can see that I should edit this. So I'll go back to the firewall. I'll go back here and I go to edit section, because in this action bar I need to go to the action and I need to inspect this. I want to inspect actually. So you can see 3 methods: inspect, pass and drop. Now save it. First of all, you need to save this sequence first, and then it will tell you to save this policy. Save it, and then I'll scroll next, 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 next. we are in the correct place. I'll do the preview, and here you can see the action is inspect. So now we can save this policy. Now we have the policy built, but we should go inside the template and attach with the devices. So branch 1 and branch 3, I will go and attach this particular template with branch 3 and branch, not this template, actually it's not like that. We should go and edit this template. So you should go here, and if you go to the additional template, in the bottom you can see that you can call one policy, update this, and since this particular template is connected with two devices, I want to update in this only, that is the below one. So you can go there, and if you want to see that what is the old policy and what is the new policy difference, then that is also, you can go scroll, and you have side by side difference option as well. So you can click here, side by side difference. If you go scroll down, and you can see that what are the new things you are adding here. So here you can see that we are adding the class map and the other stuffs as well. Although in the configuration it was showing that we have created only the zone and zone pair and the policy direction, but here everything is created like class map, policy map, inspect, all those things you can go and verify. Alright, so likely we'll scroll down and we'll configure the device. You have two devices you want to attach. Yes, I have two. I want to attach with both the edge devices. Like that, I'll go to the template number 3, that is for the branch number 3. I'll click edit. Here also I'll go and click additional template. I will select what we have created to filter VPN 40 traffic. Go next, configure it. And while it is pushing the template, let me go and log into the CLI to the devices, and let me show you the configuration change. So here in the CLI, you can go and check the object group. You can see we have two objects for 30 and 40, and we are blocking ICMP, that is protocol number 1. Then you can go and check show IP access list. So here you have the access list firewall inspect, and this is the object group policy, very much that we are using in the ASA firewall, same type of pattern we have. Now you can go and check type map, class map type inspect, that is for the zone based firewall, so it is in the class map. Then parallelly I can go and check policy map type inspect. So here also you can see the rule is inspect. Then you can go and check the zone, and then you can go and check zone pair as well, zone pair security. So these are the verification things that you can do. Now if you want to see the session, for that you need to go inside the policy map and then say, let's see what options we have. So I can go to the policy map and then the session. We should use type inspect, and then we'll can go like this. So zone pair and the session. Likewise, I can simply go to the zone pair, and here you can see that we have the inspect session. What is the half open established connection? All those things are coming as per the rule, correct? So same thing I can go and check to the other device also, because we should verify that that policy is pushed down to the devices. They has been pushed down. Alright, so next what we'll do, we will initiate the traffic. So let me go to the session, and I have initiated the traffic from the source. Now if I go back to the CLI, you can see the session. See, this is the source, this is the destination, ICMP is open. So my firewall is able to track the session. And here I can see that ICMP packets and they are increasing, see 194 and all those things. So now we have the open session and we can go and verify. If I go and change the policy, means suppose if I want to drop that, then what I will do, I will go here and I'll change the policy. So let's go to the configuration and the security policy. We'll go here and click edit and we'll go to the firewall and the say edit. Go here and click this pencil button. What you want in the action, I want to drop and log. Save this policy. Before saving this, I should save the sequence. Save the policy. Yes, I want to push log. It has been in log mode because we are doing some dynamic changes. But yeah, next time if you go and click here to the drop this, it will obviously go and drop this policy and template policy locked in the edit mode. It got locked because of it was ongoing process and we try to use that. If we go to the tools and let's see that if we can reset the user in the administration and manage user. If I can go and reset this user, let me see if we have the option to reset that user in the tools, in the operational commands. So if I go to say for example branch 1 ch1 reset locked user and admin reset, failed to reset the user. So this is one option actually they have given to reset the users as well. Otherwise we need to wait till that error will go and then we can do some changes. But best way is that if you have applied some policy, do not change it when it is doing its work. So what will happen, the vmanage will lock that user. So be careful while you are doing any dynamic change, but in the lab environment we can do that just to verify that if I do any change in the policy, it has the effect. So I'll click here drop and log and let's see if it can push this policy and let's see. Okay, it is reset, but you have seen that how we can create the policies, how we can apply this policy, and then how we can verify from the CLI. In the vmanage, it is taking some time to come and display all those information. So if you want to see from the vmanage, what you can do, that you can go to the monitor and inside monitor you have the network option. Inside the network option you can go to branch 3 ch1. Inside that you can see that you have firewall. You can go inside the firewall and you can see 1 hour counter. So to display inside the vmanage it is taking some time, but from CLI you can quickly go and check. Alright, so let's stop here. In this case I want to create firewall policy with different zone. Now if we are using different zone policy, that means I should have one policy, control policy or routing policy, that allow different VPN or VRF to do the route leak. So first of all I need to do the route leak. I'll do between the VPN 10 and VPN. So for example I have one test PC 10 and 40. So I need to create the route leak first. Then I will create the firewall policy. That firewall policy this time will take source as say VPN 10, say take VPN 40, and the destination I will take the IP inside the VPN 10. Before that, we'll do that testing that, okay, VPN 10 and 20, after route leaking, they are pinging to themselves, and then we'll create the policy. Okay, so let's go to the vmanage and create the route leak policy first. Then we'll come back and do the verification. So let's go there. All right, so I am here in the vmanage, and from vmanage also, if you want, and go to the tools. If you go to the branch number, say for example, if I go here to branch number 3 and I can log in here. Once I log in, I can go and check show IP interface brief. First of all, I want to know that what is the IP address actually of branch number 1 CH1. So I'll go here to branch 1 CH1 and let me log in. So once I logged in here, let me make some more space. What is the IP here? We know that inside the VPN or the VRF10 we have IP 10.3, and here if you go and if you ping to the VRF, say for example 10, that IP is 10.3 10.2. Let's confirm that should be 10.3 10.3 10.2. that's correct. So if you are pinged to that VRF, I should able to reach because all the VRFs are able to ping. But if I go to this place, if I ping from VRF 40 to VRF 10 from other side, this will be not successful, correct? Because we haven't done the inter VRF routing. So for that, first of all, I will do this route leaking from 10.3 10.0 to 10.5. What's this? 10.5.40.0. So 10.5.40.0. So what I'm going to do, first of all, I will create one policy with these two subnets. This will be the source, or I am going to do the route leak with 10.5.40 with 10.3.10. So let's go here to the policies. We'll create one policy. Here I need here I need prefixes, not the data prefix, because it is going to be the control policy. So I should use these prefixes, and this is for example, say branch 3 and say VPN, branch 3 VPN 40. What's the IP? The IP is 10.5.40.0/24. 100% correct. Then I'll add one more. What is this? This is nothing but branch 1 VPN 10, and that is 10.3.10.0/24. Correct. Now we can easily go next. Let me fix the screen size first. I can go and click add the route and control policy. What is this? This is route leak policy. Yes, this is route leak policy, and I can reuse the name, so I'll copy that. Alright, so let's go and add the route. What is that? That is nothing but source and destination leaking. So what is happening in this case, that you go and you select the site. What is the site you have? The site is, say for example, branch 1. This site having the prefix, although we have the VPN and prefix both. So this side had the VPN. If you want to match all the routes, you can use that also. So the VPN is nothing. Let me scroll down. So what I want, that my VPN is 10, and the prefix is that we have created This is the prefix. So match the route, match the VPN, and take the action. In the action, accept it and export to VPN 40. That is what, let me scroll down, that is something like guest VPN. So this is one statement. This time, next time what we are going to do, next time also we'll match the site. So what's the site you have? You have site number 3, where it is, branch number 3. Then what other things you have? Then I have VPN. What VPN you have? VPN is the guest. Let me scroll down. And then what prefix inside that? So prefix we have taken it as a branch 3 VPN 40. So now this case what we are doing, we are matching the VPN that is guest, and in the action we will export towards the, so I'll go to the action and accept it and export to VPN 10. That is my VPN or corporate VPN. Alright, so let's go and save this policy first. Go to the default action. For example, I will accept. And this is purely that we are doing the say route leaking. You can refer the old training videos as well for that. Because since this is the route leak policy, I am going to apply this policy to the inbound direction of say branch number 1 and branch number 3. Even I can select all branches as well if I want. But let's see branch 1 and branch 3. Click add, preview this policy. Now this is your policy. Taking the route of branch 1 of VPN 10, you can see the prefix also we have created, and send to guest. Take the guest, send to VPN, apply to the inward direction. Save this, and before doing anything, I will go here to the RDP, and if I ping, so let me complete the session first. Alright, so still it is pinging. Let me stop this session, and now if I ping to 10, sorry, let me use that correct, ping to 10.3.10.2, this is actually the IP address in the different VRF. We created the policy, we haven't applied the policy, correct? So this will not work. To do the route leak policy that should work, you should go and apply this policy. So 10.3, you can see different VRF is not working. So what I'll do, I will go back to this place, route policy. I will click activate this. And once you activate, if the policy will push, then you'll find that now from VRF 40, from one of the PC, you are able to reach to the gateway that is the other side that is inside the VRF 10. So we'll wait till the policy will get pushed, and then we'll see this output. This should ping. So once it will ping, the next stage or a step is to go and create the firewall policy and then do the inspection for this particular traffic. So after applying the policy, I can't see that I'm able to ping, but if I go here to branch 3 and if I check the routes, I am learning the routes inside say VRF 40. So inside VRF 40, you can see that I am learning the 10 route, and suppose if I ping that 10.3.10.2, and I should use the VRF, so ping inside the VRF, say 10.3, what's that, 10.3.10.2, correct? So from router I am able to ping. If I see any other IP behind that gateway, this is one of the other workstation. So from router I am able to ping, but this is connected, means inside this network I have another PC, and from here I am not able to ping. So what I'll do, I'll go and first of all I deactivate the security policy. So I'll go here and I should remove from the template, and then I should deactivate or remove this. So let's go to the template. Here I have the template number 3. Let me go to edit, additional template. I don't want the policy at the moment, leave it, update, next. And same I will do with the other device, that is the branch 1 devices. So I'll go here, edit, and inside this template also I don't want it, so let me go and update. I don't have any security policy. Yes, confirmed from the 2 devices. And then let me see the RDP ping is happening or not from the route leaking policy. So now it is working. So you can see that in the different session, means in the different VRF, I can ping from my this PC. So route leaking is working. If you want to verify further from the VS Smart, if you go and check show run policy, you can see this route leaking policy, full-fledged route leaking policy is here, and that's why different devices can talk to each other. So let's stop here, and in the next section I'll create different zone firewall policy, and then we'll see that in the inspection rule it is coming here or not, how we can inspect that policy. All right, now we'll go and create the firewall policy. So for that you should go inside the security, and before even going to the security you should go and check the list. Do you have the data list? What is the source and what's the destination you have? So here you can see in the list, I have list. Where is my source? So here you'll see that I have the source 10.540.0, that is the source. And where is the destination? So if you go and check the destination, firewall destination is 10.3. This is the new destination. Yeah, 10.3, 10.0. So this is the source, this is the destination. Across 2 different VRF that we have where we want to put the rule. So we'll go back here to the security. Inside security, I want to add new security policy. I'll use compliance because it has only 2 options, so I can skip easily. I'll create new rule. Say inspect VRFs, and I'll copy this so I can use the same name all the time. Then I'll go and add what is the source. So we have the source, that is nothing but the firewall source. Let me scroll down. This is the source, that is 10.540. And then we have the destination as well. What's the destination prefix I have? So let me add that also. Let me scroll down. I have this destination prefix, that is nothing but new destination 10.3, 10.0. And then I'll go and add the protocol number 1, that will be for ICMP. So let me add that. Then I'll go to the action. Inside the action I will do inspect, and we are very much good with this particular rule. You can see how easily we can create the firewall rule. Now we'll go and add the zone. What is the source zone? What is the destination zone? Source zone is VPN, say for example 40. So that I have guessed. If you want to create, you can click here, create new zone list, that also you can create. So this is for, say for example, VPN 40. I will add 40 here, but already we have one there. I can use that also. Let's use ours, VPN 40, and then where it is going to the corporate, that is the VPN 10. Save, and now you can see the arrow. I'm applying inter VRF type of firewall policy. Save the firewall policy. You can go next, you skip the IPS. Here also I'll give the same name, and we are not using the DIA and the SYN flood things. If you click preview, See, this much of CLI equivalence has been generated. So we have the source and we have the destination, and what we are doing, inspect the traffic. Save this policy, because after saving this policy you have to go inside the template and you need to edit the template, because you are going to add these rules inside the security option here that you have. So inspect the VRF, update it, because template lock edit mode, multiple edits. Okay, so same user has opened multiple sessions, so that's why it is in the lock mode. Let me try one more time if I can add this, update, and I can go next. So this will update 2 of the branch 1 devices, that's okay. And then next I will go to the template and I will add this branch 3. So I'll go inside the branch 3 in the additional template and then I will add it. Once I add it, then I have to go and verify this. So this also is locked. What I can do, that I'll go again, I'll log out and I log in one more time. So he will allow me to edit that. So let me go back to that template, because if you do multiple operation at the time, then it will throw some error. So we'll go here to the additional template and we'll add this particular inspect VRF, update it. Still it is showing the same error, so we'll wait. Let me try one more time, because one of the process is going on. This template is in locked mode. So if these are the cases that you will face, you do one thing, you create the copy, say copy number 1, and then try to push from here. So now go, first of all, edit this template. Everything will be the same in this template. This is not attached to anything. I'll go and update this one, and then I will go to copy 1 and then I will attach the device. That is nothing but your 10501. Once I attach this, then I will go to the CLI and I will see that configuration change are there or not. Log in via the CLI and then you can check the zone. I can see 10 and 40, that is working perfectly fine. Then I'll go to this particular branch 3 and then I'll go and check the, say, policy map, type inspect, zone session, and this is working. Now next task is this, that I will go to the RDP session that I have, and from there I will initiate the traffic towards the destination, and then I will go to the session, and here you can see the session. Okay, so it is working perfectly fine. And if I go and check the zone pair, so here you can see the number of packets, the timing is increasing. I can see that one session is there, is session last created 25 seconds, 29 seconds, and in the session I can see this is going on. So this is the way that we can verify the firewall rule across different VRF. Next we have intrusion prevention and detection. With help of intrusion prevention, we have very powerful engine inside the Cisco IPS and IDS, and that is nothing but the SNOT. It is most widely used IPS IDS engine, and that is backed with the Talos team. Talos team is a Cisco engineering team. They are using some sort of machine learning and other mechanism to build and update the cloud signature or cloud system. So if any new threat will come, already those anti-signature or to protect from those signatures and threats will be updated in the Talos. So this is again backed by the Cisco team, and that's very powerful. That is integrated with the IPS IDS system for the cloud lookup. Then this IPS IDS, they are supporting the signature whitelist support as well. They can analyze the real-time traffic as well, and it is PCI compliance. Earlier we have discussed about that how this look like, because we are not putting everything on the box, but you can see that my control plane is hosted over LXC container. Inside that Linux container, we have IPS, AMP, URL filtering. So now we have the segregation of firewall and the IPS, IDS, and the AMP URL. That in the control plane over the different CPU, memory, RAM, I have the Linux container. Now what is happening that the communication, when the data packet will come and he wants to do the lookup, at that time we have something called AppNav, GRE tunnel. So for the lookup, with help of that tunnel, it will go to the control plane, and then as per the instruction, we have the permission like block or drop or allow, etc. So it will take the action. That's why we have the virtual port group. That port group is nothing but to do the communication from the data plane or from the data path to the control path. Correct? So likewise, that all the IPS signature work here, this will work. This our IPS will work in the same way. You can see that packets which are marked for inspection will be diverted from data plane to the SNOT via the UTT divert FIA. Once the diversion will happen, obviously it will detect, and then it will take the action, and then the output and the logs will come into the picture. Based on the status reported by AppNav, means again we have the AppNav, and if you see the earlier video, you'll find that we have the service section as well, where it will collect the stats related to open, fail, and health monitoring states, etc. Okay. So if you see the configuration, while it's very easy, I'll go and walk you through the configuration. In the configuration, you'll find that you have policy name, signature set, that is balanced, and we have three options. I'll walk you all those options. We have detection, and we have say IDS and IPS, both we have in the mode. So either it will work as a engine who will take the action or only generate the log, that is the IDS. Then we'll see the other options as well. Once I log in, then I'll tell you all the options that we have inside the vManage. Once you create the policy via the GUI, and if you go and check in the CLI, you'll find you have different section. So first section, that the device, they will download this appliance. So whatever we have hosted over the so vManage, so we have the app hosting installed like this. So this is one of the command, it will be downloaded. Then they will create various virtual ports for the communication from the data path to the control path. Then we have the activate virtual service configuration, IOX based configuration, that is app hosting configuration, what is the virtual port group, what is the guest interface. Now all these things actually we are not worried to know that okay, what does it mean, because it's here you can see it's very difficult to configure via the CLI. So we have better option that we can go and configure via the GUI. Then finally you have the step 4, that is related to service plane, that your UTD engine standard multi-tenancy, where you are defining the signature and the action. Finally in the data plane we are going to apply it. So what action? If the session is fail, still you will pass the packet or you will close the session. Okay. So these are the CLI equivalence things that we will see once we create the policy. Once we push the policy, then you will find that the CLI equivalence. So let's just stop here. We'll log into the vManage, we'll create the policy, and then we'll see the CLI equivalence. So let us see that how we can build the policy. You can go to the configuration and the security. So for example, I will take the compliance policy where I have the firewall and the IPS. Okay, so I will add one firewall policy as well. Say I have already one or two policies created. So for example, inspect VRF and do. So now I have the firewall policy. I'll go and add the intrusion policy, create the new policy. What's the name? So IPS for VPN 10. You can see that signature set is balanced. You have three options: connectivity and security. Connectivity will process 15,000 signature, balance will 10,000, and security will more to that. We have the inspection mode, detection, and the protection. That is the IPS and IDS. IDS will generate the log. IPS will actually stop that session. Then in the advanced session, you can see that you can, if you have your own signature, you can go and put here. The alert log label is error. That is fair enough, but you can go and check other labels as well. Then I want to put the VPN target. What's the VPN I want to inspect is, say for example, VPN 10. Then we can go and save this. We are almost done with the policy. Say firewall and IPS for VPN 10 and do. Then here in the bottom you can see that I can give the firewall direct internet access that we have already discussed, but I can use the external syslog server. So for IPS and URL filtering, if you want to select or if you want to collect the log to the external syslog server, you can go and give the VPN and the IP. And the failure mode has two options, either open or close. So if anything will happen with IPS, still the session is open, or if you want to drop, then you can choose the close session. Alright, click here preview, and now you can see that you have your IPS rule here. Then we have the zone based firewall configurations as well. We can save it, because anyways we have to go inside the configuration and the template. And so for example, I want to apply this to one of the branch, that is the branch type 3 or the branch number 3. So I will go click edit. Inside edit I have this additional template, and then you have the security policy option. We'll go and use firewall IPS for VPN 10. Then you can see factory default UDD template, it is coming by default. Let me scroll a little bit down if I can scroll a little bit further. Default UTD template setting, what it is, default, so it is telling please upload the compatible app hosting image, and it is telling the path which is already there. That is again the container profile that we are uploading. Now it will push this configuration, and if I want to see the difference of the configuration, I can go here and click conf difference. I want side by side difference. Let me scroll down so we can see what changes we are doing. Alright, so let me scroll down. Oops. Let me go back and scroll down, so we'll check it. Although the fonts are a little bit smaller. So here you can see the inspect the VRF, that is okay. IP NAT for UTD NAT ACL, overload to the interface gigabit, IP NAT global class map, those are the old configuration policy map. You can see long list of configuration, correct? In the vEdge, in the traditional vEdge that we used to work, there we don't have this long list of configuration. Now here you can see that I have interface virtual port group, VRF forwarding 65529, the IP address is 1.1. Then I have a virtual port group 0 and 1, and these are the two new IP addresses that I have. So I have two port group 0 and 1, and with two IP addresses that I can see in the green. Then you can see full IOX configuration, correct? Full IOX configuration, and here you can match the IP addresses as well. You have the app VNIC, means the communication between the data path and the control plane. Then you can see you have UTD multi-tenancy, and the policy is balanced, and whatever policy that we have configured, it is there. then policy UTD, you can see that is applied over VPN or VRF10, and this is the full configuration. So before doing anything, what I want to do, let me go and log into the device. Here is my device, and if I show you the IP interface brief, that is our old Cisco command. Then what interfaces I have here, you can see I have gig interfaces and few tunnel interfaces like 2, 3, 4. Now after pushing this policy, let's see that how many new interfaces we have and what type of configurations we have. You will go and check. So once it will push the configuration, if I do show IP interface brief, you can see if the configuration is successful. So let's go back and check if the configuration is successful. So still it is scheduled, it will take some time. Device need app installation. Yeah, if you are doing first time configuration, it will take time. So maybe sometimes it will take 15 to 20 minutes. We need to wait till that time, but it is taking this time just for first time deployment. Next time onward, it will not take this time. So I'll do one thing, I'll pause the recording, and then once it is 100% successful, I'll come back and I'll show you the CLI equivalence that is had put to the device. Okay, so let's stop here. Let's pause here. So while it is taking too much time, let's stop this recording here, and in the next section we'll do the verification, that is the CLI verifications. In my case, it took exactly 7 to 10 minutes to install that. Now if you go here and in the bottom see that I have two virtual port group 0 and 1. If I go and show you the configuration, say UTT, here you can see that I have app hosting, and inside that app hosting you can see that I have the VNIC gateway, virtual port group, guest interfaces, and these IP addresses. Plus you can see the UTT configuration here. We have this much configuration with that particular VRF. Apart from that, I can go and check the app hosting as well. So if I go and check, this is the same configuration that related to app hosting that we are getting in the UTD. So we have these configuration. Apart from that, if you want to check the policy, you can go and check the policy. And here we have the policy. So let me scroll little bit up so you can see the policy. So we'll see the policy where, yeah, here is the policy balanced, policy UTT, VRF, VRF10, all interfaces. So whatever we have seen in the GUI, while pushing the configuration, it is coming here. Now if you want to verify from the CLI, you can go and check show UTD, say engine, and then standard. Then if you want to see some sort of logging, you can go and check the logging. And if you have some, say, logging and events and stats, so events, if any events is there, it will generate that event. Means if any traffic that is being inspected by the IPS engine, it will show you that. From the dashboard, how you can see that? So you can go here to the dashboard and the repository and the security. On top, you can see that firewall is running on edge 1, branch 1, edge 1, 2, and branch 3. Like that, if you go here and you can check, the IPS is running on this system IP. This is the model reachable, this is running. So this is a place we can go and identify which are the services are running on which of the devices. Correct? Now, if you want to go inside the monitor and the network and the branch number 2, so sorry, branch number 3, and here if you go to the IPS section, so here if you have any alert and any severity, these will come. So if I have any anomaly related to that balance signature, I can go and check here in this section. Okay, so this is the way that you can check You can verify from the GUI and you can verify from the CLI configuration as well. Although it's very lengthy and tedious to configure via CLI, so preferred that we'll do this via the GUI, and in GUI also we can go and observe. Now for troubleshooting and verification, obviously we have to go to the CLI and we have to check the logs and the T-shoot options, because to come and pop to the vManage dashboard, it may take some time. Okay. Now we have case number 2, where we are going to study about the guest access. Here you can see the attack surface is like 50-50. What type of mechanism we can use inside our SD-WAN protocol suite? That we can use app aware firewall, we have the segmentation, and we have DNS or URL filtering. So both the things in a mix match we can use. If you go and click to the guest access, although you will find option for firewall and URL filtering, but all the time you have option that you can go to custom, and then you can use DNA security as well, or DNS security as well. Okay. So here you can see that you have customer that is going towards the backhaul and then going to the internet, but you have guest access that is going directly to the internet, and that is increasing the attack surface. What type of attacks are possible? So there may be phishing attack, vulnerability endpoints, unpatched OS, DOS attack, guest users. Means directly I am exposed to the internet. So these type of threat vectors are there. Obviously, your attack surface is internet, guest network, guest segmentation. What security tools we have from SD-WAN? From SD-WAN, we can use app-aware firewall policies. We have DNS or web layer security. We can do the URL filtering. So suppose if we want to do the URL filtering, what capabilities we are getting from the URL filtering? You can see that we can do the whitelist model. We can block, allow certain content, categories, reputation. So whatever allowed there, it will be allowed. If they hit the block list or the blacklist, it will go and cancelled. And obviously we have the customizable end user notification as well. We'll see that. This we are going to configure, and we'll see that what are the configurational options we have inside the vManage dashboard. Now, for example, when a user he send the request, so what is happening, you can see here that he can send the URL request. It will go to the snort. Inside the snort, so snort HTTP parser, that URL sent to the URL filter engine, it will send to the engine. So you are sending the request to the so from data plane, it will obviously you have the virtual port groups here. So you have port groups that you want to connect from the data plane to the control plane. Inside the control plane, from parser, it will go to the engine. Inside engine, you'll find that you have whitelist, you have blacklist, you have category, you have reputation. These options are there even when we'll go to the vManage, and when we configure the rule as a guest access rule, at that time you will find that inside URL filtering we have all these options. So suppose if this particular request is allowed, you will get the response from the engine. If it is allowed, obviously you can go and open the website or you can surf it. If it is blocked, either it will redirect you to certain site or it will send you block page message. So you can create your block page message, or you can redirect to some other place. Okay, all this policy you have to go to the vManage dashboard, and from there you have to create the policy. How we can go and create the policy, we'll see in the upcoming section. And this is the CLI equivalence. Again, you can see that we have configuration related to virtual services. We have port group that will go and contact with the control plane. We have app hosting configuration, and then we have the URL configuration. Although you can see the configuration list is very big, because if you add more and more whitelist and blacklist and the categories that you can define from the GUI, although it is easy, and the CLI equivalence, you can see that this many CLI configurations are there. So let's stop here, and next section will go and build the policy.
In this scenario, we'll learn that how we can create the URL policy. So you can go to the add policy and you can see that guest access, where you can have the firewall policy and the URL policy. What I will do that we have already created one firewall policy. So I will go and call this policy. This is for URL or say with URL. And then policy description is firewall plus URL. So I can give any name. Let's copy this. So now I have the firewall policy that I called. Let's go and learn how we can create this URL filtering policy. So obviously you should have the app hosting image that is over the Alexi container. Create new. I want to create new policy. Now you can see on your dashboard that on the top it is telling that okay, what is the block category, what is the web reputation, what is the whitelist URL, blacklist URL, what is the block page, what is the blacklist and all. So what we'll do, we'll go scroll down and one by one we'll create the policy. So this is a URL policy for access. So you can give any name. Now web category block, what you want to block. So for example, I just to showcase, I want to block say business and economy, and let's do not block this. So obviously you can see there are so many sites that we can simply go and click block, like the drug, alcohol, like that. And let me scroll down botnet. So it depends that what type of things and what is your corporate policy, what type of URLs you want to block. Let me scroll down. So I'm just looking if I have any say social networking. So I can go and verify, for example, facebook.com or LinkedIn. Those things I can go and verify because these I am putting inside the block category. So I have this social networking that is block, yes. So now you can see that I have added the category as block, and inside that block I have added these many block listed. So whatever things are allowed, say if I go and click here, you will see that I can specify the allow list as well, and in the allow list I can go and add certain things. So at the moment I took this block, these I want to block. The web reputation, you can see that's by default moderate risk. You can make them, say for example, suspicious, and on the top you can see the block category 5 reputation is suspicious. Then we'll go further, we'll go and click to the advanced, and in the advanced also we can choose certain options. So let me scroll, let me decrease the size. So in advanced it is asking what is the whitelist URL. I want whitelist URL Cisco, www.cisco.com. If you have more, you will go and add. So now you can give the specific URL entry that you want to whitelist. You can go and add the whitelist URL. You can import that file if you have. Alright, and then here you can see that you have the blacklist as well. So let me scroll a little bit down, yeah, a little bit up. Whitelist, blacklist what you want. Say for example, I want CNN.com. I want to block that. It is in my blacklist, so I will go here and type say www.cnn.com. Save this. Now required can include only alphanumerical character hyphen maximum. So what I can do, first of all, give the name, say for example CNN. Just I'm giving you one example, and then you can go and import the file if we have this file. So
www.ccnn.com. Save this, but we have option to import as well. So now you can see that we have the whitelist, we have the blacklist, both I have chosen. Then I can scroll down and in the bottom you can say block page content. If it will block, it will give you this message: access to the requested page is prohibited. And I can give any other comment. Check with your network admin, or you can redirect to certain URL. Then in the alerts, what you want, I want alert for blacklist, whitelist and reputation category. Click save. Now here you can see that obviously I need to go and target the VPN. So what I have done so far, that I have given the list of what are the things I want to blocking, and the web reputation is suspicious, whitelist and the blacklist I have given. Action is block the pages, and this is the block page content. Blacklist is enable, whitelist is enable, reputation category is enable inside the alert. So we have web filter, we have block page, and we have alert section. All these sections we have inside the URL. Now I should map this to the VPN. So I'm going to map this, say, for VPN 10 and 20 and 40. I want to apply all these VPNs. Save the URL policy, go next. Say URL plus firewall policy, and I should not use plus sign here, otherwise it will throw an error. URL and firewall policy, and again the same thing if you want to bypass the firewall if you have external syslog server. Otherwise go and preview. Now you can see here that we have long list that we can further discuss about. So firewall thing we know, we have already discussed about firewall. But in the URL thing that we have done the configuration, you can see URL filter name is URL policy for access, web category action block, web categories abuse, drugs, alcohol, cheating site, block threshold is suspicious, whitelist is Cisco, blacklist is CNN. Inside that we have the URL. For Cisco we have the URL, for CNN we have the URL. What is the block text? This is the text. What is the alert? I have chosen all the alert. Where is my target VPN? 10, 20, 50. So this is my URL policy. And now what I will do here, I will go to the template and I will attach this. So I will go to my branch 1 template and edit that template, and then I'll go to the additional template. In that I will go and add the policy that just now we have created. So let me scroll down. Okay, branch DIA, firewall, all these are the old policies that we have created. URL firewall policy, that's the policy we have, correct? Update this. It is uploading. Go next. If you want to see what is the policy that we are going to push, that will go and check. Unknown command at cisco.com. So I have chosen cisco.com, which is throwing an error. So what I will do, I will correct this Cisco URL that I have chosen, and then I'll come back to this particular place. So let me go back and correct that. Alright, so I have corrected the Cisco URL and I put www.cisco.com. Let us go here and add that policy that we have. So let me little bit scroll down and see that where we have our policy. So I can call here. can't see my policy. Yeah, now it is showing me. Yep. All right, update. Template is in lock mode, multiple edits. So same user has done multiple edit for this template, so that's why it is in lock mode. Never mind. We will wait for the lock mode till expired. Or other thing that what you can do, you can go to the tools, operational command. Say if I go here to vmanage, reset locked user, because the admin user is doing all the changes. So you can reset that, and then you can go back to the template, and you can go here one more time, and again you can go to the additional templates. You can go here, you can go and give the name. It was a URL policy update. Alright, so I need to log out and log in. Let me do that, and then I will go attach and update. So I logged out and log in, and let's click update. Now it is updating, and go next. I can go and check the configuration difference, because if any error will be there, it will throw an error. So it is not telling that we have any error. I can click side by side difference. Let me scroll down. So the zone based firewall configuration, that already we know. We have VRF definition, the RD, and that. Then here you can see that now we have the access list called the URL. In that we have object group for URL, object group for firewall, object group for source and destination. Then we have the class map for URL. And later with the CLI, I'll show you this in detail, that what type of objects we have. I'll show you the object as well. Then we have policy map, and then if I scroll down, we should get the list of the URLs and the categories that we are blocking and enabling. We have the virtual port group, that is for the communication from the data and the control plane. These are the old object group, I think. This object group is for ICMP. Okay. Then we have a parameter type, Cisco new. Inside that we have the pattern cisco.com that I have edited, Cisco to Cisco new. Then we have the CNN.com, and then we have app hosting configuration here, you can see. And you have this configuration that actually we are pushing from our GUI to the CLI, and then it will push to all the VRF, say for example VRF 10, 20 and 40. So here you can pause the recording, so from IOX, and you can go, and if you want to take snapshot, increase the size, font size, and you can check that what we are using. Although I will try to show you all these things from the CLI as well. So let's scroll down, scroll down, scroll down, and that's it. Click config devices. Yes, to devices. So meanwhile it is configuring the devices, I will go and log in via the CLI, and I'll show you from the CLI with some bigger font. So here I can go and show you the app host configuration. And still it is not pushed actually, that's why it is not showing. So we'll wait for 1 to 2 minutes while the configuration will get pushed. Or better, let's stop here. In next section I will log into the CLI, and I'll show you from the CLI as well. Once we push the policy, then we can go to the configuration and the security. Here you can see that device attach is 2, device template is 1, admin, and this is use case is guest access. Then I can go to the template, and yes, I have attached that. If you want to verify that, you can go this template and you can check that, yeah, That template is already attached inside the additional template. Here it is, URL firewall policy. Now next what I will do, I will go to the maintenance and security, and here we are using URL filter. Now you can see the branch 1, 2 devices, they are using the URL filtering that is reachable, that is virtual image is running. Means those images has been downloaded to these 2 devices. IPS is on 3, firewall on all 1, 2, 3. Now I'll go to the CLI and I'll show you the CLI configuration. So if I begin with URL, and here you can see that web URL, what is the blacklist, what is the block list, what is the block size, means what is the block name category, then block page, the global configuration, all interfaces. So how we are applying to VRF 10, 20 and 40, these URL filtering policies. Then finally you can go and check the app hosting configuration as well, that will be in the bottom, because now we have the GRE tunnel or app nav interface virtual port group that is connecting, or that is doing the communication from the data plane and the control plane where you have the LXC containers. Next what we can do, we can go to show UTT and we'll see the policy. So these are the policy that is applied. Again I can go to UTD and I can see some other options as well. So here you can see that we have web filter, say URL, profile. So we have those options. If I know the profile name, I can go and check. But yeah, this is the web filter. We have CNN, block list, Cisco whitelist, and these are the block categories that we are applying. Then I can go to the engine from CLI if I want to know that the web filter engine is running or not. That we have already seen from the vmanage. So the status is running. So these are the CLI verification command that I can go and check from CLI it is working or not. Let us see the feature and capabilities of DNS security, that is Cisco umbrella. If you see the traditional network, everything is backhauled towards the data center or the head office, and then all the mobile user, other branches, they are using the internet. But now we have actually shift. We have shift in the network due to the evolution of SD-WAN and so many cloud hosted application nowadays we have, like infra as a service, software as a service, platform as a service. So the companies, they want to directly go exit and use either the cloud hosted application or the internet. Like in both the cases, if you use those strategy, you will find that you are increasing the attack surface, because now your WAN interface is directly exposed to the cloud. So for that reason, the security is one of the major thing. And one of the powerful security solution related to DNS nowadays that we have is this Cisco umbrella. So you are exposed for malware, ransomware attacks, compromise attacks. You have less visibility to the cloud hosted application. There may be data breaches and the compliances. So for all these problems that we have when we are exposed to the public cloud, then we have Cisco umbrella security. How Cisco umbrella operates behind the scene inside the cloud, we'll see. But actually it was not Cisco product. Cisco has acquired company called OpenDNS, and then Cisco has done so many enhancement and improvement inside that. Now if you see that traditionally the network, in network you have your firewall, your proxy, your IPS IDS, your AMP, your antivirus, all those things you have, but still you are exposed to the internet where you may have malware, C2, say phishing attack, etc. So to protect from these, we have first line of security as a DNS security. Now DNS security is huge in Cisco at the moment. We'll see that how many users, how many requests, and what is the strategy that DNS is providing. In terms of deployment, what you have to do, simply give one URL or give one IP address or two IP address, and then your DNS will work. So now it will redirect towards the Cisco umbrella, where it will check all the categories like malware, C2, phishing, custom. There are so many categories they have inside that. We'll see all those categories, the list of categories we have. So what type of solution that DNS is going to provide us. Here you can see in the list that the DNS umbrella will protect when the VPN is off. It has a visibility and enforcement, block requests to malicious domains and IP, predictive intelligence. Not only it has the normal database, but they have the predictive intelligence as well. And already I told you that Cisco Talos is working behind the scenes. So data scientists, engineers with so many new innovations, they are working behind the scene to provide full tight security. And you can see the regions now over the globe. These are the regions at the moment where the DNS is applied. So for a user, he will go and check the nearby DNS gateway or DNS proxy, and then his data will process. So we can say that the DNS, we have zero added latency, more than 500 ISPs are supporting. Since 2006, it has 100% of uptime, 80 billion daily requests it is getting. How it is working, now you'll see the flow. So it is using latest technology, latest type of algorithm to provide or to mitigate from the threats or to provide the security. It is using C-rank model, that is the co-occurrence model. So identify other domains, looked up into the rapid succession to a given domain. It has NLP, that is the natural language processing, and AS matching, detect the domain, and that is spoof the brands and other terms. It has so many advanced techniques like live DGA, secure rank. It is using the spike rank. So suddenly if in certain autonomous system, the traffic will increase. And that means some sort of anomaly in the traffic. It has the predictive IP space monitoring, analyze how servers are hosted to detect future malicious domain. So you can see it's not like, okay, DNS security and it has some one or two feature. It has long list of features and it is keep updating its database. So that's why it's a #1 fastest and most reliable domain at the moment. 3 million plus daily new domain names discovered, 60K plus daily malicious destination identified, 7 million plus total malicious destination enforced. How it is applied and what are the other features you have. In terms of SD-WAN, I will go and log into the vManage and I'll show you that how you can integrate with the DNS security. What are the steps to integrate with the DNS? At the moment you integrate, you will get the network coverage, means instant visibility and blanket security protection. Bring your own device against Wi-Fi. Off network coverage for laptop. More user device granularity. Trial, if you want, you can do the trial as well. They are giving 14 days trial version. If you want to check that cloud, you can go and check as well. But the deployment time is very less. It will be less than 30 minutes to deploy it. Now here you can see the operational expertise and ensure reliability. So here we have only two examples. One is 1 to the nearest. So you can go and check what is the nearest DNS gateway you have. So instead of going 3 hop, I can directly go and use 2 hops. Then the other nice feature, because it has the collaboration or it has the tier up or tiering with so many ISPs. So it will not go and go to these many hops. If we see that, okay, I can directly peer with the next hop or peer with the other ISP who's near to the source and destination, so it will peer. It will not go to the multiple hops to reach. It is widely available at the moment. You can see the number is growing and every day this number is growing. You can see the availability of the network. It's 100% available. In our case, we are going to use inside the Viptela with help of vManage. So I will show you what are the steps and what are the things, what options we have inside that. We'll go and check all those things, but we can apply with the endpoint footprints, we can apply with the DHCP DNS integration, we can use anywhere. Alright, so let's stop here, and next section we'll learn more about and we'll see what are the deployment steps. In this section and the coming one, we'll see that how we can integrate our SD-WAN solution with the DNS solution. So suppose if you're sending the request on behalf of this request, the VH, they are sending their request in the encrypted form to the DNS. Again, they are returning that response. And then suppose if that request is legitimate, it will go to the internet, we can access, or it can redirect to the block site. That's the overall use that we have with the DNS. But you will see that DNS is not stopping up to this point. We'll find that there are so many other features inside the OpenDNS or Cisco umbrella. Cisco has acquired that company in 2015. Initially, it was termed or named as a OpenDNS, and now Cisco has rebranded as Cisco Umbrella. You can see here that what type of features you have. You have DNS layer security, you have web secure gateway SWG, you have cloud delivered firewall CD firewall, you have SaaS usage controls, that is CASB, cloud access secure security broker. You have correlated threat intel. So it's not like it's doing only the DNS security, but it has so many features inbuilt. So once you log into the umbrella console, in that you will find that you have options that you can create not only the policy related to the URL, but you can create policies related to firewall and other stuffs. Alright, so it can work as a full web proxy as well. And here you can see all these features that you can see here. So it can work as a proxy, means that capture all the web traffic with full URL, login and blocking capabilities, enforce acceptable use policy with content filtering and URL blocking. So whatever proxy that, say for example, blue code proxy, other proxy like that, it can work on behalf of the request as well. Then it has this feature called cloud delivered firewall, and you can see this CDFW. So it has a gateway, secure web gateway. It has the cloud delivered firewall. It can do the inspection for L3 to L4 as well, and again it can send that request to the gateway. So the request that is coming from the branch side going to the firewall for the port or L3 L4 inspection, then it is going to the gateway, then it is going to the SaaS, or if you want you can directly send the traffic to the internet or the SaaS. So both options we have. So finally you can see that this integrated solution that we have with the Cisco umbrella, we can integrate with our SD-WAN with help of vManage. We are going to create the policy. Once we create the policy, then obviously my branches, they are secure in terms of they are providing the DNS security, the firewall policies, the CASB, the gateways and others. Okay, so how in the first place you are going to enable this? First of all, you have to log into the umbrella site. From there, go to the admin and get the key from the umbrella, that is the API key. Once you have the API key, then go and open the vManage dashboard. There you have to do the registration with the umbrella. Once you do the registration, here you can see the configuration and the umbrella registration. Then you can go and create the policy. So you have option to do the local domain bypass. Then what is the policy behavior? What type of VPNs are attached? The DNS server, means there are some features I will show you that is by default there, and it's recommended that you use that feature by default or use those default features. So you have three sections only: local bypass, action, umbrella, registration. What is your target VPN where you want to put this? In the bottom, you can see that you have DNS server IP umbrella default. Then we'll go and do the registration here just to showcase that you need the registration token from your umbrella. You have to put here and then it will show you the configured. This is the umbrella dashboard. You have to go to the Cisco umbrella, go to admin, go here to the API key, and then you will get that key that you come back here and you have to put. So the umbrella and the SD-WAN, they will work together because of this API, and the behind the scene they will integrate. That's only thing that we need to do for the integration. Once you do the integration, then you go create the VPN list. If you have any DNS server IP, you can go and give that also. By default, you can use as a default umbrella IP. Once you create the policy, you can go and you can check show umbrella config from the CLI, show umbrella device ID, umbrella DNS script. Alright, and then further, if you want to see the configuration, you can go and check. So let's stop here, and in the next section we'll log into the vManage, we'll create the policy, and then we'll verify, we'll do the basic stuffs for verifications. Let us go and configure the policy. So you can go to the configuration and security. We are already at security. Go and add the security policy. This case, I can't use a compliance or guest access. I can use DCA or DIA, but let's go to custom. I will use one firewall policy and the umbrella policy. So you want to use firewall policy? Yes, I have the existing one. I'll go and copy this one. This is copy 8, for example, and then copy. Then I will skip all the steps. I will reach up to the DNS security. That is the last one. We are here inside the DNS security. Yes, I want to create new policy. Here you can see that you have target, you have domain list that you want to bypass, the policy behavior, what's the action, the umbrella registration. So first of all, I'll go and give the name of the policy. So for example, umbrella with firewall. Then I will scroll down. You can see that you need to do the registration. So here you have to put the API key that you are getting from your umbrella site. So that I have already put. Then I'll scroll down, match all the VPN. I'll do custom. Then it is telling, oh, go here and give your target VPN. So, okay, got it. I'll go here and add VPN, for example, 10 and 20. The DNS server IP by default, umbrella default. If you have any custom DNS, you can go and give that. Local domain bypass, yes, I will use one local domain that I have. I want to pass it, bypass it. So I'll go there and click. I have one domain that I want to bypass. And now you can see the policy. Let me minimize the font so you can see everything in single page. See how easy to configure it. Then save DNS security policy. We can go next, and in the final page we can go and preview. So this was nothing but umbrella with firewall policy that we have, and then the firewall action bypass and disable all those old options that we have. Let's click here preview, and if I scroll down you can see that we have the umbrella configuration, whatever that we have used for our configuration. Next, what I'll do, I'll go to the configuration and template, and I want to change the template for the branch type 3. So let's go and edit this. Here I want to put the policy that we have created. So we'll go inside the policy in the bottom, and let's go and give that. So what is your policy? This is umbrella with firewall update. Alright, let's click next. configure the device. Now it may be failed because I have given wrong API. In my case, I don't have any active DNS. So we can wait here. Now the steps that we have seen, that's the same exact steps that we need to follow to integrate my SD-WAN with the DNS or the Cisco umbrella. And then behind the scene, we know that what are the features we have inside the Cisco umbrella. So all those features will go and work. Once everything is okay, then we can go and check some of the CLI commands that we have. So let me log into the CLI. So if it is up and running, you can go and connect to the device. You can go and check show umbrella, and then you have three option config. So here you can see that you can see this is the resolver IP. These are the correct IP. So my API was correct. So that's why it is resolved. Then the device ID. So you can see the VPN 10 status request queue, and 401 is unauthenticated because inside the umbrella also you have to put these devices, and then DNS script. Here you can see. So now the DNS script is enabled, the public key, the certificate status, last successful attempt at this time. You have the script details, you have all the details. All right. If I go and check the configuration, so we can scroll down, you can see so much configured here already. We'll go down and we'll see our umbrella configuration. Let me increase the font size so you can see this, and yeah, 16 will be better. Alright, let me fix the screen. So what you can do here, either you can go and check parameter. Here you can see that we have done this configuration of umbrella with token, the local domain, DNS script, and this is the configuration that we have done. Or the other option you have that you can go and check running show SD-WAN running configuration and then the parameter. So here also you will get that configuration that we have done. Alright, so this is the way that we can configure our SD-WAN, means we can integrate our SD-WAN with the DNS security or the Cisco umbrella. Next we have use case 3, direct cloud access. Again, you can see that in this case users can go to the data center and it can access the cloud resources, or user can directly go to the SaaS or go to the cloud and access the resources. Now, for example, for security reason, if I have given this user the route from the data center, and what is happening, suppose if that link is down, so still it can go directly as well. So both possibilities are there. Means if I preferred that user that it always go via the DC, and then suppose if any problem with that particular link, it can directly go to the cloud or access the cloud resources as well. What are the things we have? Again, you can see the increase in the attack surface, because now we have 70% of attack that can be happen, means we are increasing the attack surface. But what are the options we have in terms of security? So we can do app aware routing, we can do app aware firewall. This app aware routing means that I can prefer via DC or I can go directly. I have option app aware firewall that we have already discussed earlier, how to create the rules in the firewall. We have option related to IPS IDS that we can do. And finally, we have option of advanced malware prevention or protection. So in this section, primarily, I'm going to focus on AMP. We know that now the things has been changed. Directly the users want to access the cloud resources. So they can go directly. If we go directly to the cloud, in that case, we can improve the user experience. Overall, we can decrease the capital expenditure as well. We are, securing the bandwidth, or we are not overutilizing the bandwidth, means going towards the backhaul or DC, and then we are going towards the cloud, rather than we are directly going to the cloud to save some of the bandwidth. So better use of the bandwidth, improve application performance, improve user experience, and then consistency, security policy and monitoring due to new SD-WAN security features that we have in the CSR and the ISRs. Here you can see that I can use app aware routing. So I have use case, I can directly go to the cloud, or I can go via the data center. Both the options we have. What type of security we are going to use? Security features we are going to use, we have IPS, we have DNS web security, we can use advanced malware protection. Obviously we have app aware firewall policy as well. So in this section, let's discuss about the advanced malware protection with threat grid. Now here also you will see that the Cisco Talos theme is here. The team is there to provide you latest signatures. What are the things we can do with help of advanced malware protection? It integrated with AMP, the file reputation, the file retrospection. So not only when the file is coming, it is going towards the AMP cloud with certain hash value, but it will check over the period of time. Say for example 3 days. After every 3 days you will see still the file is good or not. Obviously initially file reputation is there, but after that the retrospection will happen. Now we'll see that what are the methods and why it will go to the threat grid as well. So what is happening? Let's see the sequence of the actions. Snort file pre-processed on the device, identify the download, compute the hash, look up in the local cache. So first of all, the user request, it will check in the local cache with the hash value. So for example 01011. If no response is found, send it to the AMP cloud. If those hash value calculation of hash is not there in the local cache, then it will send to the AMP cloud. Now AMP cloud has three response. Either it's a malicious, block it, either it is unknown or clean. If it is clean, allow it. So for example, if it calculate the value and it find that, oh, I don't have the database, so it will mark this as a unknown. If it is a unknown, then say the unknown content will send to the TG, that is the threat grid. So if the content active content is found and config allows to export, it is going toward this threat grid sandboxing. It will go here. Now from the say thread grid, when he get the response, he will reply, and then again the file will mark as a clean and it will go. So here you can see the thread grid use as well, TG use as well. So WAN edge queries thread grid for a period of time and then queries AMP for retro inspection. Thread grid also update the new status in the AMP cloud. So behind the scene you can see your AMP cloud, your thread grid, both are working side by side. So first you are checking in the local cache, there you are checking in the AMP, then inside the AMP if the status is unknown, it will move or redirect it toward the thread grid. Thread grid all the time it will update the database, and the AMP and the thread grid will work together and they are doing the retro inspection. Okay, so these are the steps we have inside the AMP plus thread grid. In the next section, we'll log into the vManage and we'll do the configuration. We'll see that what's the GUI option, and then if we deploy this policy, you'll see that how it look like inside the CLI as well. So for example, what file types you want to check: PDF, Excel, Office, RTF, DB, CAB, etc. All those options we have. So we'll see in the next section that what options we have for the reputation and for the retrospection, and how we can go and apply this policy. Okay, so let's stop here and in the next section we will log into the manage and create the policy. Let us go and create the policy. So let's go to the configuration and security. Inside security policy, I'll go and add the policy. So this case, we go and check this direct cloud access. Inside that, I'll go and copy the firewall policy. So I have existing policy. Let me go and call that policy. This is copy number, say 55. Then we'll go next. So I don't want any IPS policy. I don't want DNS, but I want this AMP. So we'll go inside the AMP, create new AMP policy. Now here you can see in your page that target VPN, which target VPN you want to match this policy. So you'll go and click custom. Got it. Go and add the target VPN. So for example, VPN number 10. Then you have to select the AMP cloud. Then if you are going to do the file analysis, you have to select the TG cloud region and the file type. Then what is the alert label? It's a critical or it's a other. We'll see that we have 3 options inside the alert. So what options you have? You have critical warning info. Leave it as default. Let's go and give the name of this policy. So for example, this is AMP with firewall policy and yep. So now you can see the file reputation. Whatever the nearest matching cloud you have, you can go and use that. Then we have option. We can enable the file analysis. For that, I should go and give the keys as well. So let me go to the NAM. I should give this key. And then what file type? So for example, only PDF. Then the alert log label is critical. So now we can see that how easy is to go and configure the AMP policy. We'll go next and I don't want the DNS policy, so we'll go next. This is say AMP with firewall policy, and let me click here preview because I don't want to put this TG thread grid, so I'll go and edit that. Now you can see the policy. It's the name of the policy, the file reputation, where you are checking this, in which particular cloud you are checking the file reputation. You have file reputation alert, then file analysis, which cloud you are checking the file analysis, what is the type of the file, and what are the alert, which is your target VPN, VPN 10. So I can go and save this policy, but in this case, I just want to go back. I just want to go back in the policy AMP. I want to edit because I don't want to do the file analysis. So let's scroll down. I'll go here and disable this particular option. I'll go next, go next, next, next. So once you save this policy, you have to go inside the template and you need to attach inside the template. So for example, I will go here to say for example branch number 3 and attach the new security policy. So for that you have to go inside the edit template, go to the additional template, go click here to the AMP with firewall policy just now I created, update this. If you want, you can go and preview the configuration, but the same thing will come here. So I'll go click and push this. So this is the way that we can go and create the policy and apply to the devices. Now we are in the use case number 4, where you can go to your data center and you can access the internet, or you can directly go to the internet, or the user can go and access the cloud. So you can see that you have all those options, and this use case number 4 where everything is fully exposed. So now my attack surface is 100%. So we should use app-aware firewall, IPS, DNS, URL filtering, and AMP. So we are going to go and we can use DIA, or we can go and use this custom option. Both the options are open for us. So let me log into the vManage and let me show you that we'll go to DIA and we'll use that. All right, here I am inside the vManage, and before going there, in the last section we have done the configuration for one of the branch related to AMP. So let me go and show you that running configuration. You can go to configuration and devices, and then you can come here. You can generate the, or you can look into the running configuration. So let me scroll down there. You can see the UTD configurations. So here it is. You can see that we have the UTD configuration, file reputation profile, file inspection profile. Okay, so here we have all those policies that we have created related to our AMP that is showing here. Now let me go to the configuration and security. Let's create new policy this time. So this time I will go and create DIA, and interestingly we have all these policy created. So I'll go and copy the existing policy that we have created, say for example related to firewall. I'll give this copy as a 66, then copy this. Let's go next. I'll go to the IPS IDS. I will copy from the existing that we have. So I'll go and copy IPS for VPN 10. This is copy number 66. Then I will go next where I have created the URL filtering. I'll copy from the existing. What is the copy we have? So we have URL policy. I'll copy this. So likewise, I'll go next, and then we have the advanced malware protection just now we have created. So I'll go here and I'll copy that also. Now you can understand here that while you are copying all these, then you may note that that's why it's good to allow all those VPNs, means most of the VPNs should use this, or we should be very much specific about which particular VPN I want the cloud access or I want the direct internet access. So once I have all these policies, say policy, firewall, intrusion, URL, advanced malware, and DNS, then this is a DIA policy, direct internet access. Now you can see that I have firewall related option. I have IPS or URL filter or advanced malware protection. So all the logs, at the moment you'll add all the policy, it will come here and tell you, okay, you want to see this syslog message related to IPS, related to URL, related to AMP. At the moment, no. And suppose if you want to preview this policy, now you can see your policy. Now you can see the power of GUI. This many CLI commands, actually it's very lengthy and maybe we can do some mistakes, but now it's easy. From the GUI you can go and create that policy. Let's go to the template and the same site, that is nothing but my branch type 3 template where I'll go and edit the template, and inside the additional template let's go and push that policy related to DIA. So we have DIA policy, update this. We'll go next. If you want to see the config difference, now you will see that many differences inside the configuration related to old and the new, because this time we are using so many configurational changes. So if I scroll down, you can see the differences here. Let me scroll down. You have firewall rules. You should see the IPS rules. You should see the URL filtering. You can see the URL and you can see the DNS. You can see the AMP. So all these rules we have that we are going to push to the devices. So let me go and push this configuration to the devices. Let me scroll down a little bit. We have AMP policy. Alright, so click configure devices and we can wait till it push the configuration. So once it will push the configuration, and then we'll go to the configuration and devices. There you can go and select that particular device where you have pushed the configuration. That is nothing but branch 3. You can go and check the running configuration, and in the running configuration we can see all those configuration that has been pushed from the DIA policy. So this way we can go and verify our configuration as well. Alright, so let's stop here.
Now we reach to last section, that is section number 6. That weightage is 10%. In this section, we'll go and discuss about the monitoring option inside the vManage. Already we know that we can log into vManage dashboard, and from there we can see all sort of important things related to SD-WAN fabric. So let me quickly log into the vManage dashboard. So here I logged into vManage dashboard. At the moment you log in, you will see you have nice dashboard where it will tell you all type of different counters that we have related to the devices, inventory, application, etc. Here you can see all the counters related to your applications and all. Now here, if you want to go to the individual dashboard, so now here you can see that inside dashboard you have this main dashboard, then you have the VPN dashboard where you can go and take all the reports related to VPN, and inside that you can see that we can go and check the top applications as well. We have the details and we have the chart option as well. It's actually nice and easy to go and check that the top applications related to VPN, and we have counter from 1 hour up to 24 hours. Likewise, if I am running SD-WAN security features, I can go and check firewall, IPS IDS, URL and AMP related reports. And again, we have nice 1 hour to 7 day counter that we can go and check, and even we can do troubleshooting for that. So we have already discussed about the main dashboard. Let me quickly go and look inside any of the individual device dashboard. So here you can see that you can go to that main page here, and from here you can click up arrow and you can navigate. The other option we have that we can go to the monitor and network. Once you are inside monitor and network, you can select that individual device and you fall into that individual device dashboard. Now from here also you can go and check various type of reports. Now what reporting option we have inside vManage? We have this vAnalytic, and I'll cover that vAnalytic in the PPT. So let me go and open my slides. Alright, so we're back to the slide, and we are going to discuss about the vAnalytics, Viptela Analytics. What are the capabilities they have? But let's see that what are the things that vAnalytic can't do. Now suppose if you want granular report, for example, app-wise utilization report, service-based utilization report, IP-based report, import-export in a different type of file format, if you want some email, SMS, those type of features, then you can go and look for live NX or live action. Live action is again one product, a third-party product that Cisco is supporting. Initially, the support was with Cisco IWAN. Now inside Cisco SD-WAN and even the other vendors also this live action or live action NX is supporting. I have taken snapshot from their book, and you can see that what type of reports, what type of granular reports that you can fetch from live action. So you have long-term report, email notification, custom dashboard, all these things you can go and fetch from live action. Now, what are the things that I can get from the vAnalytic? We have actually three main type of report that we can fetch. We can fetch applications based report, network health, and network capability. Before even enable this vAnalytic, obviously you should have the licensing, and initially it was viptela.com, but now you can send email to Cisco. They will give you a username and the password.
Once you have username and password, and once your DNS is configured over VPN, because since this is the cloud reporting tool, your query will go to the cloud, get your report will get stored there, and from there you have to retrieve. So you should able to resolve the cloud. And even to enable this vAnalytic, what you need to do, that you should go to the dashboard. Let me quickly log into the vManage dashboard. Once you are here, you can go to the administration and setting, and there you should need the username and password, SSO username password, that you will get from the Cisco to enable the vAnalytic feature. So if I scroll up here, you will see that you have vAnalytic, that is disabled. You should go there and you should click enable. Should go with the username and password. If your username and password is as per the SSO, as per the Cisco provided username password, obviously it will get enabled, and then you can go and click launch the vAnalytic. So this is actually the process to first of all enable the vAnalytic. Once you enable this, then you have multiple options to go and check the reports. You have nice dashboard, and inside that dashboard, here you can see the dashboard. Inside that dashboard, you can go and check the application and the health of the network. So here you can go and check the multiple view or multiple report from this menu bar. You can go to menu bar and then you can check the network availability and applications and all in detail. On next session, I'll go and log into the dashboard and I'll show you that. So what are the things you have? Remember, you have three things: application, network health, network availability. So you can go and check the network availability, the edge uptime and the downtime, and you can generate the report and you can download those in PDF format. In the application, again, you can go and check who is the least performance, who is the consuming most bandwidth, what are the anomalous application families. Then again, the least performing, what is quality of experience, uh, which application is good as per the QoE. And here you can see the download button. You can go and download the report. So we have three things like application, network health, and network performance. According to that, we can go and have the reports. All right, so once we log into the vAnalytic dashboard, you will find that rest of the things will be actually very easy to go and check. Only thing that what type of report we needed. If report related to application, we'll go and fetch from the application. If report related to network health, we'll go and fetch the report, and we can select the counter. What is the time frame you're looking for the network health report? And finally, if the report belonging to network availability, you can go and fetch the report. You can select the time frame and you can download in terms of PDF. Okay, so after the applications, you have this network health. Inside network health, you will get which type of tunnel, what type of loss, latency and jitter. According to that, you can go and take the report related to network, tunnel and carrier. So you can go and select, you can generate the report and you can download in terms of PDF. Finally, you have network availability. For network availability, again, you can go here and you can check the aggregated downtime by sites. You have the counters, you can go back in the time. Then you have this download option. You can filter it and you can download the report. All right, so this is all related to vAnalytic. In next section, I will log into the vAnalytic dashboard and I will quickly walk you through all these options that we have. I logged in inside the vAnalytic. The same way you can go and launch vAnalytic. Once you launch the dashboard, you can see that you have this nice looking dashboard where you can go and check the network and the application related things. So on top, you can see that you have network and applications, network availability, you can see, then application best list, then quality of experience, loss, latency, jitter. If I scroll down here, you can see that you have the WAN performance, you have the application most consuming bandwidth. If you have any anomaly, you can check that. List performing application, that also you can verify. Now from the menu bar, you can see that you can check network health and availability, and in application you can check the bandwidth, performance, and the anomaly. So if I go and click health, you can see that health is coming up. You can see the performance by color. In the health, we can see the carrier, the edge, the tunnel. Then again, you have loss, latency, jitter, and you can check the time period. You can go back in time, and you can go and check. Here you can see the carrier, color, and the edge. So it's very nice pictorial representation for the network health and availability. Here you can go and check the availability as well. Likewise, we can go and check the application and the bandwidth. So once you are inside the application, you have three options. You have the bandwidth option. Here you can see which application using most bandwidth, and summary, time, and sites, and the counters. You can go and check the performance. So which application having what performance in terms of quality of experience. 10 is good, 0 is worse. Here you can see everything is having better performance, more than 8.5 or 8.9 plus. Rest of the application has good performance, and we are not seeing any anomaly inside that. You see how easy to go and navigate these reports, and we have network and application. That's it. So this is the walkthrough of vAnalytic. It's very easy. Once you have the login, you can go and check all these options related to network health and availability and applications. Next topic we have related to application programming interface, APIs. Now APIs, now they're getting the popularity. Why? Because if you see the evolution of networking domain, we started with CLI, command line interface. Then we have the GUI, that is graphical user interface. And finally, we have the application programming interface as well. Now the CLI is also good and fast, but with respect to GUI and the API, we can do things very fast. Even with API, if we do some bulk APIs call and all, this will become very accurate. There is less chance of human error, and it will be very faster. So to provide a speed up, we are using the API. Here we have the RESTful API for vManage. We can use third-party integration for API use cases or use. Even inside vManage also we have the Swagger API interface from where we can do multiple tasks. Here you can see important thing that we are using the RESTful API, that is the representational state transfer API that we are going to use. Now here you can see that we can do things with help of CLI, SSH, syslog, SNMP, netconf, but we can go and connect my vManage with the RESTful API. Once you are connected with the RESTful API, what are the things you can do? Actually, you can do each and everything. So you can go and use certificate management, configuration, device and inventory, monitoring, real-time monitoring, and troubleshooting. Everything is possible. Now, important thing here that you can see that while you're using these APIs, we have 4 different type of methods. So what are those methods we have? So we have method called put. If you want to update the object or an object, so update an object, you have put method. Then you have get method, that is something very much related to show command. If you want to retrieve the info of that object, you can use the get. Then you have post method if you want to create new object. So creation of an object, put this post, and then finally you have delete if you want to delete an object. So these are the four methods that all the APIs are using to do the things inside with help of API. You can see get, put, post, and delete. Now we have the resources, and if you collect those resources, you can think resource as a group of object or collection with a group of resources like that. So here we know that what type of task we can do with help of API. And here on top you can see in the chart that you have resource collection, and this resource collection for what? So for example, administration. So all the administration tasks, you can group all the related object for administration, and with help of API you can do this. So administration related to groups, viewing audit log, managing the local vManage server, etc. Then certificate management, configuration, device inventory, monitoring, real-time monitoring, and the troubleshooting. Now these objects that we are seeing here, because if you go and check behind the scene, these are the object, and then you are collecting same type of object. So these objects, they should have their format, and here you can see that the Viptela REST API uses the JSON data model to represent. We'll see later on that while we are getting the output, we are getting the output in JSON format. In JSON format, they have three type of data: scalar, array, and object. That's very much programming related that you can go and check. Now, once you log into the Swagger interface, you'll find that color coding for these operations. So delete will be red, get will be blue, post will be green, put will be brown. Like that you can see. Now how I can go and log into the Swagger interface. So for that you have to go and use this URL, your vManage IP, and then the API docs. So let me do one thing. Let me go and log in to the Swagger interface. So here I have my vManage dashboard, and what I can do that we can go and check API docs. So now it will redirect towards, on top you can see this API document, fetching the resources for API doc, and then you'll get the long list of things that we can do. So give him some chance to come, and meanwhile we'll go and check the slides. So you can go and log in there, then you have API calls, you can go and use the data store and services and call different type of things. So for example, if you want to see the OMP peering, how you can do. So let me quickly show you here that how you can go and build your own query, build your own API calls. So let me open the notepad here, and OMP peering, what I can do here, you can see that API is data service, and then the device OMP peer, and then you have to give the device ID, that is the system IP. So for example, 10.40.1, I want to check the OMP peer for this particular device. So let me do zoom in for, so you can see this, and all right. So like that you can go and create. I think we have our dashboard open, API doc page open. So let me quickly go and log in there. So here you can see the API doc. Now if you want to search OMP, you can go and search real-time monitoring and OMP. You want to check the OMP peer, here you can see you have the OMP peer, and as per our slide you can see that get is blue color, but you have different color. Delete will be red like that. So what you want to check the OMP pair for 10.4.0.1. You can go and query this. If you do the query here, you can see 200 means success, and then you have 400 bad requests, 403 forbidden, 500 is the internal error. Now here you can see that we got the request URL, and here you can see the output, correct? So this is the output. Who are the OMP pair? My OMP pair always will be the vSmart. So here you can see the peer and peer. Two vSmarts are my OMP pair. Now we are also making or building our API call. So here you can see we have this API call for OMP pair, and here you can see what are the things needed. Only you have to add the URL and port number, and that's it. So what I will do, I'll copy this and we'll go here and put here. Once you go and put, you can see that you're getting the result. And if you want to get the result in the JSON format, so let me use the other browser for the same. And let me show you the result in the other browser. Same output I ran inside this Mozilla, and here you can see that we are getting the JSON format. Inside that you have the header, so if you minimize the header, then you have the data value. In data value you can see that your peer is vSmart and whose IP is this is the peer, and then again you can see that your other peer is other vSmart and whose IP is this. So you're getting the result. Correct. Likewise, you can go and use any type of these API calls. So suppose if you want to check the DTLS or TLS connection, you can go and use this. So let me quickly build this one more time. So here we are, and now we can copy and paste as well. So what you want, you can see the DTLS and TLS connection API call you want. And here you can see you can go to the devices and then control and then connections, correct? So I can go and copy this, and this will be one of my API call related to. So now we have built our API call to check the control connections. You can copy and paste, and we are getting some error. So let me quickly go and fix this error. What we can do at this point of time, that we can go and check our vManage, and from where we can get this particular API. So I'm logging back to my API. Once I'll get my screen, I'll go and search the DTLS connection API. So here we have the search option. We can go and check, say for example, API for DTLS. So what we can do, we can go and check the control, and let's go next. You have this real-time monitoring control, and then if you go scroll down, somewhere you'll find that you want to see the number of control connection, and here if you go and give the system ID, and if you try it out, you will get the exact API you are looking for, and you can see that there is a small change in the API, so that's why we are not getting the correct result. Now I can go back here. We can go and put that correct API, and then you can see we are getting the result. So the control connection related to this particular device, you can see who are the controllers, means one is the vManage. This IP you can see, let me see the IP, public IP, and this. So this is the vSmart. Here you can see the peer type as well. So one VSmart, then VSmart number 2, then VSmart with other. So this is other VSmart with other transport. This is again the other VSmart, means we have two VSmart. And then finally you should have vManage as well. So here you can see the vManage over the MPLS. Alright, so this is the way that you can go and further check all types of APIs. So that means you can check the connection BGP. Then if you want to check the orchestrator connections, those you can see. What is the API call? What is the GUI equivalence? What is the CLI equivalence? Even we can compare all three as well. So for example, show orchestrator local properties is the CLI. Even in the GUI also we can go and check. And even the URL means the API call also you can go and verify. So in this manner, in this way, you can have a list that what CLI, what GUI and what API, and later on you can use only the GUI and the API calls. Even if you want to go and verify the OSPF related things like database, interface, neighbors, processes, etc., you can go and run these APIs call that we have built for two. You can build for the rest of them, and then it will work as it is. All right, so this is related to API. Next section we'll discuss about software upgrade. Now we are in the last section of this course, upgrade the images. Now the process is this, that you should upgrade the vManage first, and then the control device or other control devices, and then the edge device. The second important thing here is that a vEdge has to be equal or lower than the controllers. So suppose if you're running 19 as your vManage, then your vEdge can be 19, 18 or 17. But you can't have higher version for vEdge and lower version for the controller. Now what you can do that you can go to the maintenance. So let me show you this. From the dashboard, you can go to the maintenance and software upgrade. Once you go and open that software upgrade, you have the device list, you have the repository. Now inside the repository, you should have the image. So suppose if we are running image 17.1, just an example because nowadays we are using 19.2, 19.3. These are some old images, and just for example, if you're running 17.1 and you want to upgrade to 17.2, in your repository you should have 17.2 image. Now you have option that you have vManage or vManage or remote server. So you have these two options. What you can do that inside your vManage, you can go and put the image for vEdge and the controllers and the vManage. So now we have the image in the local file system. We can go and put all the images. Once you go and put all the images, that is 17.2. You can see for vEdge, vSmart and the vBond and the vManage. Then means all the images are there now with the vManage. So here you can see that we have two images. One is the running one and one is new image I want to upgrade for inside my repository. Now what we'll do that we are going to upgrade the vManage first. So we can go to the device list. Here you can see the device list, and then we'll go and click vManage. So here you can see that we are inside the vManage, and then you have to click upgrade. So now if you upgrade, it will ask you that which image you want to upgrade. Already existing is 17.1. I want to upgrade to 17.2. So we'll choose that, and then we'll click upgrade. Now once we click upgrade, obviously the next step you have is that you have to click activate. So first is upgrade and then activate. At the moment you will go and click activate. So here you can see that activate a new version of software vManage requires reboot, which will log out all the active clients and bring down the control connection. So now what will happen that the vManage will got a reboot, and once it will come back online, if you go and check Initially it was 17.1, but now it is showing that your vManage is running 17.2 image. So this is the way that you can go and upgrade the vManage. Once you go and upgrade the vManage, then you have to go and upgrade the vBond and vSmart. So next thing that you choose the controller, because already image is there. I have to just choose that, click to the controller, and then check mark which controllers you want to upgrade. Here you can see if you select all the controllers will get check marked, and then only we need to go and click upgrade. At the moment we'll click upgrade, it will ask which version you want to upgrade. You just check that and activate and reboot. So check mark activate and reboot, click upgrade, and you'll find that upgrade will be in progress. Once we upgrade all the controller devices, the same way we are going to use to upgrade the VH devices. So again, you can go to the devices, click to the VH, and then upgrade all these edge devices. And that's it. So nice and easy way to go and upgrade all your devices related to vManage, controllers, orchestrator, and the edge devices.
In this example, I'm going to show you that how we can redirect traffic from one link to other link, and this is very much similar to the Cisco policy or Cisco conditional policy maps. So the thing is, suppose this VH, actually this VH has to link with internet, and this particular interface has 30 Mbps of speed. What I want here, that I want to give 10 Mbps of speed, providing my high priority traffics. If my lower priority traffic exceed 20 Mbps, then it redirect to gig 0/1. Okay, so means what does it means? Means 10 Mbps is sure, but if out of 30 Mbps, if the low priority traffic will exceed 20 Mbps, then it will redirect the traffic. And the thing here is that we are using this with certain service VPNs. So I'm going to monitor my service VPN, say VPN 1, that is the step number 1 here. So in VPN 1, I will use one ACL to just track my incoming traffic, and once it reaches to a certain threshold, that is 20 Mbps actually here, then we redirect the interface. Okay, so let's see how we can do this. And for this we need actually two type of policy. One, we want local policy on a local VH interface, and one data policy I want in vSmart. Okay, so let's do it in our interfaces, in our devices, and I'm going to use VH1, branch 1 VH1. Okay, so let's do that. I can use policy, and this time the policy name is something say bursty traffic. I can use a rate, that is 10 Mbps, that is the committed rate we have. And then I can burst up to 20 Mbps, and even we can check that. Oh, okay, so we can burst up to 20 Mbps. I thought it will show that here you have MB or kbps like that, but it's not like that. We can burst up to 20 MB, and if my traffic exceed
So this time we are not going to actually drop it, but we'll remark it. We'll mark this, and then we can redirect on the basis of this marking in our vSmart policy. Okay. So what I can do, I can exit from here. I can create access list now, and the access list name, I can give any logical name here. So I can use something, say policy bursty traffic, but you can give any logical name. Sequence 10. I want to match my source IP. And what is my source IP that I need to check? That is in gig 0/1 interface. In VPN 10, I think gig 0/0 is our interface. So my source IP is something this. They need to use subnet, so use like this. This is my source IP, and that's okay. Now I have to set action on this. So action will be accept, okay, because I'm going to monitor this. And the policy, I have something called bursty traffic. I can exit from here. I can exit from here because I need to set the default action as well. Default action is also accept. Can I validate this? Yeah, I can go to top actually, and here I can check show configuration. This is my policy. Bursty traffic 10 Mbps, burst up to 20. Remark the bursty traffic with this particular source, and the action is obviously the calling of the policy inside the ACL. Now what I can do, I can go to VPN 10, my interface gig E00, and here I can use my access list policy bursty traffic, that's the name, and I can apply it to the inward direction. I can commit and quit. So if everything is fine, the commit will successful. That is the part 1 of this implementation. Now I have to log to my vSmart controller. So let me open my vSmart controller, and from there I need to use one data policy. I'm inside my vSmart controller, and here I can create my policy. I need to define my list. So list is my site list because I wanted to apply this on a particular branch with particular site ID, and here I can give any logical name. I am using the same that is there in the slides. So you can pause the slides, you can pause the recording, you can check the naming, but obviously you can use anything. So the highest priority routes, my site ID is for example 300 because VH1 branch 1 is in 300. After that I can create one more list, that is my VPN list, because WAN VPN, because I need to define my VPN as well. So I have two sides of my policy. One is the WAN interface where I'm going to apply this policy, apply this data policy. So that's okay. Then what I can do here, I can exit from here. So I have two lists. What I have done so far, I have one site ID 300 and I have one VPN 0. Now I can do one thing. I can create the data policy. I can give any name. So say highest priority. but you can give any name. Now here I can give the VPN list that just now we have created, and we can define the sequence. My sequence is something 10. I want to match packet loss priority, and that should be high, with the source IP we have. So I need to check my source IP here, and we have source IP 10.3.0.2 that just now I use it in my branch 1 VH1. So let me, yeah, this is my source IP. Okay, means this interface I am monitoring, and it's okay. We can do the action here actually. So action is accept. We can just check what other options we have. So we have options related to count as well. I can count, and you can see here we have a lot many other options here that we can set. And before moving further, let's see that what we have. So what I have done, policy, then site, then 100, VPN 0, highest policy, sequence 10. All these things I have done. I match the source IP, action is accept. Then I can use the counter as a bursty counter, and then I need to set the TLOC. Further I can apply the policy like this. Okay, so let's do all these things. Okay, let me go to my count, and here I can give any name. So just give something logical, bursty counter, like this. And here I can set the TLOC, and let me check what is the options I have. So I have option TLOC, I have option local TLOC, I have option local TLOC list. I can use, say for example, local TLOC color. Okay, so I can use this, and if you check the topology, you'll find the local TLOC color is actually red. So when the parameters are matching, then I'm setting this criteria. I need to exit, I need to exit, I need to exit, because my default action is accept. And from here we can check the configuration, because we have done so many things here. You can see here I have highest priority data policy. In that, simply what I am doing, I am matching the service side VPN traffic or the subnet. The packet loss priority is high. Action I am accepting, but count I am fitting for the bursty traffic. I'm setting the next hop. So if this condition will match, it will go to the next color, and that color is red with help of the local TLOC value. Okay. So once we are done, now obviously I can type top to go to the top. So from here we need to apply the policy to a certain site, and I have site name highest priority routes. Here I can use my data policy. My data policy name is highest priority, and from service side VPN. I can validate it. The device is being managed by vmanage. Okay, so I need to detach this device from the vmanage. Let's go to our vmanage template, and my vsmart is here. So I'm going to detach it. Pull this here, detach, and now if I do up arrow, validate. So before doing the commit, we can check the entire configuration. From top, I can check the configuration. This is my data policy, and this is my apply policy. Now I can commit this. Once the commit is completed, I can go to my branch. I can check show policy from vsmart, and now it is downloaded here from the vsmart, and now we have this output. Now we can check various options that we are not able to check initially. So I can check something like access list, then policy. Okay, that was one missing item in the last example. All these things that we can check now, there is no problem on verify all these things. This time we check the policy. Okay, so I'm good with this particular keyword section, and in this particular keyword section you can see that there are so many things that we can do in the legacy traditional WAN. Here we can do with some different methodology, but this method is actually quite effective because we can intervene all these things with help of the controllers as well, and obviously we have control to the vEdge devices as well. Those vEdge devices are our local devices in branches. Okay, so I'm good to close the queue section. I'll show you in the next recordings in the upcoming sections. See you till then. Okay.
Question number 19. It may be scenario based that the interviewer can ask you that suppose if I have data center 1, data center 2, 2 branches and 2 ISP, then you have to go and create a global policy or global rule, like branch 1 will prefer DC 1 and then fall back to DC number 2, and vice versa with branch 2 will prefer DC 2 and fall back to DC 1. So how we can achieve that? Now in this case, say for example, you have DC 1 and branch 1, you have one ISP, you have DC 2 and you have branch 2 as well, and you have other ISP. So your connection is like ECMP by default, equal cost multipathing. But what we can do at the level of vSmart, we can go and create the rule in a way that the OMP preference, so for example, OMP preference for DC1 will be, so for example, this is 500, and for branch 1, when you are applying the policy to branch 1, and in this direction you can give, so for example, 100. Likewise, for branch 1, you can go and give the OMP preference as 500, and OMP preference for DC1 will be less than 500, say for example 100. Then in this case, what will happen that for branch 1, the primary path will be DC1, but the fallback will be DC2, and reverse will be the case for branch 2, whose primary path is DC2 and fallback will be DC1. So with few lines of global policy, you can see that you can achieve this target, although this will be possible with obviously the routing uh, use case with BGP or maybe any other protocol. If we go and tune it,
In terms of SD-WAN, it's very easy to do it with the help of OMP route preference. Now we move to question number 20. Question number 20 is also very important and frequently asked question, that what is TLOC and what is the significance of TLOC? We know that transport locator is the glue factor. So your TLOC is the glue factor for the underlay and the overlay. So your overlay is nothing but OMP protocol. Say overlay, that is your OMP, and underlay may be any of the IGP protocol, but the key determining factor is transport locator. With help of transport locator, the VA Smart, they will go and reach out to the devices over VPN 0, or they will go, means this VS devices will go and create the data path, or they will create the IPsec tunnels. Now in this case, suppose if we have two different ISP and we can mark this as a color as well. So TLOC, let me write here, TLOC is nothing but transport locator, and they have three major attributes. They have system IP, color, and encapsulation. This color may be, we can think at this point of time, is the abstraction for any of the service provider or the carrier. Encapsulation is IPsec most of the time, and system IP is the system IP over the box. So the next follow-up question here is that, okay, what does it mean by restrict when we are using restrict? So to answer that, suppose if you have your VS device and you have two different color, you have color MPLS and you have color internet, and then the other side also they have MPLS and they have, say for example, internet. Now if you make this mode as a restrict, so MPLS will form the IPsec only with MPLS, and same is the case with the internet will go and form the IPsec tunnel only with internet. Now if we do not use the restrict, so there may be chance that MPLS, 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 internet, and internet MPLS. But in case of restrict, you have possibility number 1 and then you have possibility number 3. Okay, so that's the use case we have with the mode called restrict. Now we reach to question number 21, where the interviewer is asking that can VH/CH create IPsec/IKE tunnel with non-SD-WAN devices or cloud providers like AWS Azure? If yes, then what type of tunnel? Now this question is mix of many questions. So first question may be that either I have vEdge device, that's a Viptela box, or I have Cisco devices, C-Edge, over VPN 0 or VRF 0. Can they form IPsec tunnel, say with ASA firewall or Palo Alto or any of the other vendor device like Juniper or any other? So for this, the answer is no. They will form the IPsec tunnel over VPN 0 only with the same Viptela devices or with the same SD-WAN devices. The next question, so this is part 1. The next part is, so can vEdge CS devices can form the IPsec tunnel or IKE based tunnel at least with AWS Azure? Now again, here there is some difference. So CS devices, those are the ISR or other devices, iOS XE. And again, you can see the platform. So next generation Viptela devices are ISR 1110, which is supporting everything. They are like Viptela. But for example, ASR and ISR devices where you have upgraded the image and then you are using the uh, features or using the services of SD-WAN. So in that case, first of all, they are not supporting the cloud integration. So they are not supporting cloud on ramp based on software as a service, infra as a service. So no point of making the tunnel over VPN 0, but yeah, you can go and use the service side VPN to reach out to these clouds. Correct? Now, the next question, what about VH? Yes, VH and next generation VPLI devices or ISRs, they can go and create the IKE based tunnel with AWS, and we can monitor over the vManage dashboard. That's a two-year statement. With AWS, they are forming IKE version 1, but Azure, they can go and form IKE version 2 as well. Okay, so this is the answer for this particular question. Again, you can go and check the new release note. At point of recording, Cisco has already released 20.0 as well. So you can go and refer that as well. What are the features we have in 20.0 image? Question number 22. It is highly recommended that before going for a SD-WAN interview, we should prepare this question. What is the significance of OMP? Explain the best path selection in OMP. Now, the significance of OMP is that OMP is the overlay. So if you don't have overlay, then even there is no concept of control plane and data plane. So that's the significance of OMP, because it's the overlay for us. The other very important aspect of OMP is that the only protocol, and that is with respect to routing, that we as Smart understand is OMP. So the communication channel between VSmart and VH is only OMP. Again, we can frame this in other word. So suppose if the VSmart have to exchange routing information, have to push policy information, have to give or have to share the IPsec key information, all these critical information will be shared with respect to OMP. So OMP is a protocol who is helping VSmart to communicate to VS devices. And again, we know that with respect to VSmart, we can create certain rules. So if we tweak with OMP, and that's the global routing we have, or the global routing table we have. So if we tweak the global routing table, then we can do certain things like service chaining, traffic engineering, route blocking or filtering, etc. at the level of global. Now OMP is active within the VSmart and from VSmart to VH. This is not active in between VH to VS devices, and that's why the VS devices, they have local intelligence, because they don't have the global intelligence, means they can communicate with VSmart, but one VH with other VH cannot do the communication with OMP. They have to go via VSmart, or they have to get the information via the VSmart, and that's the significance and the distinction we have in terms of global intelligence and the local intelligence, and who has what type of role. Correct? Now the second question is that what is the best path selection criteria in SD-WAN? So for that I have few slides, and these slides you'll find we have point number 1 to 7. Point number 1 to 3 at least you'll find very much Cisco type. So first of all, you should have valid route, you should have validity of OMP, means OMP should have certain valid attributes to start with. Then the point number 2 is that OMP route is valid if it has been learned from same WebTeli devices. Select the OMP route with lowest AD. So we can think like this, that lower is better. So for example, OSPF and EIGRP, who will win? EIGRP, because it has lower AD value. Likewise here also the same type of point we can analyze. Then higher route preference, we know in case of BGP, weight and local preference, if these guys are high, then those routes has much weightage, those route has much preference to win. Here also the same case, and we have discussed this type of route preference in case of uh, local, and let me show you the question number. So we have discussed this in question number 19 as well, where if you give the route preference for branch 1 to DC1 higher, then it will prefer DC1 and then it will fall back to DC2. So first to second point, first, second and third points are very much Cisco type. Even point number 4. So first it will check the OMP route preference. If OMP route preference for certain routes are same, then it will go and check TLOC preference. Again, if the TLOC preference is also by default, you haven't set it, then it will go and check the fifth criteria, that the origin of route. So it's static, eBGP, OSPF, intra, IBGP, etc. And we know this is also indirectly related to AD value. So static route AD value is lower than eBGP, then OSPF, and then IBGP. So for example, 120, 110, and 200. Okay. Then finally, if all these point from 1 to 5 is same, then it will go and match 6, where it will go and check higher route, OMP route with higher router ID, and then finally it will go and check, means if all the criterias are same from 1 to 6, then it will go and check the higher private IP address of the OMP route. Okay, now suppose if 1 to 7 is same, so at that time they will go and do the ECMP, equal cost multipathing. Now there is one note here in this paragraph, in this block, that we should understand. What does it mean? So suppose once you have your IPsec tunnel up and running, that IPsec tunnel is associated with BFT. So BFT is going to track the liveliness of the IPsec tunnel. If the tunnel is up and live, then only they will go and install the fib table. Suppose if tunnel is down, if your BFT is giving some sort of complaint that the destination is unreachable, so at that time the edge devices, they will tell that VA Smart that I don't have destination for this tunnel. Then you can go and delete the entry for this particular destination, and that entry is nothing but the fib entry. So remember, there are different type of tables. There is OMP table, then there is routing table, and then there is fib table. That is the table that is used for actual data movement, and that's something ready to go tunnel or ready to go table. So from OMP table, the routing table will get derived, and from routing table, the fib table will get derived, and this fib table is tracked with the BFT. If BFT is complaining, that means fib will go down, but still you have the OMP and routing entries. All right. Question number 23. This is also very important, that what is the key difference between the control policy and the data policy? Can a control policy be a data policy and vice versa? This is very tricky. So control policy, we know that we have two type of policy. Let me write here. So we have control policy and then we have data policy. Now control policy is, say, first of all, unidirectional. This is bidirectional. Control policy will reside. So CAE, configure, apply, and execution, will happen at the level of VSmart. But for data policy, CA will happen at the level of VSmart, while the execution will happen at the level of VH. The third difference is that these data policy will be downloaded by vEdge devices, and they will be residing at the level of vSmart. So these are the basic three difference between the control policy and data policy. Now the next tricky question we have is that can a control policy be a data policy or vice versa? So the answer is no, it can't be. Control policy cannot become data policy and vice versa, but the same type of problem can be answered from the control policy and from the data policy. So what does it mean? So for example, one of the uh, policy service chaining, I can go and create with respect to control policy and with respect to data policy as well. Now, service chaining is that you are redirecting your traffic towards certain security devices like firewall, etc. If you create the service chaining with respect to control policy, then you have to apply it in two direction, or at least you have to go and create two policy into out to in. But the good thing about data policy service chaining is that if you go and create data policy with respect to service chaining or service chaining in terms of data policy, then you have to create it once, because data policy is bidirectional, applied in two direction. So the control policy and data policy cannot be exchanged, but the rules that control policy can do can be achieved from data policy. Not all the rules, but few of the rules can be done via data policy and can be done via the control policy as well. So now we move to question number 24, that is scenario based question, which is asking that we have to tell that how many OMP session and control connection with respect to vSmart1 in case that we have two data center, two branches, two ISP, each data center and the branches having two edge devices. We have one vManage, one vBond, and three vSmart, vSmart1, vSmart2, vSmart3. So what I can do, let me open the whiteboard. Let me draw the diagram. So as per the question, we have DC1. So I have DC1, two devices. We have DC2, two devices. We have branch 1 and we have branch 2. We have two ISP, ISP1 and ISP2, but we have one vManage, we have one vBond, but three vSmart. Now for this vSmart, I'll use different colors. So for example, I have vSmart1, vSmart2, vSmart3. For this vSmart, how many OMP connection? We know that OMP pair is forming within the vSmart. So he has two OMP pair within the controller or within the control plane. Then how many devices we have? First of all, how many sites we have? 4 sites. So 4 into 2 means we have total 8 devices. That means 8 here. So total number of OMP session that the vSmart1 having is actually 8. Then how many control connection? Question number 2. So control connection means that DTLS or TLS connection, that is purely based, we know that is based upon the number of ISP. So for example, for vSmart1, obviously he has the control connection over VS1 and VS2 and VS3, and if these vSmarts are separated across the controller, then that number will increase. So let's try to figure out that how many DTLS and the TLS connections we have. Let me quickly clean a few of the things. So OMP we are done, 10. Now let's try to do the calculation with respect to the TLS or the TLS connection. with respect to one of the VS1. So VS1 can go and reach to this and can reach to this over this direction as well, because you have ISP1 and ISP2. So that means that with one device he has two control connection. So you have total 8 devices into 2. The total number of control connection that he has with the edge devices are 16. Again, if we have VS1, VS2, VS3 and vManage1 and vBond1, then we should go and add the number of control connection with these devices as well. And suppose if they are separated across, although the question here is that they are in the same area. Okay, so in that case you can count at least one control connection here, one here, one here, one here. So depending upon number of ISPs if in between, otherwise 16 plus 4. So minimum they have, with this arrangement they have 20 control connection. Okay, so that will be the answer for this particular question. Let's stop. Having same scenario in the mind, now we have other question. We have discussed the question related to vSmart. Now the question is related to the same setup in terms of branch 1 VH1, how many OMP pair, how many control connection, how many data connection or data plane tunnel, that is the IPsec tunnel. In case if the site ID of the branches are different, plus in case if both the branch they have same site ID. Okay, so let's try to figure out this also. We can go back and delete our old diagram, at least few portions. So we have this type of topology, and then let me clean this. So this we have to answer with respect to branch 1. Let me try to draw one circle here for branch 2 VH. So this we have to answer with branch 1. Say this is VH1 and this is VH2. Alright, so VH1 and VH2. And likewise, this is branch 2, VH1 and VH2. Now here the site ID is 300, here the site ID is 400. Focus on this. How many OMP connection? We know this fact that OMP they will form, the edge devices will form only with vSmart. So that means 1, 2, 3. He has 3 OMP pair. Now the second question is how many control connection? Control connection is over 2 transports. So let me delete few of the lines here. When we are talking about control connection, to reach to vSmart 1, he can go like this and then he can go like this. So that means that 3 vSmart into 2 ISP, 6 control connection with vSmart, and then any of the link will be go and preferred for vManage. So 6 plus 1 means 7 control connection with the control plane devices. Now we don't have direct tunnel with vBond1, that is the transient tunnel. That means if anything will happen, then only the devices will go and contact with vBond. So that's why we don't have any tunnel, at least the active tunnel with vBond. So we have the tunnel 2 plus 2 plus 2 plus 1 means 7 control connections we have. Now the follow-up question here is that if we have different type of site IDs, yes, we have different type of site ID. We have site ID 300 and 400. So in that case, how many IPsec tunnel? So the answer is that if you have different site ID, obviously he will go and form IPsec tunnel here, and then like this. Again, it depends that the mode of color is restrict or without restrict. If it is without restrict, then we know that the combination is MPLS, 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 internet, internet, MPLS, and then the internet, internet. So assuming that the mode is restrict, so in that case, they will go and form tunnel like this. So how many? Let's answer that also. How many tunnels they will form? Let me draw here. So number of tunnels will be for this VH for this device is 2. So if the site IDs are different, your total number of devices are 8 into 2. So number of IPsec tunnel for this device will be 16. How? You just check one of the data center, DC1. So DC1, how many tunnels we have? 1, 2, 3, and 4. So 4 plus 4 plus 4. Since in these devices we haven't allow command like same tunnel within same site ID. So here you don't have tunnel because they are in the same site ID. So this calculation should be little bit corrected. Actually, the actual number of tunnels should be 12 if you have 3 different sites with 2 devices and 2 ISP. Now the next follow-up question here is, so let me answer this. Answer for number of IPsec tunnel will be 12, not 16. Okay. Now the next follow-up question here is that in case that the site IDs are same. So suppose here also I have site ID 300 and here also I have site ID 300. Then what will happen? Out of 12 you have to subtract 4 because same site ID will assume that they are in the same location and hence they will not form the IPsec connection. So that means your number of IPsec tunnels will become 8 in this case, and that will be the answer.